During this event, we will hear from experts, from innovators, and also from leaders who are shaping the future of water sustainability, from cutting-edge technologies to transformative policies. This conference is a platform for collaboration, inspiration, and also actions.
Indeed, and we would like to take a moment to thank, actually, sincerely thank our partners, the Saudi Water Authority, and all the organizations, the sponsors, the experts, the innovators, the individuals who have contributed to making this event not even possible, but remarkable. Your commitment to advancing water sustainability is commendable and deeply, deeply appreciated.
We had a great program yesterday, and actually we have an exciting agenda ahead today. So let's dive right in. Thank you all for being here, and let's make this a truly impactful event.
And now, Muhammad and ladies and gentlemen, we would like to move on to the announcement segment, where we're going to hear from leading organizations unveiling exciting new partnerships, initiatives, and also innovations. And these announcements reflect the spirit of collaboration and progress that drives the water sector forward.
الآن سوف ننتقل معكم جميعاً إلى فقرة الإعلانات لليوم الثاني على التوالي. شاهدنا العديد من الإعلانات هنا على هذه المنصة يوم أمس في حفل الافتتاح. أيضاً في هذه اللحظات ستكشف مجموعة من المؤسسات الرائدة عن اتفاقيات وشراكات ومبادرات نوعية ستسهم في تشكيل مستقبل استدامة المياه. هذه الإعلانات ستجسد قوة التعاون الدولي وتؤكد التزامنا المشترك في مواجهة التحديات المائية العالمية من خلال الابتكار والشراكات الاستراتيجية. لنبدأ تغريد.
لنبدأ يا محمد. Our first announcement is by the Saudi Water Authority launching the Water Innovation Oasis. Let's learn more about it through the upcoming video.
إذن يسرنا أن تكون أول الإعلانات لهذا الصباح تأتي من الهيئة السعودية للمياه، وهو إطلاق واحة ابتكار المياه. المزيد في هذا الفيديو.
The world is changing. And at the center of every change stands water, shaping how people live, how cities expand, how fields survive, how food systems endure, how industries compete, and how nations secure their future. Where water flows, life emerges. Yet it is no longer a resource the world can take for granted. And where water once set the limits, Saudi Arabia expanded the possibilities. Today, on the shores of Rabi, that journey takes a remarkable step forward. Rabi Innovation Oasis, the largest water research and innovation hub on the planet. Inside the oasis, ideas move through one unified ecosystem. Advanced laboratories, full-scale pilot platforms, and integrated innovation spaces. AI-driven systems predict a smart environment designed for focus, comfort, and discovery. And across the oasis, vibrant community spaces including sports areas, cafes, and social hubs help create a supportive environment designed to attract global talent. The Oasis hosts dedicated spaces for international partners in water technologies. The Innovation Oasis is the Kingdom's commitment to drive water innovation and to build solutions the world needs now and in the decades ahead. It is a global invitation to join the journey of shaping the world's water future.
Yes, and to make this applause even larger and bigger and more hearable, yesterday we've announced that this amazing oasis got a world record in Guinness by being the largest innovative oasis related, of course, to water research, water studies, and this is a huge achievement.
بالضبط كما ذكر التغريد وكما شاهدتم يوم أمس أعلن عن هذه الواحة كأكبر مجتمع بحثي ابتكاري مائي في العالم. ربما شاهدتم في هذا المكان شهادة جينيس تلمع لهذا الرقم القياسي الذي تحققه منظومة المياه في المملكة العربية السعودية.
So we would like to congratulate definitely the Saudi Water Authority on this phenomenal achievement. And the second announcement, ladies and gentlemen, is by the active membrane. And they're going to tell us about elevating the electroconductive RO membrane. To know more about it, together let's welcome to the stage the founder, Aryan Edalat.
إذن هذا الإعلان الثاني من شركة أكتيف ميمبرين والتي تقوم بتقييم أغشية التناضح العكسية الإلكترونية الناقلة للكهرباء. لمعرفة المزيد رحبوا معنا على المسرح المؤسس آريان إدالات. تفضل.
Well, good morning, everybody. This is a 3-year-old company that is trying to basically change how membrane separation is made by applying electrical currents to existing reverse osmosis membranes. We're here because a couple of years ago, we were one of the inaugural winners of the GPID at the time, and we have to thank our colleagues at Saudi Water Authority for giving us an opportunity to be able to pilot for an extended period in their beautiful R&D center in Jeddah. And thank you, everybody, and thank you for the opportunity. And we're hoping to continue our collaboration and looking forward to visiting the RABIC, the Guinness World Record Standard, later today. Thank you, everybody.
Thank you, Aryan, and of course, you're always welcome to Saudi Arabia and to the oasis. I'm going to actually join Muhammad. We should go to explore it together as well.
We will do.
Although we have nothing to do with water, but everyone loves water, and that's honestly, it is a shared responsibility that we all need to be knowledgeable about this topic. Water sustainability today is indeed a very vital topic.
I consider myself as one of those innovators in this event, actually.
Amazing. So, coming up next, ladies and gentlemen, is the announcement of developing and launching the first SIOTH, Domain Intelligent Agent, or the DIA, which is dedicated to the water industry, brought to you by the Saudi Water Authority and Integration Objects Company. Please welcome to the stage the founder and the president, Sami Ashur.
إذن يستحق كل تحية. يتفضل على المسرح للإعلان عن تطوير وإطلاق أول وكيل ذكاء تجاري DIA من نوع SIOTH المخصص للقطاع المالي. تفضل مشكورا.
Good morning. I'm very honored and pleased to be with you today, this morning. I'm very pleased to announce the launch of our new domain intelligent agent for the water industry that we developed jointly with SWA. It was developed on top of our Smart IoT Highway, which is a platform for augmented AI. This new agent is going to help not only operators, but from all the way to senior management, make effective decisions based on knowledge, based on AI-driven, and it will empower any water industry to make effective decisions, be in a predictive mode, optimization, detect water leaks, predict failures, guide operation to make effective decisions, and it will, more importantly, it will include expert knowledge based on the most knowledgeable operators' experience, based on federated AI, and based on generative AI. So this is really a unique and a game changer today for the water industry. Not only your users will not have to ask questions online. The system automatically is connected to the equipment, to the assets, and in real time it will detect the status of your operations and guide you for very effective decisions. So it has been an honor to work with SWA. We piloted the application for the water desalinations operations and water distribution, and it gave us really, really promising results. So thank you for your attention, and it's again, it's been an honor to be with you during the session. Thank you.
Thank you very much, Mr. Ashur, and congratulations to both on this successful partnership. And our next announcement, ladies and gentlemen, is by the Saudi Water Authority and Alliance for Water Stewardship to raise awareness about the water abundance, the sustainable water services, and exchanging knowledge and technical expertise regarding innovative approaches to the sustainable management, definitely, of water resources.
نعم، إعلاننا التالي سيكون بين الهيئة السعودية للمياه وشركة التحالف من أجل إدارة المياه للتوعية بشأن غزارة المياه وخدمات المياه المستدامة وتبادل المعرفة والخبرة التقنية بشأن المناهج المبتكرة للإدارة المستدامة لموارد المياه. نشاهد الآن تبادلا لهذه الملفات، ونشاهد أيضا بداية لشراكة استراتيجية مستدامة. إذن في هذا المؤتمر وفي هذه اللحظة تبدأ مرحلة جديدة للتوعية بشأن المياه، بشأن ابتكاراتها ومستقبلها واستدامتها. كما ذكر معالي يوم أمس أننا نحتاج المزيد، لأنه الآن 5% من منظومة البيئة في الابتكارات فقط للمياه.
Congratulations, and to more fruitful partnerships. Congratulations. Coming up next is another partnership with the Saudi Water Authority, and this time it's going to be with Torrey to develop a technical diploma program.
إذن إعلان عن تعاون آخر بين الهيئة السعودية للمياه، هذه المرة مع شركة توري، لتطوير برنامج دبلوم فني. بالمعرفة والعلم يبدأ كل شيء في هذا القطاع، بل أيضا في الحياة.
بالتأكيد.
شكرا جزيلا لكم.
Congratulations on this brilliant partnership. Our next announcement is between the Saudi Water Authority and the ABB Electrical Industries Company to design and develop educational activities for job-seeking trainees and other trainees in the water ecosystem field.
لدينا إعلان ما قبل الأخير في هذه اللحظات، هو بين الهيئة السعودية للمياه وشركة ABB للصناعات الكهربائية لتصميم وتطوير الأنشطة التعليمية للمتدربين الباحثين عن عمل وغيرهم من المتدربين في مجال النظام البيئي للمياه. شكرا جزيلا لكم.
Congratulations. And the last announcement for today brings the Saudi Water Authority with BW Water to create opportunities and to obtain rare academic qualifications, enhance credibility, job prospects, and cultural and scientific enrichment.
إذن آخر الإعلانات لهذه اللحظات وليس في المؤتمر يجمع ما بين الهيئة السعودية للمياه وشركة العناية البيئية بالمياه والصرف الصحي BW Water لخلق فرص الحصول على المؤهلات الأكاديمية النادرة ورفع مستوى المصداقية وفرص العمل والإثراء الثقافي والعلمي. نشاهد يوم أمس، ربما لاحظت تغريد، كنا نشاهد يوم أمس الشباب والشابات من موهبة يتحدثون بأنهم يرغبون أن يكونوا المبتكرين لمستقبل جديد في المياه. وربما لاحظتم آخر 3 اتفاقيات تلامس بشكل مباشر البرامج التدريبية والبرامج الأكاديمية والبرامج التعليمية. متفائلين بإذن الله بمستقبل رائع لاستدامة المياه، حيث تحدث معالي يوم أمس في جلسة الافتتاح أن الهاجس هو هاجس الأجيال القادمة، هاجس القرن ال21، وبمثل هذه الاتفاقيات بإذن الله التحديات يتغلب عليها.
بالفعل مثل هذه الاتفاقيات ومثل هذا الحدث الهام اليوم بالتأكيد نضمن مستقبل أجمل لأبنائنا وأيضا لكوكبنا بالكامل يا محمد. شكرا جزيلا لك. And with this last announcement, this segment comes to an end, ladies and gentlemen. Of course, we would like to congratulate all the participating companies and special thanks to the Saudi Water Authority for their efforts in creating a better world, as we just mentioned. More announcements are coming up in the same time tomorrow morning as well, so stay tuned. And definitely we have a very rich program and agenda happening on that stage and also in the next wave stage, Mohammed.
بالتأكيد أنا أدعوكم لمتابعة ما يعرض على هذه المنصة من العروض التقديمية والجلسات الحوارية، لكن لا تنسوا أيضا أن لدينا المعرض المصاحب هناك في قاعة النكست ويف ستيج. سيكون لدينا المزيد من العروض المتخصصة من الأحاديث حول الابتكار والمياه واستدامتها. أنا أغادركم، أترك معكم الزميلة تغريد وألتقي بكم هناك بإذن الله. شكرا.
حيا لمحمد.
شكرا لك.
Ladies and gentlemen, as we continue the theme for today, which is the future of water solutions, throughout the day we're going to explore how innovation, technology, and also collaboration are addressing global water challenges, and also they're at the same time paving the way for a sustainable future. To set the stage, we have a keynote presentation that will provide a strategic overview of the global water security challenges and the evolving water strategies. This includes insights into mega projects advances, specifically in the desalination and also the emergence of regional hubs, driving water technology excellence across continents. And now it's my pleasure to introduce our keynote speaker, Mr. Brian Harvey. He's the Vice President at Jacobs with extensive experience in water infrastructure and sustainability. Of course, Mr. Harvey is going to share his vision for a water-secure future, addressing the challenges of water scarcity and the strategies that are transforming the global water landscape. Please join me in welcoming Mr. Brian Harvey to the stage.
Good morning. Really delighted to be here today, Your Excellencies, distinguished guests, ladies and gentlemen. Thank you for the honor of being asked to present to you today on a subject which is not only really important to the world, but it's really important to me as well. I've spent over 30 years addressing the challenges of water around the world. I've been fortunate to live and work around the world, but really the water challenge is as real today as it was all those years ago. So I'm Brian Harvey, and I work for Jacobs. And whilst I have worked around the world, I'm living here in Riyadh at the moment and have been for the last 3 years, bringing solutions to the Vision 2030 projects, and really delighted to be with you today. So the presentation I'll be giving is really my vision on what I believe is the route to a water secure future, and that's around foundations founded on partnership between governments, private sector, communities of the world, and that's what I'll try and bring to life today over the next 20 minutes or so. So to start things off, look at this basic diagram, and I'm sure you've all seen this many, many times before. On the left, water demand, on the right, water supply, and water demand, as you can see here, is really dominated by the agricultural industry. Industry brings in lots of demand as well, and domestic, what we drink and use in our houses every single day. And that demand is something which is growing and will increase. And I'll come back to that in a short while. Water supply, as you know, is dominated by surface water in many parts of the world, groundwater, but also increasingly now it's supplied by good technology around desalination and also water reuse. But whilst these diagrams are very, very simple, it's the complexity of the detail behind these diagrams, which really makes the water industry so fascinating, but also creates so much opportunity for us all. And I believe the best way to bring together these complexities and solve these challenges of supply and demand is through partnership. So if I may, I'll take a bit of a history step back now over the last 200 years, just to illustrate how things have evolved and changed over this period of time. And I'm focusing here on global water, as I did on the last slide, and I'll narrow down a bit into some regional examples and some regional thoughts later on. So in the pre-1800s, so over 200 years ago, surface water was right at the heart of our water supply with wells and shallow groundwater. And that evolved then into the 1800s with urban water, more urban areas, more people moving into cities, and that created more urban water solutions. In the early 1900s, groundwater abstraction, deeper groundwater abstraction, became more and more common, and with that, more water treatment as well. The technologies and the science was starting to catch up with the demands of the day. The 1950s saw the first desalination plants come into the market, and really those deep aquifer sources of water, which really unlocked new supplies and delayed many of the challenges for many, many years. The 70s, we saw more environmental awareness, more groundwater depletion. We became aware that by just extracting all the time from the groundwater sources, we were starting to develop a problem. And then the next wave, the more efficient wave of desalination plants started to evolve. But the water resource management techniques, the ones that we started in the 90s, those are the ones which started to unlock the true solutions, I believe, those all-encompassing solutions to world water. Water reuse, water recycling started to come onto the scene, and then that unlocked a new wave of solution again. How do we keep water in the water cycle regardless of its prior use? And then on to the 2010s. Really the smart technologies came into play, and then resilient infrastructure, AI. Groundwater and surface water have been with us for many, many, many centuries, but they're becoming more risky with depletion of groundwater, with climate variance on surface water. And desalination, whilst it started off as a risky technology, I think now the world's becoming much more comfortable. And then most recently, reuse. Again, lots of initial challenges in terms of cultural acceptance and the like, but now becoming much more common across the world. So with that simple picture, I'll now look at this complexity, because one of the common features of all of that last 200 years has been the complexity change. And that complexity is likely to increase over the future, because there's predicted further population growth. Hopefully, the world will continue to have really strong economic development, and therefore more industry and more agricultural use of water will prevail and continue. Urbanization, I'm sure, will continue as well, as more and more people are attracted to work and lives within the cities. And if all predictions are held true, then the weather patterns and evaporation rates will continue to evolve. So that journey of challenge that I described over the last 200 years will most definitely continue with time into the future. Great. So I mentioned earlier the partnerships words and touched very briefly on why that's so important to me. But really the world of water has evolved over time to meet needs. And those partnerships that have evolved to meet those needs are very regionally focused. So whilst my 200-year review of the world of water evolution has really highlighted those big macro changes, I'm now going to start zooming in onto some of those regional partnerships, which have been so important to the evolution of the world of water. So, for example, if there's been energy scarce areas of the world, they've tended to focus on energy efficiency in the water production cycles. For areas of the world where there's real water scarcity, they've tended to focus on development of new technologies and new ways of creating water. And then in locations where there's been capital shortage or dollar amount shortages, they're focused on new ways of investment and unlocking those new funding streams into water. So the next few slides, I'm just going to zoom in on some of those partnership areas, which give me a lot of confidence there's a lot of great things happening, and really important that we keep those journeys of partnerships developing at both a regional level, but also at a global level. So I'm going to start now with the efficiency partnership, and lots of bright colors on this big screen with this one. And there's two areas of efficiency I'll start focusing on here. One is the operational efficiency, and I think you'll agree some of the work that's been going on in Denmark in recent times with wastewater and treatment plants, which our company's been involved with in the past as well, really has started to push the boundaries of sustainable water treatment by not only generating the clean water and that water we can use, but also generating surplus energy, utilizing the resources created through the wastewater production techniques into new nutrients use, chemicals, etc., etc. So a real level of efficiency that's been achieved there. The next efficiency I'll focus on is around construction efficiency, and I take these examples from real life examples in the UK, where and these three pie charts at the bottom of the slide there illustrate three elements of a water pipeline project. So the first on the left is pipeline crossing, so bridges effectively. Middle one is pump stations, and then the far right pipelines. And what the different color codes show is that in green it's what can be standardized, and in yellow was what required bespoke design solutions. And the interesting thing here, if you zoom across all of them, is that about 75% of what we produce in the water sector for this pipeline project can easily be standardized and the like. And that brings us enormous advantage in the design process, because it starts to operate or bring in cloning opportunities, standardization, a very, very much simplified design. During construction, it allows greater economies of scale. Rather than buying bespoke parts, we can buy en masse. And then obviously in operation and maintenance, we can also then bring efficiency, because it becomes much more familiar for operators to use a particular type of pump or a particular type of valve and making those replacements. So now all of those are important, but I think that the final point on this slide I'd like to make is that the importance of whole system efficiency, because any one of these points, be that operational efficiency, construction efficiency, can exist, but it can be so easily lost, either through non-revenue water or through some other inefficiencies elsewhere within the distribution system. So it's really important that we not just think about those individual component parts of efficiency, but also the whole system-wide efficiency as well. So the next area of partnership I'm going to briefly focus on is that of technology partnerships. And I'll focus on three areas. And going back, if you remember back to that 200-year slide I had earlier, these three areas are right at the heart of the water technologies and water growth over that two-century period. But the big challenge is, how do we protect the groundwater? How do we scale up desalination? How do we scale up reuse? Because that's right at the heart of dirty water, and then treat it to very, very high standards of quality, and then pump that water back into the aquifers of the world, where it's then held for many decades before it's then taken back into circulation again. That's the more sort of distant view of groundwater, and very much linked to the third point here of reuse. So really important technology, really powerful techniques, but one that we now have a way forward, and both in Western Australia and in Orange County in the US, in California, there's really powerful examples there of which give us great confidence. The next area is around desalination, and where better place to look than here in the Kingdom, where there's enormous capacity being developed to meet the future demands of the Kingdom and all it entails. Certainly, living in Riyadh, and are very aware that desalination is such an important part of the water supply to my house every single day. But here in the Kingdom, as well as capacity, has really been driving new approaches and techniques. Obviously, the first one being from thermal to the RO type techniques, but increasing use of renewable technologies as well. And both the examples there I share. The top one there, Rabib, in the 600,000 cubic meters a day capacity, is an incredible capacity, which proves that desalination works at scale. And then the second example there I showed, Jeddah, is very much highlighting the potential that comes from energy efficiency and those new renewable sources, be that solar or wind, that are with us today. So no question in my mind that there's a scalable solution here for desalination wherever it's needed in the world. And the last area I'll focus on is reuse. I'll give an example here in Singapore, which has, I think, been shining the light for many years in terms of the multi-taps, the 4 taps approach, rainwater harvesting, imported water by pipelines from Malaysia, and then new water, which is the reuse production water. Combine that with desalination, they've got a very much improved water supply situation, one that's given them enormous economic growth over the last 50 years or so. So we've got groundwater solutions, albeit in very few locations of the world. We've got confidence that desalination can be scaled up, and we've got confidence that reuse now works and is an integral part in some nations of the world. So I think the technology partnerships have proved themselves, and I think just looking around the conference over the last day just shows how much new technology and how many new bright ideas are there coming to the market and bringing solutions, further solutions to us all across the water world. So the last area of partnership I'd like to focus on is investment partnership. And here I'll go to a project in the UK which is just recently completed and is the Tideway project. And this is the project beneath the River Thames, which collects excessive water from the drains and the wastewater pipes of London and prevents it falling into the River Thames. So at its heart, it's an environmental cleanup project, but really it's a wastewater collection system which takes water along a 24-kilometre tunnel into a wastewater treatment plant to the east of London. Now, the reason I mention this, and not only is it an incredible engineering project, but my mind has started to bring different funding sources together. Now, at the moment, we're segmenting that investment, and on occasion, I think we're probably not optimizing the investment spread across both the public and private sector funding sources. The philosophy, I believe, in Tideway was it changed that dynamic, moving it from segmented investment to one of seed funding coming from the public sector, if I take this to its most simplest form, which then de-risked the project for private sector investors to come in and make a difference and make this project viable. So with the Tideway project specifically, it was the first of kind project, deepest tunnel ever in the London, below the tubes, below the River Thames, and below many billions of assets above ground. And that risk had to be de-risked, proof of concept had to be delivered, and then the funding mechanisms really started to flow. And the ultimate test here is not just that the project was built, but it also drove an enormous saving for the customers of London, in excess of 60-70% saving on the customer bill from that originally predicted before this new way of funding advances happened. So this is a project which I've tracked for many years, and it was so good to see Andy Mitchell, the CEO, and others there opening that project. Not just the engineering marvel, as I say, but on meeting those new investment solutions that I believe the water world needs. So to draw this conclusion, thanks again for having me here today. I hope this has shown some light, not only on the most complex issues of supply and demand, which are like to become more complex, but for me, hopefully, starting to share real confidence and optimism that the technology solutions are absolutely there, and those efficiency partnerships, those technology partnerships which are shared around the world. Now, if we can scale them up and connect different parts of the world together, we can all learn from each other. But also to how important those global solutions can include the investment solutions as well. I'm sure there are many more innovative investment solutions out there, but the one I presented today, we now have confidence that it's not only delivered the solution for London, but it's also got so much potential anywhere else in the world that I look. So with that, I'll draw it to close. Thank you so much for having me once again. It's been a real honor, and hope you enjoy the rest of the conference. Thank you. Thank you.
Very much, Mr. Harvey. Thank you for that inspiring and very insightful presentation. Your vision, actually, Mr. Harvey, we would like you to remain on stage, please. Yes, because we would like to present to you a token of appreciation on behalf of the Saudi Water Authority as a thank you gesture for your attendance and for sharing your knowledge with us. Thank you very much. Thank you very much, Mr. Harvey. Ladies and gentlemen, in alignment with their goals of advancing the water sector, the Saudi Water Authority published a report in partnership with Oliver Wyman that's going to take us into a comprehensive look at a future of infrastructure, digital transformation, circularity, and also how it's shaping water management worldwide. I don't know if we have the QR code ready so that our audience can scan it and take a look at that report. If it's not ready, I briefed you for that, and then we will have the QR code ready for you after the upcoming session. Our next session is a panel discussion that explores how smart city ambitions are driving the adoption of advanced technologies in water networks, from the SCADA systems to the AI-based leak detection, and also the digital twin applications. Our upcoming session, ladies and gentlemen, is going to highlight the real-world impacts and the opportunities for innovations And moderating this discussion is Christopher Gasson, the Executive Director of Global Water Intelligence. Let's welcome him and his panelists to the stage.
Okay, it's great to be here. I've got this fantastic panel. We put out a memo that on Tuesdays we wear pink. I got my shirt, and it's not Wednesdays. I mean, I don't know if there are any mean girls out in the audience and you understand the reference, but it's Tuesday, and I've got a pink shirt and she's got a pink suit. And we're not going to talk about pink. We're going to be talking about smart water systems. And I guess that the meaning of smart water systems and the meaning of smart water is something which has evolved over time. Now, you know, AI is very much part of what we mean when we talk about smart water. But I thought we'd start by asking each of our panel what they think of the meaning of smart water. So I'll start here with Arthur. I can't pronounce your name straight off.
Arthur Valkiezer.
Valkiezer from Hydroloop. And Hydroloop is I'd call it decentralized water reuse, but what does smart water mean to you?
Well, smart water use for me means that on one side we offer inhabitants to maintain their comfort of living and at the same time substantially reduce their water footprint. And this can easily be done by recycling in every building, in every home, the lightly contaminated grey water, like shower water and condensation water from the air conditioning systems, and then reuse this for those applications that you don't need tap water quality for. So this is in-property water recycling. And by combining this with smart systems like AI, you can actually, here in the Kingdom of Saudi, the water consumption per capita is 230 liters per person a day. And this can easily be reduced with almost 50% by having a water recycling system, a low-cost water recycling system in every home, in every building. That's smart.
Okay. No, I hope that there's some people here from the National Water Company and property developers who understand the opportunity in this, because historically the water sector in this country has been very centralized around the water production through desalination. But I think that you're right, that the smart opportunity really is in this, this decentralized household level water reuse systems to make sure that all of the water that is supplied by the centralized systems.
Yeah, it's like an upstream intervention. So it reduces energy and water usage on both sides of the point of use. It is the production of tap water, it's the distribution of tap water, and then it goes to the point of use. And there, where it becomes wastewater, you recycle it and use it again and give it a second life by reducing the wastewater stream that goes to the wastewater treatment plants. So the ecological footprint of recycled water in a building is much lower than the production and the treatment of tap water and wastewater.
And what proportion do you think can be reused in grey water systems? I mean, if you've got a supply coming in, I mean, typically what proportion is
about 40% of the in-house use. Yeah, can be reduced, yes.
I see. Okay, so
you can build 40% more homes with the same technical setup.
Or indeed avoid building 40% more desalination plants.
Exactly, and wastewater treatment plants, yes, exactly.
Okay, that's a huge and smart opportunity.
Yeah.
Now, what about you, Victoria? What does smart water mean to you?
Well, thank you very much. It's an honour to be here. Well, water in itself is very smart. I think humans are still catching up. So smart water, to me, means we have to be better and brighter custodians of the world's most precious resource than the previous generations. And in order to do that, we need to enhance and embrace technology. We need to enhance and embrace best practices of before. And we need to work together to deliver an outcome to protect the world's most precious resource. When we are facing a shortfall between supply and demand of 40% by 2030, we have to do something. When there's been a 500% increase in conflict over water since 2010, we have to do something. So we need to get smart, not water. And I think there's enough great technology out there, but in silos it won't work. So the great technology we've heard for here has to be part of a bigger systems thinking approach to the whole water cycle, not just at the municipality utility level, but actually at the watershed level. So how is the use of water, whether it's agriculture, whether it's for consumption, whether it's for manufacturing or industry or public consumption, how is that related to population migration, climate mitigation? And I think using the power of new technology, the power of the new buzzword AI, and we won't go into what is AI and what isn't AI, but how you put that together with the myriad of sensors, the myriad of applications into a holistic whole that gives us data that we can actually action on to become smart, to match water smart, and make sure we create and help deliver a water-secure world.
That's very broad, what you've just answered. Can you say something a bit more specific?
Okay.
People, I know you don't want to give
so,
a pitch
yeah,
Friday, but,
this is my pitch, non-pitch.
Yeah, exactly. No, it's not a pitch, not a pitch.
Christopher.
Just try and be a little bit narrower. So
Okay. Christopher, as it's you. So FIDO has a very simple mission where AI, water and impact, that's economic impact, social impact and environmental climate impact. And what we do is to look at a water network and eliminate non-revenue water by using acoustics and AI and generative AI, two different forms, to find any leak on any water network, rank it by size, look at the asset condition, do event probability of where the next failure is going to occur. But most importantly, we verify that the repair has been done. Because if you don't act on the data, you have no impact. So we give that volumetric audit trail from identification using on a simple DAS model with easy-to-use sensors to find, locate, and most importantly, size leaks, identify instances of theft, look at consumption profiling, so you could then look at how to encourage better water use, all through the use of our FIDO AI system that we started 6 years ago.
Okay, fair enough. Isn't that the easy bit, though?
For me, the easy
Well, I don't know. What I'm thinking is that, for a lot of places, it's not, as you say, finding the leaks is one thing, doing something about them is a different thing. And you don't actually do anything about them.
Oh, yes, we do.
So
we don't have Christopher, we have, yes, this could be a good panel discussion. So what we do is identify the largest leaks. And this comes into smart cities. You don't want your roads constantly dug up for the small ones. And we check the repairs being done. Let's give you an idea. We checked one repair book of one very well-known global, on the global stage, water utility, very advanced, often looked up to, and 62% of the repairs that were done and were paid for had either not been done, had created a secondary leak, or hadn't been repaired properly. So we play a vital role in ensuring that impact. But no, I don't own a shovel and I don't do the dig.
I see. So that's not the smart part.
Yeah.
Okay. What about you, Sarp? Now, you're probably the only person here who's sort of more of a pundit, i.e., you've got an overview of a lot of different technologies as being an advisor on innovation to SWA. You must see a huge amount. What do you consider smart? And
I think when we start talking about smart, the most important thing that we need to understand reliable, continuous data, and that's one of the biggest problems we have. If you look at the Saudi water ecosystem, we are from source to tap and then tap to, recycling. It's a very big and very large ecosystem and very sparsely, populated area. So we have a lot of different issues, and one of the issues we have is the reliable data. We have networks from like 60, 70 years ago, and they're attached to networks like recently made, a couple of years back. So understanding the network is the most important for smart water, how we approach to smart water. And we are looking for very many different technologies, FIDO being one of them. We are looking for different technologies, different applications. Our main focus to approach to smart water, first we understand the network, establish a real-time, continuous and reliable data, and then the next stage go for AI. So we are trying to do it step by step instead of, attacking directly to AI or smart systems. So we are trying to start from the infrastructure, understand it, put the, reliable systems on site, attach them to reliable DMAs, properly isolated, etc., and then use the sensors, integrate them to SCADA. So we have a very good plan. Of course, we have challenges, but I think the smart, when you say smart, data, reliable data, I think is the first and most important thing for us.
And that seems to be a huge challenge in this country. I mean, if you think about historically how the National Water Company and before that MOE managed the networks largely through contracting out to contractors, there must be huge areas, which are completely blank on the map.
We are closing the gap. Yes, you are right. We have some missing data from SCADA, from everything, but we are closing the gap, and there's a lot of investment in the country especially for the network, water network system, not only for distribution but also connection as well. So National Water Company, we work very closely with them, and they've been doing a lot of investment on the understanding the network better and making it reliable for everyone for a long time. Yeah.
And how does it work with you being responsible, or SWA having this responsibility for overall innovation in the country, and then the National Water Company actually doing the business?
We do a lot of small projects, piloting projects. So we have one in Medina, we have a couple of them in Riyadh. We work with the NWC teams on the site, and then we bring some of the companies that we think they are worthy to try. So we have a collaboration. We are not sitting on top of anything, so we work with the stakeholders. Same with the Saudi Irrigation Office, because they take the treated wastewater from NWC and then they use it for irrigation. So our job is to work with all the stakeholders and to find out what is the reliable technology around the world, how we can implement in the conditions that we have here, and work with the stakeholders, pilot them, and then see if they want to continue or not. So our job on the innovation is to find the most, applicable technology and how to utilize them in the country.
Okay, no, that's great. So moving on to Asim, you have fluid analytics, and I guess that this is sort of more on the wastewater side than the drinking water side. So I guess between Victoria and Arthur, the bit that is often forgotten. Now, what do you consider to be smart?
Thanks a lot. Pleasure to be here. For us, smart water is situational awareness. Looking at the catchment as a whole and not just individual assets. Often we see cities struggle with fragmented data. Looking at just flow data to model hydraulics, looking at CCTV data to understand defects in pipes, but no single system really to look at sewer stormwater as a whole, understanding where systems are going to fail, where is the next flood likely to occur, and the public health risks associated with it. So, and and very often more sensors is not really the answer. Building an intelligence layer on top of existing infrastructure that's already there. I mean, even in countries like India, which are still developing, we've got thousands and thousands of kilometers of pipelines in tier 1, tier 2 cities. So being able to look at all of this data holistically and then going in and building the analytics that's needed. So AI to inspect thousands of kilometers of pipes, doing it 10 times faster, using IoT sensors to predict floods, and then autonomous boats in waterways to understand the potential source of contamination, where it's coming from. So really looking at catchment as a whole is how we see it.
And just being more specific about how you work, and can you tell us the story of a project where you've really delivered value to your customer in this?
Oh, absolutely. So the great thing about working with existing data sets is that we can operate anywhere in the world. So we're based in California, but we've got projects all over Singapore, India, South America. One project, and over the last few years, we've usually been working with a single data set. So if there's CCTV data, the US generates about 10 million hours of CCTV data every year, and is reviewed manually by trained technicians, and we're still not able to solve the water pollution problem. So we've sort of worked in silos with these data sets in the past, but recently we've started deploying it across an entire city. So one project that we're doing with Mumbai City is looking at deploying AI for condition assessment of sewer and stormwater, looking at areas where we feel hydraulic capacity might be impacted because of silt, because of other reasons, going in and then deploying IoT sensors in specific hotspots, understanding how the system's performing, have fixes impacted the hydraulic capacity of the network, and then having small autonomous boats moving around either the coastline or certain rivers inside, being able to track that back to the source of the contamination. So if we detect the water quality being off in specific areas, tracking that to the stormwater drain that's discharging, taking that back to the sewer network that had broken, that was causing overflows into it. So being able to do this as a consolidated system, I think gives multiple stakeholders the visibility that they didn't have before. I think that's really been a game changer over the last
I mean, just trying to sort of summarize what the value that you create here is. You've got a whole load of sewers which the stormwater gets into, and it creates or drainage systems which the wet sewage gets into. Yep. And by understanding where the problems are, you are essentially reducing pollution, and that's something which is presumably regulated or something that the city needs to worry about.
Yeah. Often the solution is not new infrastructure, it is optimizing what you already have. So if Mumbai City, for example, has 3,000 kilometers of sewers, unfortunately not a great stormwater system because you have a lot of open drains that discharge into either the sea or inland rivers. Being able to really look at where contamination is happening and where interception diversion should solve the problem. So it's looking at the water body and then working backwards. So if you're able to prevent a stormwater drain from entering the river, just intercepting and diverting it to existing sewer systems to treatment. Because existing systems are at about 40-50% of capacity. So there is additional capacity available in these systems. So being able to just rewire the network, optimize existing systems using data. And you've seen that in Mumbai, I think in the last about 4 years, we've been able to get the city to divert over 400 million liters a day of raw sewage that was getting dumped into this one river that runs through the center of the city called Mithi River. So, yeah.
I see. Okay, no, that's great. So moving on to Engineer Rashid, who's from SWEC. What do you consider smart, or
Okay, thanks our moderator. I'm pleasure to be a part of this session today. Smart water means for me transforming from the reactive system to proactive ones driven by data and digital technologies. And with this accelerating of ambition of the smart cities, the water has become the cornerstone of the sustainable infrastructure. I think the challenge, not the ensuring water supply for the cities, for the customer, but managing it smartly. And due to this, some global estimates about network leaks of the cities, there is some number reach about 32 billion cubic meter annually. The cities lose the water due to leaks of the network or inefficient network. And this is why smart system emerge as a fundamental solution to make balancing between water security and economic and environmental sustainability. The foundation of this smart system will be the SCADA system and advanced SCADA or DCS system. This is the foundation of the smart system, and there is too many tools of AI you can implement it in the whole water supply chain, start from production, transmission, distribution, and reuse. And we make success story in water desalination at the Kingdom for this AI implementation. We can also invite all attendees to visit our booth in this hall number 2 and they see the innovation practices and the AI machine learning we are implemented in our plants. Water desalination is the operational arm of SWA, and we are operate more than 170 plants in the Saudi Kingdom, Saudi Arabia. Our capacity 11.3 cubic meter daily. This is covering 70% of water supply of the kingdom, and we have to engage the smart system in our plants for sustainable the service and water delivery to the customer.
Mm-hmm. And I'm just thinking, as somebody who's sort of working at SWA, you put such efforts to making this water. I mean, you have this incredible sort of history of desalination and, advancing the science and so forth. Does it sometimes frustrate you that you make all this sort of fantastic water and then it goes into the networks and goes into the distribution system and it all gets lost? How do you feel about that in SWA?
We are concentrate on the production resources, and we are making the efforts for this, our reliability of the continuous of production. Also, some area like maybe, I don't know, outside the Kingdom of Saudi Arabia, if the plant production closing to the network, the integration between network and the plant operation will be more benefits for the sustainable and operation and forecasting the demand. But here in the Kingdom of Saudi Arabia, the entity take care about each part of this whole water chain. Production, there is another entity, also public and private. Transmission, there is another entity. And each components of this water chain, there is opportunities to implement the smart systems and improve the efficiency and satisfy the customer. For desalination plants, like AI machine learning, we are apply this in our plants for chemical dosing automation and observing the membrane of RO technology of the pressure of the membrane. And this is applied, we are talking about 4 twins. This is applied in the Ras Al Khair plants. This is like visual model live data we make some operation scenario, assess the risk for the operation, and make a plan for the maintenance proactively. Also, there is some AI. We are talking about inventory of chemical. We have one application to monitor the inventory and chemical consumption, and give alarm for us about inventory level and increase this by, we are talking like automatically. And we can also in our booth, we have more innovation practices we can share with all attendees if they visit our booth.
Yes, I was going to ask next about what's the I guess, the most exciting piece of smart water that each of our people have seen recently. And I guess for me, Arthur is one of these things where I heard about this deal you had in Sydney, where you are fitting your systems into the people's houses, and then is it right that the utility then bills people by the amount of water that they use from your systems in order to repay the cost of them? Is that how you do it?
Yes, and they reduce their future investments.
Move that up a bit.
They reduce their future investments in desalination plants and wastewater treatment plants by simply offering water recycling systems in every building, whether it's a hotel or an apartment building or an individual home. Traditionally, rainwater systems were used in New South Wales around Sydney, but the rainfall is coming completely unpredictable. So with many months of no rain at all. So the rainwater system doesn't work, doesn't offer the reduction that the Sydney Water and the state requires actually to maintain their service level of water and wastewater treatment.
And how big is the system that you have to have in your house? Is it like having another fridge or?
Yeah, it's 1/3 of a square meter. So the footprint is this by this. 2 meters high, and this is enough for a family of 4 to reduce water consumption and wastewater emission by up to 45%. And maintaining your comfort of living. You can enjoy taking a shower.
And do you have to replumb the whole house?
This is ideally for a new home, and then it's very simple. For an existing home, it takes some effort, yes. But there we have circular shower systems. That is also helping to reduce wastewater and tap water usage. And what's also very important, every water recycling system, whether it's ours or from another competitor, is actually a sensor for a digital twin, because we monitor the amount of tap water that goes into the building. And then we monitor where this tap water is used for showering, for the kitchen, and what can be recycled. And then this recycled water is also monitored. So we give a footprint for every digital twin, and we give this information to the utilities so they can adjust their system towards the usage. And we also give this information to the homeowners or the building operators so they have feedback of their water consumption, of course also their bills, and also they understand the value of water. And of course this is very common already for homeowners that have solar panels on their roof. They have their app and they see how much energy they produced. Well, the same thing now happens when you have a water recycler like Hyderloop in your home. You have your app and it tells you exactly how you can find the balance between having a comfortable life and recycle and reuse your water so that you also contribute to a sustainable society.
And how does this in fact change the way that people use water? I mean, before you had, I presume, do you have one of these in your home?
Of course.
And how, when you fitted it, how did it change the way you used water when you got the data?
It's a very interesting question. It's 25 years ago when I started testing water recycling in my own home. That's how it started. And I remember very well that the first time when I took a shower, knowing that this water was not going to be wasted, and it felt like a liberation. Because
well, you took a 3-hour shower, did you?
Yeah. Well, you know, normally, you know, we produce waste with almost everything what we do. Mm-hmm. And so I saw the water running away from my drain, knowing that it's not wasted. It will be done again. So I could enjoy much more the pleasure of taking a shower. Yeah. Not feeling guilty.
Sounds like Dutch guilt. Oh dear. Anyway, what about you, Victoria? Tell us what have you seen recently that's, you know, you thought, wow, that's impressive in terms of smart water.
Yeah, smart. So we've all been discussing effectively what we're delivering is risk mitigation. So picking up on the final point about wastage, you produce something at great cost with great technology to then lose it. You know, BMW wouldn't produce 100 supercars and then burn 30 or 40 of them on the forecourt before they got to the consumer. So we've seen, we see pipes like being inhabited by an army of shoplifters, and we're determined to stamp them out because you've produced a product and it's not getting to the end user. But also you need to know, how can we mitigate that risk? And water is a collective responsibility. So we thought at FIDO we're a little bit disruptive and we don't like being told something can't happen. So we were told that AI and acoustic technology will never work where there's intermittent water supply. Can't happen, you need continuous noise. We thought, we're going to solve that. So India has a particular problem. Prime Minister Modi made a very noble saying that he wants a 24/7 permanent water supply on the clean water networks, and they have a terrible leakage rate. But they know that good infrastructure, like here in the Kingdom, is a key to economic growth and prosperity. So we actually adopted and adapted our AI model to be able to take intermittent acoustic samples in Bangalore, and we've been brought in with the corporation GAP, who was and are funding us for a 10-year program to reduce all leakage, to look at instances of network reliability of its condition, what is going to look like in the future. Will it match their operational needs? For them to risk mitigate, for the utility to risk mitigate. And we managed to secure millions of cubic meters of water reclaimed through just adapting our model. And where that really plays into that risk mitigation is talking about how technology, when you start out, maybe not the use case of where it ends up. So everybody calls us a leak detection company. We're not a leak detection company. That's one of the outputs. We mitigate the risk of a failing water supply. We mitigate the risk of you having supply chain failure. We also mitigate the risk of where you're actually going to build for all these corporations and heavy water users. And also we make sure that that resilience is long term. So I think when we started out, we were seen very much through the UK leakage lens. That's not where we're at. And we're really proud to say by adapting the model, adapting our operational methodology, we can help risk mitigate, whether it's for the utility or for the corporate, in numerous watersheds around the world.
And do you think you can help households as well? I mean,
well, this is the interesting thing. Because I do think it's morally wrong for a utility company to tell you to shower with a friend when they're losing so much water. So your technology is fantastic at stopping that. So what we do is we believe in engagement by the many, and as AI innovators, we actually use generative AI to help technology for the many. And we encourage our little sensors are so simple, I don't believe in difficult, expensive hardware, that the children can make it in school. They can take it home, put it on their meter box at home. We'll tell them if they've got a leak inside the house. It'll also tell them, the utility company, if there's a leak on the network. And you start to get the education to understand that water is finite, but actually the community can make a difference. And it's also collecting those verified data points that you need. You need responsible data, you need validated data, because once you've got validated data of where a leak's been on the network, what pipe material, what size it was, what it took to fix it, that is a truth point that you can build from. It's not You know, we hear these stories about leakage engineers selling their notebooks for $20,000 because it's got all their knowledge in about where the leaks are. You've actually got a verified data point from start to finish that you can feed into your system with all your other verified data points to start making the right decision to create this resilience that we need and capacity for growth.
Okay, no, that's great. So what about you? What have you seen that's cool?
There are actually two things, one in a smaller scale, one very large scale. First one was from Singapore a couple of years back. There was a small company called Vicente. They had these multi-sensor probes, and they distributed around the city, and they could get very accurate data, real time, looking for the micro changes in the pressure, acoustic data, water quality data, of course a bit expensive. But their model was so accurate, they could actually predict the future, burst and leakages, etc. But of course, it's a much, smaller scale if you consider Singapore as a city. That was very impressive. They had the verified data, and they could, within 2-3, diameter area, they can say within the next 6 months to 8 months, there might be a burst or leakage. So that was very impressive, a very good usage of AI predictive models. The other one I recently saw in Medina, because Medina is one of the holy cities in the kingdom. And during the Hajj time, there are millions of pilgrims come, and sometimes, especially if the weather is too hot, they always need water all the time. And their water sources is not just one source. They are gathering water from SWCC, from the seawater desalination. They have groundwater usage, so many different input to the system. And they build a SCADA and the control room. If you ever have a chance to see it, it's very impressive. They can see individual input and individual usage in the whole area, and especially around the Holy Mosque. And it was very impressive because the control and the data and the overall see of the whole ecosystem, water ecosystem, was very, very, to me was very impressive. I was very impressed. And I think the similar one in the other holy city as well. So it is very impressive, and I think one of the most, to me, so you can see the whole picture, whole city, and then you can zoom into the street level. And then you can even see like individual usages. I think that was, very, very impressive for me. As a large scale and a whole city scale.
I don't know, it seems to me that this smart and sort of data thing is an area where, actually Saudi Arabia has a hidden talent. I never realized this until COVID, when the Tawakkalna app was launched. And this Tawakkalna app is the most extraordinary piece of, computing and data and smart, and it made me feel that Saudi Arabia is the future. To be able to create an app like Tawakkalna, which enables you to do everything, and this is why I think there should be a lot of excitement around smart water in this country. Anyway, Asim, would you like to?
Sure. So, we've been talking about data, and, traditionally the way pipelines are inspected is you have cameras running up and down pipes, and you've got technicians watching all of this video. And in spite of this process being well defined over the last 10, 15 years across the US, across EU, you still have about 850 billion gallons of discharge across US cities. And this is a big compliance nightmare because you have lawsuits between the federal government and the utilities. Cities already are cash strapped, having to pay fines and so on. So the objective then is, how do you sort of optimize OpEx, CapEx? Can you use this data, model it to be able to take decisions faster? And one thing that we've seen over the last several years is different countries utilize different material pipes. You have the US using vitrified clay. You've got a lot of concrete, reinforced concrete in India. You've got a lot of lined pipe in Singapore, and so on. Over the last few years, we've been fortunate enough to work with utilities across the board, being able to build models of varying pipe materials. And what that has enabled us to do is broadly three things. And this is something that we've sort of demonstrated across utilities with partners like Veolia and Singapore PUB, is when you have a team out in the field collecting 300 meters worth of video every day. That's because they're collecting video for 4 hours and then they're creating a report for the other 4 hours. And it takes about a year and a half for the technician to become proficient and be able to create these reports effectively. So being able to dump all of that data at the end of the day into a computer vision model instead of having to sort of sift through every minute enables the team to do 3 times as much as they would have otherwise done. So you can do more than 3,000 feet, more than a kilometer a day with the same equipment. Now the benefit of that is if you're a private contractor, that's your revenue, going up 2 to 3 times because you're billing by the foot or by the meter. So you have this sudden increase in productivity, and you've got a 50% drop in costs because now no change to operations. You've got the same team, the same equipment. You're able to do much, much more. But from a city perspective, compliance, which is, when you inspect a pipe and you take a decision on how to repair it, it's about 3 to 4 weeks out. So being able to bring that decision making down to about 2 days is where cities feel the most benefit, and being able to then go in and rehab the pipe and seeing cleaner waterways, I think that's the biggest impact that we've been able to show on some of our projects.
Okay, no, that's great. So let's move on to SWEC. Now, I remember in the sort of first of these innovation conferences that we did in Riyadh, Engineer Tariq presented the sort of future of SWEC with all kinds of drones and AI and what have you, and I thought it was all futuristic, but it all seems to have come to pass. But the one thing that he didn't present in his future vision was what you're doing with the intakes and jellyfish. I really enjoyed that. Tell us about that, how you're working with the jellyfish in your intakes.
Yes, this is for the production, seawater production. The jellyfish attack during some period of season, attack the intake, and the cause will be force shut down the plant. The innovative practice we are doing, there is bubble curtain. This is diverting the jellyfish direction with environmental, no environmental impact for the jellyfish. And we fix all this bubbles curtain, like compressed air bubbles. And we are saving the intakes from any attack and availability. We maintain the availability of the plants and continuous of production. There is another innovative idea. This is membrane recycle. Before 3 years after we manage the surface and underground desalination plants, now we are reusing the membrane of seawater system with the brackish water after cleaning and reuse and reduce the environmental impact and resource reuse again. And this is impact for the 140 plants of the surface and underground plants. And this is will maximize our production and increase our availability for supply the water for the kingdom.
I mean, it's one of these things, that, as you say, replacing taking the seawater membranes and putting them into the brackish plants after they've been used, and, this extraordinary ways of protecting the intakes. It seems to me that SWEC has become this innovation engine in recent years. Who comes up with the ideas? Do you have a special department where they're supposed to come up with ideas and somebody says, we'll do this to jellyfish? Or is it the people in the operations, you say, jellyfish don't like bubbles. Why don't we attack them with bubbles. I mean, how does these ideas come about?
This is idea coming to overcome some problems like this problem. The innovation came with to find solution, and also with the AI and machine learning, also we can predict any change in the seawater and before it reach the intake. We are talking about jellyfish, also algal blooms, and any change, oil spill. Okay, this is we are applied and give alarm for us to save our intake before the effect. If I talk about machine learning, about digital twins, we are implemented in our plans and maximize the production and increase the efficiency of the equipment and the system. And I think advanced SCADA and DCS system will be the foundation for the smart system, and you can collecting massive life data, and you can you have big data to deal with, and this will be I think the special network. This is any smart system in the network will be saving erecting the new plants. The investment in the network, the impact for all water chain will be clear for us.
Okay, thank you. So we'll have a final, very quick round. I think we've got sort of 1 minute or less than 1 minute now each. So what is the sort of one thing that you see in the future that you're most excited about?
Most excited about the fact that we have the opportunity to create this water-resilient world, that we copy nature. Nature is the biggest water loop you can imagine, and this created all life on Earth, because we need water as we need air. So this should be made available for everybody on Earth in a way that we have on one side this lifestyle that is modern and that we can enjoy everything also that is related to water and water consumption, and at the same time don't create more waste on Earth, because we have to adapt from a linear lifestyle to a circular lifestyle with all aspects.
Yeah, okay, no, that's great. Victoria, what do you got to...
Oh, what I'm so excited about is finally water is at the center of the conversation. We need to create a water secure world because water is not just life, but it's growth. We need it for the bedrock for economic certainty, for economic growth, for social cohesion, for climate mitigation. And it is getting the attention it deserves. It's getting some of the biggest and brightest brains it now deserves. Water is where it's at. People are leaving AI for fintech and coming over to water, which is great to see. I'm really excited. We're getting the youngsters some hope and optimism that coming to join and creating a water secure world is where they need to be. So I have great hope. I do hope that we can break down the silos and we're not all competing on who's selling the biggest box with the most fancy bow, that we believe in verified data, that we work with AI to get a verified outcome that we actually need, humans and AI working together, and hopefully we can create that water secure world. So I'm excited that finally water is being taken and placed at the center of all our discussions, whether they be economic, social, or climate.
That's great. So,
I think the most exciting is the accurate predictive AI. And I say accurate because AI simply concentrates whatever you give to the system. So if you have a bad data, you have worse outcome. Because AI doesn't remove the bad data. If you have an outliner, it's okay. AI can remove it. But if you have like 51% bad data, it will become 99% worse data. So accurate predictive AI, I think that's what I'm excited for.
That is an exciting prospect. What about you, Hassan?
I think seeing public health departments leverage wastewater data to be able to predict outbreaks, I think that's been really exciting. It gained a lot of traction during COVID, and now that's sort of trickling down into being able to monitor waterborne diseases through wastewater, so being able to predict whether next hepatitis A outbreak is potentially going to happen, what part of the neighborhood, just by leveraging how wastewater flows through urban networks, and seeing how utilities and public health departments work together to solve this problem. I think that's been pretty exciting to watch over the last few years.
Yeah, no, that's true. Rashid, what about you?
I think the integration between water network and production plant, if this is possible, we are talking about the world, this is a good thing, and if we are believe the water smart technology, water smart managing, and the new philosophy of resource management and data become decisions, and decisions drive sustainability.
Okay. So we've got a lot of excitement about data and what we can do with it. I think that's all we've got time for on this panel. Thank you very much to our panelists. And
can I say one more thing? Sorry to interrupt you.
One more thing.
I think we should all work together and cooperate.
We shouldn't cooperate. No.
to create this waterful world.
A waterful world. Okay, we'll cooperate to create a waterful world in Saudi Arabia. Let's do that. Anyway, thank you very much. It's been a fascinating panel.
Thank you.
Thank you very much, our esteemed panelists and our moderator, of course. Kindly remain on stage. We're going to present to you a token of appreciation for coming here, for sharing your wealth of knowledge with us today. We really enjoyed that insightful, inspiring session. Thank you very much. Ladies and gentlemen, our next session takes us to the Avon Lake in North America, where the electrochemical water treatment technology was actually implemented for the first time in partnership with South Korean company TechWin. And this case study is going to explore the drivers behind that project, the challenges it faced, and also the lessons learned. And for this session, and telling us a lot about this case study, we're honored to have Brian Stubbs, the President and the Executive Director of Cleveland Water Alliance, to share this groundbreaking story. Let's please welcome Brian to the stage.
Well, good morning, and first of all, thank you for having me. Thank you to the Saudi Water Authority for putting on a dynamic event. I travel all over the world. This is my first time here, and this is fantastic. And also, just thank you to everybody that's been so cordial and pleasant and helpful here in the kingdom. We're talking this morning, kind of a little departure from yesterday in terms of we talked about the regulatory pull of the market and finding synergies within that. In North America, we're really, from our perspective, talking about how do we build up the bench of ecosystem, the bench of early stage technologies. Water's been sorely missing from this perspective. If I have a mobility app, I have an AI app, et cetera, I know where to go to get that from idea, from lab to market. For water, it's always been a challenge. I mean, there's a great history of big companies like GE Water and others who have become holding companies and didn't figure this equation of how to get technologies into the market fast, quickly, efficiently, and with proper funding at the right time. So at the Cleveland Water Alliance, we have taken this approach on how do we accelerate that time to market. So we're a water cluster, innovation cluster, 150 plus multinational global companies working with us, over 35 water utilities. We're based in the Great Lakes region of North America. This is fascinating for me because we sit on 21% of the world's fresh surface water supply. So we have, in some ways, different challenges, but in some ways, very similar challenges. Research universities, kind of missing in this equation often. We work with over 23 what we call Research One. This is the top level research companies that are names that some of you may know, from Stanford through to University of Chicago to the University of Michigan. Federal partners. We work with our federal government extensively, from the Department of Energy, that Water Energy Nexus, from NOAA, and then also with global accelerators. I know some of them are here today. I was just in the green room with Hein from the Water Campus and the Water Alliance in the Netherlands. So we package that ecosystem together and bring it to be more efficient for getting early technologies proven, trialed. So, we do this through key programs. First is our Smart Lake Erie Watershed. This is 20,000 square kilometers of telemetry coverage, just like a smart city. We've done the same thing. So it could be Korea, it could be Singapore, it could be Saudi Arabia. $18 deployments just this year in our test beds. And we've had 83 pilots of these early stage technologies just over the last 4 years. So really, what we've built here is a global destination. Companies are coming from all over the globe to test and trial their technologies within our set of test beds. And of course, our partners include the utilities, industrials, data centers, a big play for us right now. We have quite a few. We have a new Intel chip factory coming in, so we're helping them around water, food, beverage, residential, ag, doing a lot of work around nutrient loadings. And then, no big shock here after that last panel, the fact that 60% of our deal flow is digital in some way, shape, or form. A lot of that's going to be around the sensors, and a lot of data services as a play. So as mentioned, we do this through our test beds, establishing trials, and we do this with utilities, we do this with industrial partners, and we've put a little over 20 million just into that infrastructure to test. significantly. At one point had tripled in price. Also, it became a supply chain headache. It was just hard to get. You've got to have a certain, numbers of days and months supply. And where we are 3 years ago, we had a major derailment of chlorine on the back of a tanker on a train. So it's just like perfect storm of, on one hand, we had our utilities saying like, there's got to be a better way. On the other hand, we had a company coming to us saying, we have a new technology, a new solution for this. So that led us, and this is just an example of how companies will play and engage with us as our ecosystem building to get their product into the market. So, TechWin came to us out of both Daegu and Seoul, South Korea, and had a solution. And the idea of high concentration. Number 3 was huge for us. Strong economics, very strong economics. Ultimately, it's going to be cheaper. In fact, so much cheaper and such high concentrate that in the case of the utility we chose here, Avon Lake Regional Water, it became a profit center, which was fascinating to us because they were generating more hypo than they needed, and they could offload it to other utilities as well as industrials, including a Ford motor plant. Also cool, the source for electrochemical process here is salt. But we're not going to build these in Korea and ship them to you. Can you find us a manufacturer to build them for the North America market? So a lot of kind of really interesting opportunities there. So look, when somebody comes to our test beds, probably 80% of them are plug and play. We can vet them, we can do our due diligence, we can deploy them and get them. Opportunity, it warranted coming, speaking, talking with them. I traveled to South Korea. Contract between us happened fairly quickly. And then finding a utility that was willing to trial this, to take on this risk. Now, remember, when we talk about a utility taking on risk, we de-risk that for them. We take on the risk as and I won't bore you too much with charter status in the United States for a nonprofit. We're not a for-profit unless we have no assets. So for us to take a risk is, for lack of a better term, risk-free. Nobody's going to sue us. But we also, of course, layer that with lots of insurance, 6 different policies ranging from Lloyd's of London on down. That gives that comfort level to these utilities to trial this. Then also with Avon Lake, it was a perfect time because they were doing a design build of their facility in which to double the amount of water. That's our biggest challenge now is the infrastructure. The infrastructure to supply the water demands within our communities, of course, led by data centers, led by advanced manufacturing, which is another strong suit for us. So with that in mind, we got everything inked and we started building this, and we turned this project on just a couple months ago. So it's working, but I just wanted you to see when we talk about testing and trialing technologies, what we're really talking about here is things can be fast, quick, and easy, and also things that are complex. But keep this in mind. This would be my one of my couple takeaways is we got the product to the market faster, more efficiently, and more quickly. And another good example is a data play where We actually got this company from trialing in our test beds to being acquired by a much larger company in 18 months. Go back a decade and tell me a water technology solution that got into the market and actually got bought out within 18 months. Now suddenly we're talking about the idea of access to capital and capital coming in to really drive the market, to improve the market, to bring all of our utility partners better solutions. So just a couple images. You know, this is the TechWind project in Avon Lake. Bottom left is, you know, before it left their facility in Korea, and up top and to the right, you can actually see it where it's been deployed. Eventually, this will have a whole structure built over it, but everybody was excited to get it up and running. And again, takeaways, legal instruments, insurance, trusted partners, making sure the market is ready for this. The market is going to adopt it. If it's not a regulatory pull, is the market going to be ready for the push? And of course, economics often have a lot to do with that, and problem solving. Patience, time is always a must. And we always ask this question, if not but for. So if not but for us, would that project have gotten deployed in North America? Maybe, but probably not, and nowhere near in terms of the timeline. So I'm going to wrap up by saying, you know, with this, we also add in business hoteling space. So, you know, that's our location there, and it just shows you how companies come in. We have companies from Singapore, from a great semiconductor-based optical sensor company, also out of Korea, several companies out of Europe located there right now. And of course, the Freshwater Innovation Fund. Always keep that in mind. The first dollar is the hardest dollar within the water ecosystem. You know, so that $500,000 US dollar check or that $1 million US dollar check is the hardest one. The 20 million, I can get them. It's the first one. So with that, I want to wrap up. Just again, thank you. It's also good to see a few of you that I met at WEFTech a couple months ago in Chicago, and we always welcome your visits, and we'd love to host you. Thank you very much.
Thank you very much, Mr. Brian. That was a very rich keynote. Thank you for sharing your insights with us. The Saudi Water Authority would like to present to you a token of appreciation as a thank you for your invaluable participation. Ladies and gentlemen, our upcoming session highlights the development of new global standards for drinking water, emphasizing the fundamental human right to water, health, and access. This case study will showcase how partnerships, educational programs, and also the technological innovations are driving progress in water sustainability. Please join me in welcoming Marco Guy Each, the co-founder of Bled Water Forum, who will share with us how these efforts are actually enhancing the future of drinking water worldwide.
Your Excellencies, dear organizers, dear host, dear ladies and gentlemen, it's a big pleasure to be with you today to discuss all these innovations, and I'm very impressed how the Kingdom of Saudi Arabia is developing and leading this world, from my point of view, in right directions regarding the water innovations. I will tell you a short story how we started. 1 year ago, I met the ambassador of the Kingdom of Saudi Arabia in Vienna, Dr. Abdullah bin Khaled Tavallah, and his colleague Mohammed bin Kainan. head of political affairs. We discussed a lot about water innovations. I represented a lot of things, how we are approaching water, because we are approaching from totally different angle. We are dealing with high quality drinking water, natural spring water, natural mineral water. We have so many water sources. My country is very rich with water, with nature. Our portfolio is very rich with water and new understanding of drinking water. I will discuss about that. So 6 months later, the Blade Water Forum was attended by a delegation from the Kingdom of Saudi Arabia. The delegation included Mr. Fuad Kometi, your colleague. He is a director of the Water Technology Innovation Center, Saudi Water Authority. Mr. Arif Al-Kalali, general advisor for water resources to the Deputy Minister for Water at the Ministry of Environment and Water and Agriculture of Saudi Arabia, along with several other leading experts in the water sector. Today, the Ministry of Environment and Water and Agriculture of Saudi Arabia is an official member of our expert board of Blade Water Forum. And 6 months later, today is a further advancing this collaboration by introducing new global standards for drinking water in collaboration with Kingdom of Saudi Arabia. When we are talking about drinking water, from my point of view, we are still living in the time of black and white television. And you know why? Because the people all over the world don't understand what water really means. They understand only what is drinkable, what is non-drinkable, what is still sparkling, what is soft, hard water, and that's pretty much all. But we developed so much knowledge about that, and we can teach you a lot how to understand water, how to use it for a right way, how to pair it in so many directions. So on the other side, we have technology who can basically read your mind. So many new innovations around the world, but obviously we forgot the basics. So that's why we are here, and that's why we are changing that, and that's why we are one of the leading organizations in the world on that topic. So who we are? Blade Water Forum is a non-profit organization, fast-growing organization, focusing on new understanding of drinking water and new global standards. we have great innovative ideas, we have new knowledge about water. This part is also a game changer. I'll show you later why. Then a partnership with government and non-government organizations. We have access to global technologies. We have partnership with economy sector, hospitality sector, which is also very important when we are talking about tourism and developing. Individual people, experts, and certification and awarding ceremony. And all this, I can tell you, is something what is changing this planet. So let's take a look, what are these global water trends? With European Water Awards, as I said, we have access to global technologies, and over the past 10 years we have awarded and identified many of the most innovative companies from around the world, all members of our organization with whom we work to improve. Wide distribution. And here I'm not talking about the brands, I'm talking about water. So another part is related to European Water Sommelier Association. Have you ever heard about water sommeliers? Some of you maybe yes or not. So we have deeper knowledge how to understand water, and our goal is first of all to educate national institutions, schools, and people worldwide how to understand water more deeply. How and what we are teaching is that we are talking about the water quality, what are the water sommeliers, then we are teaching about specific expertise and knowledge. History of water is very important, how water affects the body, how water affects our human health, very important topic. Contaminants in water, non-regulated, regulated contaminants, because as you know we are living in the world of pollutants. There are so many contaminants which are not part of regulation yet. And as we are focusing is just on that. We are identifying what we can find in water. We are identifying all the contaminants, so we know which water source is more cleaner. So if we are dealing with water with less contaminants, more contaminants, non-contaminants, and as I said, I'm talking about non-regulation parts. So importance of packaging, also a very important topic. It could have positive or negative effects. Chemical, microbiological analysis, water mineralization, when we are talking about total dissolved solids, pH, hardness, CO2, what that means, overall components. We are evaluating water with more than 20 parameters. Then we are teaching about global market, different sources, what is the best quality of water. This is the most common question wherever I go, and I spoke with people. They're asking me, Marco, what you are drinking, what is the best water? So new understanding and symbols. We started sorting water by purpose, so we are looking for different types. So that means first of all is water for hydration. This is water where we can drink it every day for if you are thirsty, for example. Then we are talking about water for purpose. That water contains very low level of mineralization or very high. Then we have water for health, water for kids, and we can also talk about water after sports and other activities. Then we are talking about labeling, and this part, pairing water with food and beverages is also something special because you can get a great experience. We are looking for synergies, for upgrades, and this is also something where we are changing the hospitality segment completely. Then we are delivering new certificates and standards. Then we are teaching how to taste water. And as I said, we are helping tourism and hospitality program to improve the water services by implementing all these new global standards. And I will show you a water menu here. We are implementing in restaurants, hotels, bars. So when you enter the restaurant, you will find this water menu, and just to explain, it depends what you're gonna eat or drink. If you will take a coffee or tea, you will choose number 1. Number 1 is a low level of mineralization for water. If you go with, let's say, more fully, with more, let's say, meat, or you will take some sparkling water with higher level of mineralization. So you have so many options here. It depends on what you eat and what you drink. It's very easy to use. So this is what we are drinking, what we are bringing to this work. Then the other topic is BWF certificate, where we are marking water utilities, public fountains with QR code, where we are explaining what this particular water really means, how to use it, health risk, how to pair it with food, with other beverages. So we are doing that transcription because it's our human rights to know what we are drinking. And then we have a Keynote seal of approval. This is certificating symbol for hotels, restaurants, and bars. This is our guarantee that at this location you will find the most quality drinking water in the world, and then the staff is well educated about water, and that they will teach you new things about water. And on the other hand, we are also marking the water suppliers. The last category is, of course, water supply, and with this we are bringing the color spec to this area. So European Water Awards, President of the Republic of Slovenia, Nataša Pirc-Musar, at awarding ceremony. BWF certificate we provided 2 years ago for Fine Bio company in South Korea. A Keynote seal of approval is this seal, and this seal you will find all over the world, and the QR code here also you can scan it. You will find more data. We are also developing a sign language for deaf people, and also for blind people. Whenever we are let's say, talking about water and publishing these QR codes, we are using sign language and voice recording for blind people, so we can take care of all population. So, and this is the game changer, and this is only a few % what we are bringing to this world, and in the next 3 to 5 years, we're gonna add a lot of new technologies on it, and this water will transform completely in this direction too. So thank you so much for your attention.
Thank you very much, Marco, for that inspiring presentation. Please remain on stage. The Saudi Water Authority would like to present to you a token of appreciation as a thank you for your invaluable participation. results are remarkable. Thank you. Ladies and gentlemen, now we're diving into one of the most critical themes of this conference, water management and excellence. This theme will explore how operational excellence, cross-sector collaboration, and also the innovative integration of water energy system and how they can drive sustainability and resilience in the water sector. Our upcoming session will explore how water and energy efficiency go actually hand in hand, driving circular value chains, recovering heat, recycling water, and also reducing waste across sectors. We're honored to have Sam Dibu, the EVP and the President of Global Markets at Ecolab, to share his insights on this important topic. Sam is a global leader in water, hygiene, and energy technologies, and his expertise is going to shed light on how sustainable practices can benefit both water and energy system. Sam, the stage is yours.
So, Taikri, thank you very much for the introduction. Good morning, everybody. My sincere thanks to His Excellency Abdullah Al Abdul Karim and the Saudi Water Authority for inviting me to join you today, and of course to all the distinguished delegates here. Every time I visit, I'm reminded of the kingdom's generous hospitality and the unmatched commitment to innovation and prosperity. As a global sustainability leader, Ecolab shares your values and ambitions. Ecolab is proud of our long-lasting partnership in support of Saudi Arabia's Vision 2030 and proud to contribute to the Kingdom's leadership in water efficiency and sustainable industrial growth. Through our subsidiary, Nalco Water, we have been helping advance the Kingdom's goals for more than 45 years, and we look forward to expanding our presence in cooperation with the Saudi Water Authority for many more years to come. Of course, water security isn't a passing trend here. It has been a national priority for decades. The Kingdom's proactive approach and visionary leadership in water efficiency and sustainable outcomes positions Saudi Arabia at the very forefront of global water innovations. As we convene here today at the crossroads of rapid technological advancement and real sustainability challenges, three truths stand out. First, water is the foundation for new opportunity and growth. Most industries, almost all industries, require water to grow. And in an era where artificial intelligence is reshaping our world, our future depends on how wisely we steward water. Second, the path forward is built on innovation and partnership. Around the world, and especially here in the Kingdom, government and technology leaders are forging strong collaboration and unlocking new value. And third, Saudi Arabia's visionary leadership and public trust are essential. Saudi Arabia's Vision 2030 and the National Water Strategy show that when bold ideas are matched with public support, we can align growth, new technology, and sustainability for the benefit of all. So today, let's explore how these three pillars, water stewardship, innovative partnerships, and visionary leadership, hold the key to unleashing unstoppable growth. While many are familiar with AI's energy demands, the associated water footprint is less widely known. The fact is, water demand will continue to surge. By 2030, the world faces a 56% deficit, and AI is predicted to consume as much power annually as the country of India and as much water as it takes to meet the annual drinking water needs of the United States. The largest microelectronics manufacturer uses as much water in one day as the largest food-producing company in 1 year. And a single advanced microchip fab manufacturer consumes as much water in 1 week as a major food and beverage processor does in 1 year. This is not sustainable, because we can create more of the energies that these facilities need, but we cannot create more water. In fact, if we would combine all the fresh water from our lakes, rivers, aquifers, it would fit into a 55-kilometer bubble, roughly the size of the Riyadh metro area. At the same time, AI continues to unlock extraordinary possibilities. It is unleashing the potential for transformative growth and innovation. Every week, one new data center opens, and every month, one new microchip fab comes online. Globally, we saw in 2025 $500 billion invested in new data centers. And we anticipate $1 trillion worth of new investments in the coming few years. Saudi Arabia is not watching this revolution from the sidelines. The kingdom is positioning itself really at the center of this transformation. By 2030, AI is projected to contribute 12% of Saudi Arabia's GDP. It is becoming a cornerstone of the nation's future economy. Saudi Arabia is already a global model for water strategy, and as Ecolab, we like to say here, if we can get water right in the kingdom, then we can find solutions for anywhere in the world. And that's true. Nobody is better positioned to address this challenge and seize the opportunities than Saudi Arabia. The power of water can really further bolster the kingdom's pioneering role in cutting edge on the global AI boom. So let's turn to the second pillar of growth, innovation and partnership. This new era and growing investment in AI-driven technologies demands a new approach. One where we can reuse water and energy just like nature has done this for billions of years. At Ecolab, we see a future where a data center uses less water in 1 year than a busy car wash in 1 day. And where microelectronics fabs recycle most of their water despite requiring the purest water on Earth. Unlocking this massive growth opportunity lies in innovation, in circular water solutions, and in strong partnerships between industry, government, and technology leaders, partnerships with companies like Ecolab. Our more than 100 years of experience is unmatched. We serve millions of customers in 40 different industries in more than 170 countries. We safeguard 1/3 of the world's food supply, and we enable 1/4 of the world's power generation. And in 2024, we helped customers save enough water, drinking water, for almost 800 million people. And by 2030, we will help save enough water for 1 billion people. In Saudi Arabia alone, Ecolab helped save enough drinking water for the population of Riyadh. And we do this by helping customers reduce, reuse, and recycle water within their own operations. And as you save water, you save energy at the same time, because varying by industry, up to 75% of the energy in a plant is used to manage water. Pumping, heating, cooling, treating, they all use energy. When it comes to water, Ecolab leverage expertise and extensive data to define best-in-class water efficiency benchmarks for the 40 different industries we serve. Because we know what the optimal water use ratio looks like for each sector, we are uniquely positioned to help our customers achieve it in their operations, turning sustainability into a competitive advantage. So for example, in the beverage industry, we know that a best-in-class bottling facility achieves a water use ratio of roughly 1.5 liters of water per 1 liter of product. And in the mining industry, we know it takes 450 liters of water to produce 1 ton of copper. And a best-in-class mining operation recycle more than 80% of their process water. And a best-in-class paper mill uses 12,000 liters of water per ton of paper, mostly achieved through smart recycling solutions. So from microchip customers in Asia to paper mills in Latin America to steel mills in India, we use our best-in-class insights to drive improvement plans for every location anywhere around the world. And this performance is achieved through the power of circular water strategies, often first by capturing the low-hanging fruit that reduces the water intake, and then by implementing more advanced reuse and recycling technologies. Currently, only 20% of industrial wastewater is reused. I know that there are many engineers in the room, so you will relate to this. At Ecolab, we believe that wastewater is an engineering mistake. In the ideal state, no water should be wasted because it is being continually treated and recirculated within that circular process. And we have seen the impact of our circular water solutions already firsthand through work with customers like Nestlé in Mexico, Tata Steel in India, Cargill in France, and Digital Realty, the data center operator in the United States. Ecolab is proud of our long-standing presence in Saudi Arabia through its Nalco Water business, which has supported leading industrial partners in managing and optimizing water use here for decades. Ecolab is invested in supporting the kingdom's industrial growth and talent development and innovation, and today our solutions are applied across sectors from industry and manufacturing to food and hospitality. That includes strong multi-year commercial relationships with companies like Ma'aden, Saudi Aramco, and SABIC. Our 45-year partnership with Aramco and our long-standing relationship with SABIC have focused on value co-creation, centered around water savings, energy reduction, and decarbonization. We leverage customized solutions that we have developed in our R&D center at KAUST, as well as digital solutions to help our customers drive growth while achieving sustainable outcomes. For example, in our partnership with SABIC, we optimized the performance of the seawater cooling towers responsible for 28% of the site's electricity use. By implementing Ecolab's proprietary technologies, we achieve game-changing impact. And to achieve such impact, we believe in this transformative power of partnership. The business community must take on this cause in partnership with the government. And we are proud and encouraged by our collaboration with the Kingdom to ensure that we have the right solutions in place to support the scaling infrastructure needed for AI. Last but not least, let's discuss the third pillar for growth, visionary leadership. The Kingdom's Vision 2030 and the National Water Strategy demonstrate what is possible when inspiring leadership and national ambition is matched with strong collaboration. Like many of us here present, Ecolab is proud to align our expertise with the core pillars of the Vision 2030, specifically in addressing the critical challenge of water scarcity. Visionary leadership and consequently public support is essential to align economic prosperity, developing technology, and sustainable outcomes. This year's Ecolab Watermark study asked consumers in Saudi Arabia how they view water, technology, and sustainability. And the results are encouraging. 7 in 10 consumers believe businesses should use AI to manage natural resources responsibly. And we believe that is a powerful signal. It's a powerful signal of trust in technology as part of the solution. But we also saw a gap. While most of the people recognize AI's energy demands, only half understands its water footprint. Closing that awareness gap will be important as AI infrastructure continues to grow. Public confidence in the Kingdom's technology-driven future is strong, And much of that confidence is rooted in the Vision 2030 and in the National Water Strategy. These policy documents are shaping how people think about the future and demonstrate that economic growth and environmental stewardship can go hand in hand. In October, Ecolab was thrilled to sign a memorandum of understanding with the Saudi Water Authority to accelerate water innovation and to support the kingdom's sustainability objectives. This collaboration provides a framework for to jointly advance the sustainable water management as a strategic enabler for the Saudi Arabia's Vision 2030. So in closing, water stewardship, innovative partnership, and visionary leadership hold the key to unleashing unstoppable growth. As the AI boom continues to reshape global economies, responsible water stewardship and smart water management have become essential for sustainable growth. The Kingdom stands at the forefront of water-smart innovation and is shaping what the future will look like. Ecolab is proud of our partnership with the Kingdom to ensure that we have the innovations and the right solutions in place to support the scaling of the infrastructure that will be needed for AI and for other growth industries. And lastly, guided by the Kingdom's vision and leadership, together we can create a very powerful platform to scale water transformation here and throughout the world, driving shared impact and growth to even greater heights. Thank you very much.
Thank you, Sam, for that eye-opening presentation. Kindly be at the center of the stage. The Saudi Water Authority would like to present to you a token of appreciation as a thank you for your invaluable contribution. Thank you very much. Ladies and gentlemen, up next, we have a dynamic panel discussion that is going to focus on how the water-intensive sectors can contribute to water security. Water-intensive industries actually play a crucial role in ensuring water security, and this panel discussion is going to explore how these sectors can collaborate with environmental agencies to implement effective water-saving measures and leverage the incentives to adopt sustainable practices. Moderating this exciting upcoming session, ladies and gentlemen, is Dr. Jen-Yu Lee, the Saudi Water Authority expert from Saudi Arabia. Joining him are 5 distinguished panelists. Let's welcome them all to the stage. The stage is yours now. Let's give them a big round of applause, everyone.
Good morning. Thank you very much for joining us in this panel discussion. Save water, how the water-intensive sector can contribute to the water security. So first of all, please allow me to have a quick introduction about this discussion and our panelists. So water security is defining a global challenge. For the sectors, for example, the mining, tourism, energy, agriculture. Those sectors heavily rely on the using water. So today we will discuss how the collaboration and innovation can turn this challenge to be our opportunity. So first, please allow me to introduce our panelists. Ms. Muna Chris. Muna Chris, over there, yeah. So she's the Environmental Innovation Director in Red Sea Globe. So at Red Sea Globe, she integrates environmental innovation with tourism development. Ms. Muna. Engineer Yasser Al-Asafi, the Executive Director of Infrastructure Sector in Government Expenditure and Project Efficiency Authority, XPRO. Yeah. So Engineer Yasser at XPRO, he is enabling efficiency standards for Saudi Arabia key infrastructure sector through the government expenditure and projects optimization. Engineer Yasser. So Ms. Melanha. Ms. Melanha, the Director of Private Sector Policy and Advocacy in Water Aid. So at Water Aid, Melan focuses on guiding the private sector to take responsibility in water resource management and financing. So Ms. Melanha. And Dr. Helen Robinson, CEO of Aquarius Resource. Actually, Dr. Helen is a hydrogeologist. So she's a hydrogeologist advocating for an equitable and inclusive water transition within especially geothermal and mining sectors. Yeah, Dr. Helen. And engineer Sami Al-Rabia, so Director of Commercial Transaction in Vertical, the national company for water transmission. Yeah. He is responsible about the implementation of commercial agreements and performance indicators in Vertical. So this is our 5 panelists today. So today, in today's discussion, we will discuss how different sectors can identify the water saving opportunities and the role of collaboration with government, international agencies, and companies and the communities. The effect incentive to encourage water saving measures and the critical part played by technology and innovation. So thank you very much for joining us. We may start the questions now. So my first question probably give to all of our panelists is a universal question. So because you are from the different sectors, from government, private company, national company, and international organizations. So what role does such cross-sector collaboration, for example, public and private partnership, so can play in advancing water security? So from your own experience, could you please share with us a very brief example of success or example of challenge? We may start from Helen.
Start with me. So I'm actually going to start with a challenge. There was a fantastic project a couple of years ago in Kenya, and it had the potential to be a really great example of a public-private partnership where the communities were partnering up with well developers for water access. And the idea was that they would work together, plenty of community engagement, clear understandings for what was needed, where it was needed, to develop good quality access to water in a sustainable way. However, there was no sort of meetings with the communities, no sort of stakeholder engagement to gain that understanding. When the project started, there had been no clarification of who was going to do what, when they were going to do it, who was responsible long term for sort of operations and maintenance. There was no skill transfer. Additionally, we saw that there was no sort of structures in place around regulatory frameworks for the long term. And this resulted in poor water quality monitoring, the wells weren't developed properly, and the communities lost interest. And unfortunately, that particular project whilst having the potential to be amazing, failed.
So it's the example from Africa. Okay. So Milan, from WaterAid, working for the international communities. So could you please share us an example?
Well, thank you. Very honored to be here, and thank you for the organizers and for the Kingdom for having me. So I work for WaterAid, and we are a nonprofit in operations in over 25 countries around the world. And core to actually being able to achieve WaterAid's mission is this particular topic of cross-sector collaboration. I want to go back to the keynote that was made yesterday by the CEO of DC Water around the focus on people, right? And the importance of investments in people as employees and consumers towards enabling, to ensure long-term longevity, economic growth, well-being for businesses. So in this context, where I wanted the example to complement Helen's example, is an example from South Africa, where one of the largest mining companies had operations in South Africa, and they made a change in regulatory requirements, where they reduced the amount of untreated water that came in from the mining operations that could be released in basins. In response to this change in the regulatory environment, the mining company proactively worked with the municipal water utilities, as well as another competing mine company to actually set up a wastewater treatment plant in this location. And in doing so, what they managed to do was to treat to wastewater to a standard that could then be used by the municipal water systems in order to ensure potable water use for the communities and for the operations in the long term. And these investments actually led to increased well-being for the populations that had increased, right? Because this was actually an economic growth opportunity in that region that supported the communities around where the mining operations were. And so it had a twofold, it had multiple benefits, right? For communities, for businesses, and for governments and society overall.
Okay, so this is very interesting. So Engineer Yasser, could you share something from the point of view of the government authority?
Yes, thank you, Doctor, first of all, for having me in this panel discussion. I'm really happy and glad to be part of esteemed panelists, and I would like also to take this advantage to thank SWA for doing and creating such an event, and I think it was evolving year by year, and this special thanks to them. I think countries over the globe, most countries over the globe, has spent a fabulous achievement in taking in their consideration water sector, where they have takeoff agreements and where they do have a balance between private sector and public sector. And we can see this happening in Saudi Arabia in particular. We have seen tremendous effort past 5 years when water system has been in place, and we can see the principal buyers there, where all the private and public, I would say, entities have an agreement based on the levelized cost of water. And we can see how this levelized cost of water goes by 50% since 10 years back to comparing to now years. So I think this is a very exponential success that happened in the water sector in Saudi, and I think rest of the world, some countries are doing the same, where they do have very good metric to measure the effectiveness and efficiency. And I think this helps the urban side demand. What about the agriculture side? What about I would say the demand comes from that part, and I think this is a challenge, and we've seen today keynote speaker present some very good data about how is the demand of agriculture is continuing to grow, and this all try to get the water from renewable and non-renewable water, and this is a challenge, I think, for the future to enhance the relation between public and private sector agreements.
Okay, thank you. So Mina, any story from tourism sector?
Yes, good morning everyone, and thank you for having me here today. Actually, yes, cross-sector partnerships is very important, especially for the size of our projects. So we have, starting with the PP agreement with giant players in the field to provide our utilities, starting from 100% renewable energy to provide the energy which will it's the source of energy for our RO plants, and then wastewater treatment and reuse of the wastewater. And in addition that we have the largest battery system in the whole world. So aligning all of these together, we decided to cooperate with Aqua Power, EDF, Masdar to provide our utilities. And actually the main challenge was like, you can see that all of these utilities are dependable on each other. So we need the energy for the water desalination, for the reuse, all of that. And aligning all of these, the complexity of the communication in parallel with the financing elements also, it was not easy. And because also we're not only developers, we are operators. So we are operating the most luxurious resorts in the world. So there's like no mistake is for, it should be well measured, and actually partnerships also doesn't stop for utility providing. For us also we believe in partnerships with academia, research centers, international and national, like KAUST University, University of Tabuk, we work with them closely. And also we partnered with other giga projects like ENOA and NEOM for water solutions. We work together in very interesting projects. And of course, like MIWA platform, like Sahaba for water. So we have good collaborations with them, and we work all together. So we're covering the full spectrum.
Yeah, it's very nice. So Engineer Sam, actually example from water sector.
Thank you very much, Dr. Lee. I will start actually with the challenge, which is we know we are in Saudi. We rely on the desalinated water as the main source of water. And I will end up with the success story, which is our national strategy for water, which defines the roles and the responsibility for each sector. So the collaboration between the private sector and the public sector, I think it will ensure the success of our strategy. Thank you.
All right. So thank you, our panelists from a different professional background, the examples. So now I would like to have specific questions for each of you according to your professional experience. So probably first we'll go to Muna. So as we know, Red Sea Global is building world-class mega projects, generative, or even the regenerative tourism destination, such as what you call Amala. So what are the most impactful water management strategy and technology so Red Sea Globe or you are implementing now?
Actually, we cannot say that there is one important one, or like we look at the full cycle.
Okay.
At Red Sea Global, we have strategic people, we have engineers, we have scientists. So when we look at it, we start from the water desalination. So like, okay, it's a very scarce resource, and we're using renewable energy for that. We set a very aggressive and high performance framework for the RO plants we have. And then you go to the next step where the wastewater and the treatment of the wastewater. We utilize 100% of our wastewater, like the TSE is fully utilized, 100%, which we are very proud of it, for irrigation. And then like most of our buildings, like all of them are LEED certified, and most of them are platinum, where energy and water is very important, and we achieve the highest score in that. So inside our buildings are like efficient fixtures, water monitoring, utilizing gray water systems, they're all there, and metering. And then you go to the next level, which like outside, where the irrigation, we make sure that we use native plants. We have very accurate irrigation systems for our all plants across the destinations. And we don't stop here. We're even now utilizing the byproducts. Like we have a big challenge with the brine, as we are like nature inspired. So we have a project because we are building. So the concrete, for example, is one of the energy intense product we are using highly. So we are utilizing the brine as a substitute for cement, for example, and we're working with casts, for example, for carbon mineralization, looking how to make this challenge as an opportunity. So we're covering the full cycle for the whole, the life cycle for every water drop.
Thank you. So as far as I know, you have a very extensive experience, management experience to balance the technical performance, financial viability, socio-economic impacts, and environmental outcomes, not only in Red Sea Globe. I think probably I start from coast, is that time?
Yeah.
So could you tell me, when you try to promote the water-saving measures in water-intensive sector, for you now is a tourism sector, how do you balance these factors to ensure the solution you have are both effective and sustainable?
Yes. Actually, this is my candy shop question.
Right.
Yes, because we are at Red Sea, we are nature-inspired but science-driven. And this is the basis of how we do. We actually built a very robust operating model to assess every technology. We have very aggressive and detailed criteria. Starting from environment, which there are things non-negotiable, like environment is number one for us, and we make sure that we're following the highest standard regulations to make sure that we are taking care of the environment. Then we have the financial. We look at the financial aspect, making sure the ROI is feasible, like we are looking at the full cycle of the project from the capex to the operating cost. And then we go to the socio-economic, which is very important for us because we work with the communities, not for the communities, and we make sure that the scalability, the profitability, the value creation of the technology is there. Of course, the technical performance, which is like we try as much as we can to pilot the new technologies, and we do the validation in a very comprehensive way by collaborating with the universities and making it as like an R&D opportunity. And we collaborate with third-party labs to do also the validation with them, closing the whole loop through the life cycle analysis and how it will reflect in our regenerative goals and how we will achieve our very promising and aggressive regenerative goals. And of course, as I said, because we are like super luxurious, we make sure that will not affect the experience of the guests. It will not affect the whole feeling and the authenticity of being in this part of the world.
Very informative. Thank you very much. The next, probably I will give the question to Dr. Helen. So you are the CEO of Aquarium, and also you are a scientist and expert. So you have been worked with the oil and gas sector, mining, as well as other sectors. So especially on decarbonization. So according to your experience, what opportunities do you see from them to partner with each other and to jointly develop a water-saving technology? And what is needed to make such partnership to be more effective?
Thank you very much. So I'm going to focus on the oil and gas sector, partly because the previous keynote touched upon extraction of heat from mine wastewater, and so I won't go into that today. But the oil and gas sector actually presents a really interesting possibility moving forward. For those that are present in the room that may not realise, most highly producing hydrocarbon wells produce more water than they do hydrocarbons. And while that water is treated for the purpose of disposal, not much is done with that. However, that water is very hot. It is super saturated with critical metals, so we can do brine mining. The lithium is the buzzword at the moment around the world. And that heat can be used sometimes for power production through binary organic Rankine cycle systems or binary Kalina systems. But even what's more interesting as well is looking at what happens when the water cut becomes a problem, and from a hydrocarbon perspective, that well is no longer economically viable, and you're looking at closing that well. And we quite often find in certain parts of the world, the wells are not closed properly, and so you have this consistent methane leak to atmosphere. However, a lot of these abandoned and orphaned wells can be repurposed for renewable energy, the subsurface renewables. So if we take sort of my specialist area, geothermal, as a priority sort of for this conversation, is you can reprocess your water chemistry data, your geophysics, your well lining, your well development, your logging, using the skills and the data that already exists within the oil and gas sector, and redevelop that for geothermal. And then you can use that power or heat to apply to desalination, industrial heating. We can do enhanced geothermal systems, which will allow for abstraction or production and re-injection of cooled waters, so we're maintaining the system long term as well. And that starts feeding into how we support the oil and gas sector to decarbonize, whilst the oil and gas sector is going nowhere for a long time. You know, if we're talking about renewables and carbon credits and sustainable credits and water credits, we need to be pragmatic that this is not going to happen. This renewable story, as much as I would love it to happen, is not going to happen anytime soon. So we need to be pragmatic. And the only way to be pragmatic is to support the oil and gas sector in decarbonisation and acting as an enabler. And that's one thing that geothermal can do through abandoned and orphaned wells.
Okay, so this is cross-sector experience and information. And as far as I know, you also worked for a lot of water projects in developing countries. According to your experience, what has been the most striking water security challenges there? And how should our international organization best support these regions?
Thank you. So I'm going to give you an example from a project I worked on in Malawi about 7 years ago now. It was the Climate Justice Fund Water Futures programme that was funded by the Scottish Government. And the Malawian government initially had thought that they had approximately 20,000 functioning water points across the country, and they wanted them all mapped. We engaged with the communities right across the country. We mapped the locality of all of these wells, the level of functionality, what the water was being used for, who the donor and the drillers were, how much was being paid, who was monitoring, etc., etc. And we actually found that they had over 70,000 water points, so 50,000 under what they'd initially had. We added to the survey looking at the source point for serious contamination, so the positioning of pit latrines with respect to water points and how well they were constructed, the location of cemeteries, the location of waste tips and things like that. And we found that a lot of water points had contaminant points within a 50-metre radius. And so policy and legislation was changed throughout Malawi to change the locality of where wells were drilled in relation to other things, also where wells were drilled in relation to how far they are from a community. So there's now policy that wells in Malawi cannot be more than 500-metre walk from a community. And we also changed the contract under drilling. So a lot of donors will drill a well as soon as they're given the money. And sometimes this is right at the start or just into the rainy season. And the contract is a water strike. So as soon as they hit water in what is essentially a full aquifer, they can stop drilling. But of course, very quickly, that water level drops and all of a sudden that well becomes non-functional. And so the policy around that was changed so that drilling has to be done in Malawi towards the end of the dry season when the aquifer is at its lowest, and they have to go beyond water strike. And so the biggest challenge in humanitarian water in particular is policy and regulation around how you develop right from scratch.
Yes, thank you, Helen. My next question probably go to Engineer Sami. So VETCO, the national water company for transmission. So as a leading water utility company, how does VETCO transmit water in a sustainable and a reliable way? Could you share me with some information from your experience?
Okay. At VETCO, we transmit millions of cubic meters of water through thousands of kilometers of pipelines and hundreds of city gate and pumping stations. Okay. Such a huge infrastructure was built over decades and required close monitoring and management. To achieve that, we took many initiatives, and one of them is we established 2 performance indicators that ensure there is no leakage in the network, and number 2 is the rate of the pipeline failure is very minimum. To achieve that KPIs, we established a set of procedures and we ensure that it is implemented to make sure the water supply is secure and sustainable. Our achievement even the last year, like Alhamdulillah, is there was no leakage in the network, it's 0, and there is no pipe break for the whole year. Thank you.
Okay. Yes, even though now you are working for water transmission, as we talked, we know you also have a lot of experience in desalination sector. 10 years, 15 years ago, you have been worked in, at that time in SWAC, SWCC, right? Yes. So, as per your experience in the desalination sector, which is provides the feed to the transmission system, what experience or what lessons from your work in desalination sector can be transferable to the transmission sector?
Actually, seawater desalination plant and desalination water transmission system have a common characteristic, which is they are intensive of energy consumption for the high pressure pump. So any advancement in the high pressure pump design and efficiency will benefit the both sectors. So if we reduce the power consumption, it means lower operation cost, which means overall improvement for the system. If we look at VETCO, that we are running our high pressure pump for 24 hours, any small percentage gain in the pump efficiency will lead to huge benefit in terms of saving and environmental impact improvement. Okay. This is what I see as a common system between the production and the transmission.
Okay. Yes, so this is very sector-specific information. Next, probably Engineer Yasser. So as far as I know, before you joined the Expro, you also have a lot of experience in energy sector to manage the plants. From your experience in the major infrastructure, including the energy sector, what kind of financial practice can distinguish the water projects that deliver value from those waste public funds? Yes. And how can water-intensive sector apply these kind of spending efficiency principles to be successful?
Yes. As many of you might know, that we are in Expo are reviewing lots of projects, government projects as a mandate of Expo. And I think we can distinguish, since our position, we are the center in the government, from our position, we can distinguish that what are the projects that brings value to the government and to the entity, and from the ones that are not. Take in consideration the requesting fund at an early stage, and design, and also construction and handing over to the operation. I would think the project that have, I think the aspect of success has many aspects, but one of them we would think the strategic alignment. We would think the projects that has a strong alignment to the national initiative would be effective and efficient, and we do have an example in water sector. Most of the projects that are floated to us or to the market, we can see how the harmony and the alignment with the national water strategy. And we are lucky in Saudi that this national water strategy are managing by golden hands, SWA and MIWA, because it takes in its consideration all the intersection between tourism, industrial, and other sectors that are taking the population increasement and to other numbers. Also, I think the economical aspect, so the projects that has viability, clear viability, and what are the return of investment of that project, and as well as what are the demand and capacity study behind those projects, take in consideration what is the current assets that are aging, and the problem of, I think, of determining what are the life cycle stage now, so you can determine what is the capacity, and as well as I speak, the demand, and the demand that could be measured in the national strategy, and it has to be intersect with other strategy. Also, the commercial aspect, how would be the commercial aspect is linked. So we can see projects that are funded from government, or there is a possibility to partnership with the private sector. And we can see the desalination and also the transport sector in Saudi, and this is really something we are proud of, have moved from public orientation to private public partnership. And as I speak earlier about the levelized cost of water, we have significantly going lower in that cost, and this is brings Saudi one of the, I would say, efficient country in terms of desalination and transport as well. Also, the fourth dimension, I think, also the management, how would this project will be managed, what is the governance, who's the team, what are the entities that gonna be manage this project. And last but not least, I think the financial aspect. We see the project that are cost determination has the highest will be ultimately when it's going to be handed over to operation has least project troubled or project problem at the end of the phase. And I think also, and this is part of what I have mentioned earlier, in water sector in particular, the project that has touched the water access, the non-revenue water, the reused actually, or the treated water is really a project that we can see strategic alignment on that, and we support that to be happen. And for the energy sector, from my experience, I remember that, and this is aligned with the government direction, where to go and to go for displacement of crude oil initiative. And we can see moving to combined cycle plants, and those plants are closed loop plants running water. So those it should be closed loop, but sometimes in some practices we can see a leakage on that. And the practice before was drilling down to the wells and bring the water up. And this is, I think, with water system that have in place 4 or 5 years back, the energy sector has moved to use the reused water from cooperation with the water sector, and this is really another significant mark has been achieved in Saudi market. Yeah.
So based on your practice, especially the best practice of Expro as the government authority, what governance frameworks can issue water investment to be cost effective and also deliver measurable outcomes? So what can water intensive sector learn from this practice?
Yes, I think from our position, the government, we can see, we have the luck to see different sector within the government, the energy sector, water sector, municipality, and etc. And I would think, from at least my view, the water sector has the highest complexity, because you're not talking about only production and transmission and distribution, and I think this themes has been shared with other sector. But when you look at, it's not stop at this stage, you go for the wastewater access first, then you collect the water, then you transport the water, the reused water or the wastewater, and then you go as well to treat this water, and actually you will do also the transport of the treated water. So it is really a very big chain comparing to other sector. But I think, backing to your question, the governance, I think if we do have water sector or itself, the right roles and responsibility, the governance, where we do have very clear mandate or very clear responsibility, who's the legislator, who's the regulator, and who's the service provider. I think this is going to be solve lots of problem and accountability, and also the effectiveness of delivering the value to the consumer. And I would think the generation sector, if you look at, or production sector in water, it has actually many entities as well in Saudi, and this is really another achievement. We would second the thank that I said before. And we also have, it's an energy sector and gas sector, but water sector has been really evolved the last 5 years in Saudi, and we can see all the water that have produced from production now is going through off-taking agreements, and we are buying this water through, the ultimate goal is to have the cheapest, or the, I would say, maximum spending efficiency by introducing the levelized cost of water, and this is really a remarkable things that happen in our country. And I think this practice have been there in some other sector, and globally it's been used, but with the right governance, you make sure this will be continue to evolve.
Thank you, Engineer Yasser. From the government authority point of view, and then Milan, because you are responsible for private sector policy in water aid, so when you collaborate with the private sector to promote water conservation measures, what are the most effective incentives from, for example, reputation to finance, which can convince a company, the private company CEO, to realize that water is a core business priority? So could you share with us some discussion?
Yes, we're really happy to. So at the end of the day, the question is, how do you make the business case for these investments? How do you make it so that it elevates the topic of water into an arena where it becomes business sense, right? And I'm going to go back to the panel, the keynote that happened just before we came on, and the panel before that, where it's really around kind of two dimensions. It's around risk mitigation, and it's around opportunities and returns on investments in these cases. So on the risk mitigation side, if you're looking at a lot of the discussions that we've been having now, the questions around how do you help companies understand that investing in water security is an investment in addressing three kind of dimensions of risks, right? Kind of the physical risk dimensions, in terms of what ensuring that companies across their operation supply chains have the amount of water of the right quality to ensure the sustainability. And you've seen increasingly in many parts of the world an encroachment towards day zero, right? Where there's a worry about the lack of water in many places. You also see in many places flooding risks that have direct potential impacts on companies' operations at the same time. And we just heard in the keynote before the amount of high-quality water that's needed for semiconductor development. All these kind of encapsulate the physical risk dimensions that companies really need to understand. And that really raises up, right, in terms of when companies and CEOs and the C-suites are looking at the risk factors and the financial case for it. We also, in my example, the first example I gave, was around the regulatory risk environments. As governments are looking to increase sustainable water management, regulatory changes are happening in a lot of places. They are moving towards encouragement of companies and others to implement more sustainable water practices, and this is going to create changing regulatory environments that companies will need to respond to in these places. The third dimension, right, is around the reputational aspects to what your point. And for those companies where brand recognition is so important, we've seen protest movements where we're looking at bottled water issues, and where I grew up in California, bottled water issues were a big issue, right, in terms of companies taking water from people. At the same time, a lot of discussions right now around AI and water usage and AI, and potential backlash against these new technologies and the systems that are consuming a lot of water, and the reputational aspects around that. So those are the three dimensions of risk factors that companies really need to understand. In addition to understanding that the risks that they face are jointly are the risks that exist in a basin, right? And that they will actually need to work with others in order to address those risks. And this gets down to the collaboration aspects, which I'll touch upon. The other side of this component, right, is the opportunities, the return on investment case, the financial case for if a company was to invest in water security, what are the returns? And from a water access sanitation aspect, WaterAid has been working in this space for a while, and a few years ago, we commissioned a study called Boosting Business that really found that for every dollar invested in water sanitation solutions, they usually see a twofold increase in returns around this, because employees have greater efficiencies, more productivity, less absenteeism, and this is good for business, right? So this ability to make the quantitative argument for investments is equally important as the risk management side of the equation.
Okay. So as you worked with the private sector for those companies, based on your experience, what is the most commonly overlooked water risk for those companies? So when promoting water-saving measures, how can we ensure the equitable access and use of water resources?
Yeah, so WIN Series, which is a nonprofit based in the US, has been working on an initiative called the Valuing Financing Water Initiative. And in that, they benchmarked 71 of the largest water impacting companies in the world. And what they saw in this benchmarking exercise is that there were two key areas where there is not enough attention. One is on water quality interventions. The other one is on water access, sanitation, and hygiene interventions. So from a WaterAid perspective, we have been working, right, to elevate the need for companies to invest in WASH arenas, not because it's a nice to do and it's good for people, but that it's core to business stability and longevity and resilience over long term. And you see that, right, in terms of just people investments in this case. And it was highlighted even more during COVID, where you saw that, unhealthy workforces leads to a decrease in economic well-being and growth for economies overall. So that's one of the areas that we are really focused on. And what we are working to work with companies on is to make the case for joint investments to address those shared challenges in basins. And I'll give an example of a project that we're working on. It's called a Women in Water Collaborative. It's in India in 3 basins, and this is done jointly with the Water Resilience Coalition which is a large collaboration with over 40 companies that have dedicated themselves to achieving a positive water impact by 2030, by 2050, apologies. And so in this scenario, what we're looking to do is work across industry sectors in these locations. So we've got 8 companies working together, from pharmaceutical to technology to apparel, working with municipalities, working with NGO, WaterAid in this case, to really improve piped water systems for the benefit of their workers and their workforce within these locations, and to ensure that long-term sustainability of their production and resources. And so this is, you see, it's cross-sectoral and it's long-term. So our goal in this case is to reach 2 million people through these investments, and it's an outgrowth of a project that was initiated by GAP and USAID a few years ago, and it's grown in scale and reach. And we're trying to replicate this in other kind of economically important regions for companies, and also in Lagos, Nigeria, and also amongst the apparel sectors in Cambodia.
Thank you very much. So today we have very intensive and informative discussion with our panelists from different professional backgrounds. Thank you very much. And also thank you very much for the audience to join us. So please join me in thanking our esteemed panelists for their invaluable insights. And I think our discussion ends now, but the real works start now. Thank you very much. Thank you.
Going forward.
Thank you very much for our esteemed panelists and Dr. Lee for such an engaging discussion. It's clear how collaboration and innovation are key to driving water security in a water-intensive sectors. The Saudi Water Authority would like to present to you a token of appreciation as a thank you for your invaluable participation. Thank you very much, our esteemed panelists and Dr. Lee, for this engaging discussion. It was very insightful and informative. Thank you very much. Ladies and gentlemen, we're now stepping into one of the most transformative themes of our life, the AI and the digital transformation. From harnessing the power of AI and the IoT to revolutionize the water systems, to exploring how digital innovation is reshaping urban infrastructure and also how it's going to drive sustainability. Our upcoming session promised to inspire and to inform, so let's get started. Ladies and gentlemen, now we have a keynote presentation that is going to explore how the AI and the IoT and the predictive analytics are being integrated into utility infrastructure to enable real-time visibility, to optimize the distribution, and to support the national smart city agendas. We're honored to have with us Lei Jiang, the Vice President of Shenzhen Water and Environment Group and the Chairman of Shenzhen Water Technology Company, to share his vision for the future of the digital utilities. Lei Jiang, the stage is yours.
Ladies and gentlemen, good noon. My name is Zhang Lei, Vice President of Shenzhen Water and Environment Group and the Chairman of Shenzhen Water Technology. On behalf of our group, it's a great honor to be here today to share our practice in smart water management. So my presentation will be three parts. First one, the presentation of our group and the city. Second, innovation. And the third one, the vision. Currently, the world faces a challenge like water scarcity, severe water pollution, and frequent water-related disaster. In this context, how to solve this complex problem by leveraging digital technologies has become actually a critical question that we must answer together. So the digital transformation of the water industry is accelerating. It's projected that the global digital water market will reach $54 billion USD by 2030. The new scenarios, products, and models emerging from the transformation are driving huge increase in productivities, presenting significant opportunities for the industry development. This is our city, Shenzhen. A major window of China reform and opening up is a Totally, as of today, water supply and drainage treatment capacity exceed 15.2 million meter cube per day, so serving almost 3.5 million customers. There is a pioneer national leading demonstration model for integrated water supply and drainage operation with my company, Shenzhen Water Technology, focusing on the smart water sector, processing capability in automatization, software development, intelligent products, research and development, of course, the smart operation and maintenance. And our technical innovation have been awarded by the National First Prize for Scientific and Technological Progress in 2024. And during the same year, our group joined the Global Water Leader Group, becoming the first mainland Chinese member, gain global recognition for water operation and maintenance. Guided by the digitalization, we are currently enhancing modern water governance capacity. This is our achievement. We have achieved a breakthrough in several key indicators. The tap water quality compliance rate remains consistently at 99.99%, almost 100%. Urban water logging defense standard have significantly improved. Now we can handling is achieving elastic allocation and IT resources, including the monitor in real time 3.5 million smart water meters. And secondly, we constructed a digital twin system for whole water supply and drainage cycle, from source to the water shield. We integrate beam, GIS, and IoT data from water diversion project, plant, municipal pipeline network, and reverse basin within the city's SIM base, achieving digital twin management for the entire water system from design and construction to operation. For example, we can see here our digital twins water plan based on BIM model, creating a 3D visual as well for our water and the drainage network. There is a daily on-time supervision. And the third characteristic is our AI application to achieve the goal of involving intelligent agent for plant, pipe, network, water, environment, customer service, etc. So currently, we are integrating the Shenzhen Water Cloud brand with technology to create a smart construction management platform for whole water project. This enables intelligence whole process control of a project quality, safety, progress, and investment. Notably, we apply BIM technology to the design and the construction of deep water transmission tunnel, preserving precision shallow underground space for the sustainable development of our megacity. So, next is we have a deeply integrated digital technology into the entire life cycle management. Saving 60% of the surface of our construction surface. As well, we have a Nanshan water plant, which is with a capacity of 1 million cubic meter per day for the production. We implement the solar panel, fully covering the plant's high lighting needs and provide a stable power support for low voltage production equipment such as dosing system, valves, and security system. And we do have also the Honghu wastewater treatment plant. It's the first fully 5G covered underground wastewater treatment plant. Thanks for whole fully processed smart control, we achieved for the chemical saving more than 16% per year, electricity saving 15%, and the investment saving 5 to 10% is real money, and the last one, the human cost saving, more than 50%. So before, for one water 8,000 kilometers of water supply. We use GIS plus BIM plus LT plus SIM to perform online monitoring and simulation of both statistic pipeline information and dynamic data like water quality, pressure, and flow. This allows us to build dynamic visual health assessment model and early warning model for abnormal event in the pipeline. So, thanks to old management and system, pipeline leakage rate in Shenzhen now has been reduced to 4.6% only, equivalent to annual saving of more than 12 billion cubic meters, is equivalent to more than 470,000 household water consumption. Beyond the common leakage management practice, we built a citywide leakage management system in Shenzhen. It enables early warning detection. So we have a 3 level. We got the plan level, district level, and the neighborhood level for the management, for the MBM management. This results in the decrease of pipe burst rate by 30% in risky area. So to saving our residents, we still have our agent, intelligent agent, we call the Shen Xiaoshui, so which continues service for 7 per 24 hours availabilities, and with more than 200 specific tags, we build the user profile with effective identification and water security risk. Our intelligent agent scans the entire pipeline every 5 minutes, automatically identify pipe burst, simulate repair. Analysis robot drones for sampling, delivering, result in saving our chemical cost by 30%. And we focus on key area like we have also developed several priority technology. For instance, our Shenshui AOA breakthrough wastewater treatment process achieves extreme denaturation. Penetration rate of AI to 90% in 2027 and 100% in 2030. This to evolve from single unit intelligence to group intelligence. And currently, our group formulated a comprehensive AI innovation roadmap for water system. It focuses on addressing the key point from raw water intake, treatment, distribution to the users, then collection, treatment, and finally the water environment. We are building AI models and driving technological innovation. We also enhance our smart terminal product for the water sector with an AI identification capability and the plant level. We will progressively build a production and application. So we are confident that our AI vision by 2030 will inject new momentum into the sustainable development of the Shenzhen environment and the group. So we have a environment and the water group have a mature and professional capabilities in solution design, product development, product construction, and investment. So we are looking forward to cooperate with all relevant parties in Saudi sectors, hand to hand for innovation and unlock the potential of every drop of the water. Thank you.
Thank you very much, Mr. Lei Jiang, for that insightful presentation. Kindly accept this token of appreciation as a thank you gesture for participating in the conference and for sharing your invaluable expertise with us.
Okay. Thank you.
Thank you very much. Ladies and gentlemen, and in a powerful step forward transforming the water sector, the Saudi Water Authority, together with Oliver Wyman, has released a forward-looking report that actually dives into the future of infrastructure, digital innovation, and also the circularity. So how these forces are reshaping water management around the world. You can actually scan the QR code to explore the full insights right now. Our upcoming session, ladies and gentlemen, takes us into a deep dive into how the AI-powered analytics and the IoT-enabled infrastructure and advanced digital platforms are being used today to tackle the challenges of water scarcity and the environmental sustainability. This presentation will also explore how these technologies enable smarter resources allocation, predictive maintenance, and enhance customer experiences. Together, let's welcome Tsai Guangyu, the Vice President of Global Public BUMECA region at Huawei, to share his expertise with us. Welcome to the stage.
Good afternoon, ladies and gentlemen. So very appreciate SWA and can give us a chance to do the presentation here. So I'm Richard. So today my topic is the AI accelerate water digital transformations. Just now, not my colleague, because Zhang Lei is also my friend. So he already gave a presentation regarding the Shenzhen, the water system. And now I will give more the technical presentation from the AI aspects. So firstly, please allow me take several minutes to introduce our company, Maybe most of you are aware of Huawei from our Huawei mobile phone. But honestly, we are a technical company from China, but we provide the global services. And from this the corporate revenue, you can see that for the first half of 2025, our revenue reached to 59 billion. So as an expectation, so for this year, our revenue will be more than 100 billion US dollar. So here, from 20 21, you can see our revenue dropped a lot. It's because of well-known reason, because we are get some the technical sanction from some other country. But fortunately, okay, we use 3 years. We go back to the road to the growth. So our business focus on the 5 aspects, the ICT. So we provide the 5G, the telecom, the services, and we have the smart devices, Huawei mobile phone. Okay, we are the world first, the vendor to provide the triple folder, the mobile phone. And we also provide the clouds. So globally, we have 101, the availability zones. And we also have the digital power. Now, based on our services, we reduced 890 billion tons the carbon emission. And we have the intelligence, the automobile solutions. And in Saudi, we started our business from 2002. Okay, so far we already provide our services in Saudi more than 20. The large model, we have the ChatGPT, and we have DeepSeek. So many the AI, the platform established. So AI are more and more widely used in our life. So Huawei, we are a technical company. So we are just thinking about how to use the AI technology to solving for different industries, including our water industry. Sorry. This is the digital transformation for water management. Okay, so there are main 3 stages: informational, digital, and intelligence. And now we are in the intelligent stage. So the next, I will take maybe 10 minutes to describe how the AI technology can enable our water digital transformation. And we think about we should set some targets for our digital transformation, okay? So here, we just list the 5 aspects. It's just for our consideration, maybe cannot cover all. The first one is unmanned operation, and also okay, so we should use the technology to, instead of the human works. I'm not saying we will 100% to cancel all the human workload, but we should think about how to use the technology to improve the efficiency of our water management. So here, I use the picture. So we should use the sensors. Here you can see the noise monitoring, the water level monitoring, environment monitoring. We should use different kind of the sensors connected to our devices to transfer the data to our control center. So in this way, so we can get the real-time the situation of the devices in our smart water plants. So we no need to take some human, okay, take a human workload to always monitoring the devices. So this is just saving the time and improve the efficiency. We should also use the camera. We should use other some sensors to cover the water plants, okay? Then later you will see how these devices working together to reduce the manpower workload. So here we just show some samples. The CV, computing vision, is one of the key technology of AI. And flooding identification. So all these videos can be distinguished by AI technology. So if this is a normal situation, a normal events happen, the AI can tell us, okay, there are some problem, please handle it. And based on the AI technology, so we can also establish the unmanned laboratory for the dosing for different kind of systems. And we can use the robots to do the indoor, the pipe gallery monitoring, and the intelligent robot presence assistance. That means in future we no need our engineer, okay, to just patrolling in the water plants. We just use the robots. They can patrolling the water plants automatically and take back the photos, the videos. The next one is the safety, because for our smart the water plants, we think the safety is the top one, the priority, okay? So based on the AI technology, so we also find it immediately. After we find some abnormal things, okay, so how to handle it? We also need the AI to support us to do the emergency response. Here, I just show one sample. For example, there is the alarm from the flooding, okay, flooding the events. So firstly, the system will announce these events to all related teams. For example, the communication team, for example, the emergency team, even maybe some manager team. So the system will announce this the station, the gates. Then we should close some other, for example, dosing room or other things. So all these steps can be fulfilled one by one. So this video we just take from the real system we already deployed in China, the water plants. And the third one is we should build in the green the factories. With AI, we can use the intelligent algorithm to full process plant and the station operations. We can stimulate the operations before we deploy some new process. And this energy consumption management system based on the beam, with the AI, with the beam, we can also do the analysis, okay, to how to saving the energy. And the water quality
yield rewarding based on the time, the quality monitoring, and intelligent dosing system based on the experts, decision makers. So this is also the AI can use for this situation. So longitudinal, the energy saving control based on the plant-wide, the water balance. Okay, so in a simple word, the AI can help us to generate some new plans, some new algorithm to improve the efficiency of the energy saving. Here is an well to check maybe some devices have some problem or something. But in future, with the AI technology, we can support this automatically, the patterning with the video. For example, the first step, the dosing room, okay? So we can check the dosing room is okay or not. Then the next step is the blows solve the issue. So in this way, we can also make the green, the factory. For sure, we have other tools, precise management, and but because time limitation, I didn't go to the details. But based on all these AI technologies, so in a simple word, we can achieve the expected economic benefits. For example, the overall electricity consumption reduction 5%. Okay, the overall chemical consumption reduction. The statics we can get. And also emergency response time reduced more than 20%. And the work efficiency improved more than 50%. So that's why in the beginning I said unmanned the system. Our target is not 100% to cancel all the human beings, but we want to improve the efficiency. This is one case of smart water plants. In this case in Shenzhen, I think in future if you have chance, you can visit Shenzhen and we can take you to this site. And this is the world first, the water plant covered by 5G. Based on the 5G, so we can connect to the AR. We can smart plants. At the same time, we need this end-to-end security solution. We use the unified operation and maintenance the features to managing all this architecture. Based on this architecture, then this and the digital culture, we should have the inclusiveness, the lifelong learning, and the reskilling, and the data the scientists. This is the preparation for our digital transformation. And the third is the infrastructure, as I mentioned, the RISE architecture. So because in Saudi, we have 32, the water plants, okay? So for all these water plants, maybe we should use this solution to make the digitalization. And then the next step, we should connect all this, the water plants together, okay, to control, to share all the resources. And the water is a partial of the smart city. So we see Huawei, we also have the smart city solution. So the water, the electricity, and the smart garments, all these things can be covered by the smart city solutions. So we have the booth in the hall 2. If you have any interesting or you need more discussion, maybe we can discuss more there in hall 2. Huawei has a booth there. Okay, so AI-based smart water plants, in one sentence, this is one factory. But more than this is the one garden, it's one hall, and it's one corridor. Thank you, this is my presentation. Yeah.
Thank you very much, Mr. Tsai.
Yeah.
Kindly accept a token of appreciation presented to you by the Saudi Water Authority to thank you for your invaluable participation and contribution to this conference. Thank you very much. Ladies and gentlemen, let's move on to a panel discussion that is going to explore how the digital water is being integrated into the urban systems to create what is called the cities of tomorrow. This session will highlight how the water utilities are aligning with the smart city infrastructure using AI and the IoT to automate maintenance and to reduce water loss and integrate with emergency response system for a long-term urban resilience. Moderating this fascinating discussion is Engineer Abdullah Al-Jabri, the Executive Director of the Saudi Water Authority. Together, let's welcome him and his fellow panelists to the stage. Welcome, everyone. Looking forward to this very insightful discussion.
Alaikum warahmatullahi wabarakatuh. Ladies and gentlemen, here to to discuss about this panel, and we're going to start with speaking about the title itself, with new emerging technologies and the widespread use of AI and the need of a digital transformation. We just need to discuss more into our panel about what it does mean to have an urban digital water city, how we can achieve this, the targets needed, the technologies that we're going to have to use to reach this title of a city. And this is something that we're going to discuss with esteemed panelists over here. And let's start by introducing the panelists to you. We're going to start with Gigi. Go ahead, Gigi.
Hi, thank you so much. I want to first start off by saying thank you to His Excellency and the Saudi Water Authority and the organizers for this invitation. ولو ممكن أقولها بالعربي أنا عايزة أقول شكرا قوي قوي على العزومة الممتازة دي، وأنا مبسوطة قوي عشان شايفة سعودية قدام خالص في الحتة بتاعة المية. شكرا.
عفوا جيجي. So we're going to start again with Ben. Go ahead, Ben.
Thank you. So Ben Ernst, work with Suez in digital innovation, based in Dubai and with a scope over UAE and Saudi. And we work with water utilities to help them find opportunities for sustainability improvements in their operations, improvements in innovation, artificial intelligence and automation, and help them execute those.
Good, thank you, Ben. Stefan?
And I'm Stefan Shulkarski from DHI in Denmark. We specialize in building digital twins for utilities and using computer modeling technology, combining that with data as a way of enabling digital twins of a holistic water utility.
Thank you, Stefan. Krishna.
Thank you for the opportunity and having me over here. My name is Krishna Prashant, also known as KP. I work with ABB. At ABB, we try to help our clients and our customers transition from a linear water economy to a circular water economy, and we try to do that using cutting-edge innovation and technology. Passionate about water, music, and I do a little bit of blogging, but extremely pleased to be here. Thank you for having me on the panel.
Absolutely. Joaquim, you can go ahead.
Hi, so my name is Joaquim, so I'm based in Portugal, but Douro is a company that is a subsidiary of Metito, so working in the region for a long time. And all my life I've been working, professional life, working with the data and trying to bring utilities up to a level that we all want to adequately manage water.
Good.
And thank you.
Obrigado, Joaquim. Thank you. So we can see that we have a very close technology-based esteemed panelist. Of course, we're going to start again with Gigi. We will start with you. Let's understand more and discuss more on what does it mean to have an urban digital water city. Is something like, I have a smart meter, is that something would earn that title, or we're going to have to understand more into the name?
I think we're going to have to understand more. So just a little bit of my background. I have 30 years in digital technology, first in data communication, and the last 14 years in the water sector, working with water utilities on digital transformation, digital twin. And of the last year, I have spent on a research project with the Water Research Foundation and AWWA and WEF on this idea of generative AI for the global water sector. So before 2023, I used to think of digital water as structured data and doing data analytics to gain some insights so that you can make better decisions. And now, after 2023, with the role of generative AI, I think it has expanded tremendously. So now, generative AI brings in unstructured data. And when I say unstructured data, I mean videos, emails, handwritten notes, voice memos. All of the 80% other data in a water utility is now combined or fused with structured data, sensor data, SCADA data to provide analytics so that you can get insights to make better and more informed decisions. So I think that changes quite a bit. It allows us to do more with soft sensors. It also allows for a knowledge layer on top of digital technology so that anyone can start to understand it. We hope that generative AI will take dashboards and understand the concepts behind all of the different KPIs and put that together in a human narrative so that it can help the operators determine how to go about their optimized decision making.
Good. So we understood that we're going to have to transform in our infrastructure, in our sensors, in our how we're going to deal with our data. How would we need, or how much would we need to invest into our legacy infrastructures in terms of equipment, into our assets, into our cities? Where would you start with this spin?
So that's a great question. I think the legacy systems that we have, they're both an asset to us, and in some ways they hold us back as we go forward in our digital transformation. I think it's important to value the value that those systems bring into our modern information systems, to build layers on top of those. So some of those are possible to evolve, and some of those they kind of have to stay where they are, and we need a layer of cybersecurity protection around those. But we need to manage those for both the asset they are and the risk that they are, and invest in them in a measured way, so that we're improving the value of our system as a whole while still allowing us to move forward.
Good, perfect. Stefan, we heard that we understood the city, we understood that we're going to have to invest, but what are the targets that would get the name? Until now, we're going to have to touch base into something of a KPI or a target or a figure.
Yes, look, I think when we think about the KPIs of the modern water utility, a digital water utility, it's also good to look at the legacy. I think in the past, we ran water systems at steady state. I would say they were built to run, and they ran at a certain speed, and it's set and forget. But that's inefficient. It's very reliable, but inefficient. And what's happening today now with digital systems is it's about gaining efficiency by following the diurnal cycles of the utility of the water flows and making sure that we use the information we've got to adapt quickly to the utility. So once we start to do that, we can start to save things like energy. We can actually utilize energy when it's cheaper, not more expensive. We can minimize chemical usage. We can minimize CO2 and nitrous oxide emissions from treatment plants. We can also minimize things like overflows that would tend to occur into receiving waters. So all of these inefficiencies in the system now, we're working on continuously to minimize them, including things like leakage. You know, we all know the problem with leakage in water utilities today. Now, of course, we're trying to reduce that and make it more efficient. So that's the KPI, is looking at the efficiency of our business at every level.
Good, perfect. I'm going to have to stay with you on this one because we have touched based on a certain criteria we're going to have to look for to reach the title of an urban water digital city. So saying that we're going to have to monitor our leakage, check our infrastructure, how we're going to make sure that we are reaching those targets using the same legacy, or we're going to have to invest in an entire changeover of an infrastructure?
Yeah, look, I think when we talk about the legacy systems, I think a lot of the data foundation and the governance required for a digital utility doesn't exist today, and that's being rebuilt, and that requires then that the legacy systems adapt to that new governance and data framework. And I think right now those foundation stones are what we're globally trying to build into water utilities so that we can then set the scene to digitize. I think historically we've been working in different areas in the utility, and they all have their own data systems in different parts of the utility, but they're not integrated into a governance model and a holistic data framework that allows us to look at the whole utility as a whole.
Good, perfect. So, Krishna, how would we support the water utilities, the companies that would run the entire systems into a more, let's say, aggregative approach to reaching the right KPIs, making sure that we are getting the right data using our sensors, IoTs, and equipment?
Yeah, absolutely. I mean, it's a very interesting conversation that we just heard. The thing about the good news is we are not alone. Yeah, literally 50% of the world's water is being wasted while it is being delivered. So, I mean, I don't know how many of us would allow a bank to lose 40% of our money and say that, hey, let's get more jobs and more money back into the bank. We don't, right? So the good news is we are not alone. The good news is also that it is not, the gap that we have is not a gap of technology or sensing or of data. It is starting out with realizing that there are too many local silos in which problems have been being addressed by utilities. And this is where I think it's useful to think of it in a holistic perspective. Let me give you a simple example. So all of us have seen different water networks, and we have specific areas of problems. Let's take a typical problem, energy consumption. And energy consumption is a problem. Why is it a problem? Because energy costs money. That's one thing. But the other reason is that energy is used for transporting the water and treating the water, and every time you lose water, all that is lost, right? So we just don't want to do that. But how do you know best? The problem goes back to the same thing. If you have a shop and shoplifters are stealing your loaves of bread, you install CCTV cameras, right? You don't just ask for more bread to come into the shop. And that's the solution. You need more ears. So I was very intrigued by this term future of water and the vision that we have here in the kingdom. Really impressive. I think this is the right time to really start looking at the entire water network. Imagine a city by 2030 is the vision, or around that period of time, where every drop of water is heard. You can sense every single thing. But it's not enough if you're just sensing. If you need to package this in a way that is contextual for people to take decisions. Yeah. The big myth is that digital water is about data. No, digital water is about decisions. Better decisions, more solutions that are there for all kinds of problems. So I think there is a great opportunity that we have in this space to try and address some of these things.
Absolutely, I do agree with you. Now we heard about sensors, IoTs. We want to merge on how we're gonna do a holistic ecosystem for this. We're seeing new emerging technologies, utilizing AI, for example. Having a digital twin would make you understand your urban city more. What would be the new emerging technology that we have to have within our digital waters, urban city?
Well, I always think we need to start from the bottom. We need to get support from the top. So when we are looking into this, and I think digital water is water. So we are talking about water, and we need to start looking at, around. And as Krishna was saying, there's something very important about the data that we are using, that is context. And providing that context to the users is fundamental. To build that holistic vision, we need to understand in the end what we want to look at, and so what data can I use to make it useful. Okay. But also when we look into all these systems, into all the ways that is viable to produce data nowadays, sometimes we forget that in the end we want to bring that knowledge. AI will translate that in an easier way, because given the way that the technology is evolving, with this big span, the overall that we can get, it will be much easier to track what we are doing and to get, as everyone was saying, what now is being introduced or translated as explainable AI. Explainable AI is something that will provide you that context for the user in the end to understand what is going on and to support the decisions that need to be taken. So I think we are on that path, building this evolving way of doing things. So structure from data into information and bringing out that knowledge. And all systems can work together. We talked a lot about interoperability. I think that's a key term here. But things are changing so fast, and fast in a way that they are really ready to help us to take those decisions. And so this holistic vision, with the systems that we have in place, with all the software providers that are coming in the end, we are creating that value. And I really trust that with this chain of value that is being created, with the tools that we now have, it will be much easier to take the right decision.
I like your approach. We're moving way too fast into this.
I'm sorry.
Yeah, but that is the part it is. Are we moving too fast? Are we going slower? In terms of a pace, do we have to make sure that we have the right technologies? Is it mature enough? Should we just enhance it or implement it right away and then later on say that we're going to optimize it piece by piece? So are we ready? Are we not ready? Can you tell us more?
So I think we need to work at those two speeds.
Okay.
Sometimes slow. We need to understand what is going on, how can we improve that data that we are working with, but at the same time, we need to take advantage of what is there. And if we have access to this technology, let's use it to our benefit, right? But when using it to our benefit, identifying which are the key points, where can we benefit the most, and in the short term, what decisions need to be taken for us to use that data in the most structured way. Obviously, this will touch other points as policies and regulation.
Exactly.
But we can discuss that later if you want, or if I'm going too fast.
No, it's okay. It's not you're moving fast. The technology itself, it's moving fast. And this is the other part where we're going to be touching base on the governance side and what we have to meet in terms of our cybersecurity requirement, security of our data, just make sure our assets, it's safe. So if we are moving too fast, like the technology itself, not Joachim, but if we're moving too fast and we're just dropping part of our guard down, just what we're going to have to take into consideration to make sure that everything what we have in terms of assets, data, our new emerging technology, it's safe. It's safe to mature, it's safe to be enhanced, it's safe to give us the optimization that we need. You want to go, Gigi? Go for it, Gigi. We'll go back to you,
I want to
Krishna.
add to...
Is it to me?
Okay.
I'll get back to you, Krishna.
Oh, my apologies.
No, please.
Okay. I just wanted to say something about the technology moving fast. So we in the water sector, the global water sector, have always lagged behind technologically for other sectors because we are dealing with critical infrastructure and human lives are at stake. So we have to be extra careful for sure. However, I have been part of a research project, like I said, with 22 utilities around the globe that has started to look at generative AI. Most of the utilities today are banning generative AI because of fear of one, job loss, but two, cybersecurity. Okay. We found that in our experimentation that if you get a enterprise version of these large language models like OpenAI, enterprise version or something, it has the same cybersecurity compliance as any other digital technology that you bring into the water sector. So my ask is for water utilities around the world to start embracing this type of technology because it's going to impact everything that we do. It's going to impact the modeling, it's going to impact the knowledge layer on top of the modeling, and also it is one of the most profound, accessible technology with the number of capabilities is unbelievable. It has data analytics, it has computer vision, OCR, all of this. So I think this is one thing. It is moving fast, but we in the water sector should also be lock in step and make sure that we don't get behind on this one very powerful technology.
Good. Perfect. She's shedding light from a consultant point of view. You're going to have to shed light from a provider point of view.
No, the thing is, history is replete with examples of technologies growing so fast and being put to the wrong use. Yeah, we all know for it. I mean, I was just telling backstage to you, and this reminds me of this newspaper article that I read I don't name the industry, an industrial output had polluted water, and the technology was so advanced that we precisely knew exactly 683,284 liters of water was dropped into the river in 3 months' time, right? So the accuracy and the amazement of technology sometimes makes me wonder, if you had such a capability, why wasn't it stopped in the first place, right? So I think a part of the answer is to really not look at technology as a driver for anything. What is the problem that we are trying to solve? So we say technology is going fast, but some of these technologies that we are talking is also used in many industries. The irony is, if a refinery shuts down for a day, it's the headlines in the newspaper. If a water pipeline breaks down in the streets, nobody knows about it, except unless you notice and call them, So a little bit of the problem starts with the perception that water is free and it is right, but it's really not the H2O that we are really worried about. We are worried about the process that we are bringing it to there. So coming into technology, interoperability you spoke about, this is at least decades old, that everybody has realized that if you operate in silos, it's going to be a problem. And therefore, it is important to adapt into copy and mimic from other fields, other technologies. I would advise many of my clients to actually look at technologies where data is used. You don't use a data-based communication, you use event-based communication, right? We see a lot of places where there's lots of data in water utilities. What do we do with it? Shall we run some AI on top of it? Shall we run some modeling on top of it? And sometimes it is overwhelming. There's so much of data without knowing what to do. And that's where it is important that the devices on the field are able to provide information, not data. They are able to provide insights, not data. So, and that is why you see these kind of technologies like MQTT, Spark-Plug-B, or Ethernet APL, etc., which are all designed for a world where you can handle terabytes of data at the same point of time. You don't have to be worried about a few kilobytes. But you don't want to spend a fortune paying for terabytes of internet data time all the time as well. You need information when you need it, contextually, and you don't need it. I think one of the important steps digitally to look forward is to try and focus on the context of what problem we are trying to solve, and then try to use different technologies, including AI, to address it. Yeah? So that's how I think it's the best way to approach this problem.
Perfect. That's one of the parts and where we have to make sure that we have the right layer integrated with each other. We have our asset layer, and we have our IT and OT layer, and then we're going to have to go to the computational and process side of the data part. So all of these transactions later on, when we build it, we're going to have a huge traffic of data over here. So our IT engineers would go crazy into this, saying that we're going to have a high transaction over here. And here comes over here where we have our multi-cloud structure. Everything is moving on the cloud. How we can support and make sure the transaction is getting to a minimum. We're optimizing our services over here. We're not just capitalizing or investing into something, but we're investing money into the other side of it.
The important thing to make sure, a few points that I'd like to say. First of all, one of the elements I think some of us touched is security as well, right? When there is so much of data, and if different people have access to data, there is a big problem. So it is very important to invest on zero trust. Yeah, you don't trust any of the systems or anything. I mean, in general in life, we have learned now that, you can't leave my mobile phone without the password locked. We have learned that much. And that is true for all these systems as well. And so the choice of technology that we take is going to be super critical. You don't want to leave your pump optimization to only a cloud. You want to have more and more on the field decentralized decision making. I don't know how many of us drive these modern cars. Earlier days, if you had to brake your car, the information would go to the central computer system and then decide to slow down your car. Today, the brake can decide. Similarly, a pump can optimize itself. Pressure zones can regulate themselves without having to always necessarily reach out to the cloud. So there are that kind of mechanisms. And more importantly, it is very important to notice, as much as AI and technology is being used by all of us, there are hackers out there breaking it every other day. So this is never a one single solution. It's an evolving process, and to stay on your toes with cybersecurity standards is super critical when it comes to these kind of deployments. Last point, you're right, it's overwhelming for the IT guy. I mean, we probably want a lot of IT guys handling a lot of data, and I think this is where context really matters. I was in a water utility, very good investments, a lot of SCADA and modeling and sensors and everything. And I'm going to the operating room. You can see the screen. There is a leak. There is an event. But there's nobody in the operating room looking at it, right? The guy is out of his shift. He went to have a cup of coffee. So in reality, this is too much for anyone to handle inside that room. What we were able to realize is that we need to package it into actionable items, prioritize it in this fashion. So not a screen full of alarms and not a dashboards of KPIs, but really actionable items is what helps the people go on to it. So yes, we need to also address the fact that there is reducing workforce, aging workforce, and skills and reskilling of operational personnel is a challenge today. So we need to try to be able to do it like I was saying. Hey, can my grandmother manage a water utility? If you can provide a system like that, that's the system for the future. Anybody is able to take a decision and decide to be able to prioritize and take a look at it. I think that is the ambition and vision that we should strive for, and some sectors have been doing that as well, and it would be very important that we focus on these things when we look at the water industry as well.
Good, perfect. What I'm getting from this is that we're automating our systems, we're reaching an autonomous level of decision making into our system. But Stefan, how we can help this into our policies on a utility level, into our city level, and how we can ease our new technologies to the operator themselves and to the policymakers themselves?
Yeah, look, I mean, what Krishna was saying was very important here, but I think in a digital utility, we need to take a holistic view of the entire utility. So when we build a digital twin, we need to connect the wastewater treatment plants with the water network, the water wastewater network, the water distribution network, and even with the energy system, where we're looking at how we're using and consuming power. So we need to look at the entire system, and then also the impact it has on the environment, on the receiving water. At the moment, when I look at a digital utility, it tends to be happening in silos. So we might have the water distribution silo, the wastewater network, or the treatment plant. They tend to operate in their own environments, but actually they're interacting in ways that are not necessarily well connected today. So from a policy perspective, we need to set a vision of what is a digital utility at the very top level to say, you know, if I have a rainfall event in the stormwater system, I'm likely to have a water quality event in my receiving water in a couple of days' time. And a digital twin should be able to give you that information very quickly up front so that you have a couple of days to react before that event happens. You can even look at scenario planning in real time before the events happen. So it gives you more time to plan your response to something, some action that might happen. And I think today that's the next step for digitising utilities, is to start connecting those different silos across the utility.
Good, perfect. Ben, this is touching base also on a city structure, how we're going to build it. We have different silos, we have different equipments, we have different assets. If there is a plan, and I'm going to hand you the blueprints and you're going to draw it for me, what would be the perfect plan? We're integrating all of our systems, all of our equipment. We're unifying all of our data, categorizing everything. We have our own single platform. If I gave you a white paper, what would you draw for me in terms of an entire blueprint of a city?
Well, of course, an ideal digital water system is one that's interacting with every other system in the city to the extent that it can. And to that extent, we really need to pay attention not just to the interoperability of our systems as they exist today, but how they will grow into the future, because the bright, shiny thing we're building today, well, that's the legacy system of tomorrow. And we were talking about regulatory challenges. I think that's one place that regulation can support water utilities, is in instituting standards for how these systems can interoperate and talk to one another. I do believe that success in digital water, it's only 20% about technology, it's 80% about people and governance. And we really need to invest just as heavily in our people as we do in our infrastructure, empower them, put them in a position of governance over the systems that we have, and empower them to recognize what's working well in our systems and to make changes as they need to be made, so that we're building not just a water utility that can solve today's problems, but a system that can evolve and solve the future's problems for future generations.
Good, perfect. So right now we're getting into problems and challenges. So what would you see, Gigi, as the main challenge into, we don't want to call it a problem or a challenge, let's say a small hurdle into our way, say how we're going to overcome this to achieve the title that city that we right now running into our near future?
Yeah, so I think many of the panelists have already said this. Interoperability is really key to all of these systems communicating with one another. So one of the things, I have been working with the SWAN organization on something called the Interoperability Utility Group. For 2.5 years, we started looking at uniclass classification and getting utilities to have the same data structure for their assets and communication, and it was quite impossible, because it takes too much time and it's very difficult. However, I am seeing a little bit of promise, again, going back to generative AI and these large language models. There is a new protocol called MCP, Model Context Protocol, and it's sort of been seen as a USB-C of the data world. So it will start to allow, everyone will have their own APIs, of course, but this will, you put a MCP server on your software, and you would be able to flow the data back and forth between these systems. I think that's going to be important not only internally into a water utility, but as you had mentioned, between a drinking water utility and a wastewater and a stormwater. And then more importantly is how do we communicate with the energy utility? How do we communicate with the agriculture? How do we communicate with transportation? All of these, to get a smart city, we need to have integration. So this is where I think data governance is going to become key, and this is beyond the role of an individual utility, but more like the Saudi Water Authority or the EPA or AFWAT. You know, we have to come up with standards and data governance so that these entities can communicate not all the data, but just the precise data necessary for them to make decisions.
I do agree. It's a major role for other authorities. Someone like us or AFWAT or any other entity has the same body of regulation into a country. Now, to say that, have we reached that title of any other city? Do we have a benchmark? I'm going to leave the floor to each one of you to give us some kind of a use case or a story. It's a free country, so go for it. Give me a story from your side. Either it is a challenge or some kind of a success story that we reached or we heard of a success story of that title of a city. You want to start, Gigi?
Yeah, so I mean, a few years ago I worked in the kingdom with NEOM, and we were working on a design phase digital twin. And of course we worked with Suez at that time, Euro Optomatics, and Innovise, and Esri, and Autodesk to build a BIM, a building information model of the new system. But we also used it by using Optomatics in order to optimize design decisions, like what material should you use for storage, where should you place the asset, you know, if the storage is on a hill, or, you know, how does gravity affect the location of the storage for better energy uses. So I think that was very, very exciting, and it was very successful. Optimized design phase. But then I think the next step that NEOM has taken is to take that BIM information into the construction phase and update all the BIM information. And then after that, take that into operations, which is not being done today. Operations, when something is constructed after commissioning, usually starts from scratch. And we feel like there's a large body of knowledge in those BIM infrastructures. So I feel like this is one case that was very successful.
Good. It's good to hear that the story resides over here within a close range of ours. Ben, maybe we can also have a story, or maybe we can shed light on the same side of you from you're working with Gigi.
Sure. I think a lot of utilities have a real wealth of data from investment over the years in sensing, and it's a great time in history that there are so many artificial intelligence technologies that we can bring along and layer on top of that data and get insights out of that and benefits that are almost free at that point. With the pressure and flow data, we almost free can have leakage detection. And with meteoristic algorithms, we can almost for free have huge savings on our capital investments. And once we know what's happening in our network, a digital water system, I think, is successful once the decisions that we're making as network operators and owners are informed by the data, they're informed by predictive models, and they're informed by digital twin. And then we're making better decisions at every point in the chain and getting great value out of the system. I know DEWA credits their digital twin with 25% reduction in non-revenue water, and NEOM will be leaning heavily on their digital technologies to reach their 3% non-revenue water goal. So I know all of the water utilities in the region have great aspiration for the digital water future.
Great to hear that as well. Stefan, go for it.
Yeah, look, I think it's good to look at good case stories. It's also to look at case stories where we failed, where we've seen digitisation fail. And I've seen, some examples from Europe and around the world where a success story would be that the industry, the water utilities, particularly in Scandinavia, I've seen this, they actually get together and they form a joint industry project where they build a digital framework around how they should all work so that the community of professionals, operators within that country actually can all even move around between the utilities, so the workforce is a bit mobile and they have a common digital vision. And that's something I think in Scandinavia they've been very successful. Agreed, it's smaller utilities, but still quite a successful digitisation journey. And then in other places I've seen in parts of Europe, huge amounts of funding made available. Let's just convert a legacy utility straight to 100% digital overnight, and the step change is just too large. You end up with operators in legacy systems resisting the change, and they're not even interested in taking the money. They don't want to change the systems. And so you've tried to take too big a step. And in that case, you end up with this sort of internal resistance, often from the operators who don't want to actually take on the new technology because it was just too big a step. So in those situations, it's really about building your vision, your strategy for your long-term digital vision, you could say, and then actually taking some small steps, high impact, and get the operators, get the silos across the organisation on board with that digital journey, and then you can actually change the legacy systems much faster. So that would be, some of the where it's failed and where it's succeeded, I think is good to contrast those two.
Good angle.
That's good. That's at the same part that we're afraid we're going to move too fast or too slow, but we don't want to lose the trail of people that we have it. And this is the asset that we're truly going to rely on, even if we have our own digital system. Krishna, if you have our story as well.
Yeah, I must agree with my panelists over here, and there are two examples I want to put on the table. One where things were a success, and one surely it wasn't. Let me start with the success case first, where famous Mexican city, Monterrey city, I think in 2024, they ran into pretty much a zero-day kind of a situation. They ran out of water, drought hit them continuously, and it was a big problem. Monterrey, as for those of us who know, is also the place where there is a huge industrial activity. A lot of American manufacturing happens in that side of the Mexican border. And there was the famous newspaper going on about, Tesla putting up a factory there, right, the perfectly wrong time for you to go have a 0 hour because you require a lot of water. And in a span of, so there the idea was very close to what some of us said, right? They got a mandate to have a vision saying that, hey guys, we've got to fix this in 18 months. Not 24 months, in 18 months we've got to fix it. Not the biggest problem in the world, it's that part of Monterrey, I think was it 50 million or 70 million residents, we've got to address it. So 3 layers, the sensing layer, control layer, automation layer, and on digital. And at each point of that stage, there was clear decision making on what problem we are trying to solve and where we are trying to solve it, right? So the ability to sense the lowest of flows, the ability to implement policies to affect behavioral change in demand consumption, completely focused on demand side management. There was no opportunity for desalination or anything to add sudden supplies of water in the next 18 months for sure. So it was a pure play demand side management story using digital, which in a period of 18 months could bring down the demand by 20% per capita per year, and provided enough room to actually fight the rest of the battle to keep augmenting other sources, etc. So that was one of the places where I have experienced a case of clear vision, goals, problems, and at all the 3 layers, an aligned view to achieve the final objective. The bad cases often is this problem, like it was mentioned, there is funding available often in many economies and many countries. Sometimes there is a good vision and there's money put on the table. And when there's money put on the table, often it goes in the direction of, hey, now I have money, I need to invest, without knowing what the problem I'm going to solve or what it is. And so there is a lot of tenders floated out, and all that kinds of things happen. A lot of investment happened in this particular case, and then as expected, yes, investment done, patient died kind of a situation because you did not change your demand reduction or any clear situation. And then that thing kind of stagnates. I think what we have to be very clear about is the formula of what's the vision, what's the problem, and then directly address the 3 layers of the digital in order to come to a solution. So that's what, these are the examples that come to my mind.
That's a very crucial part. When you have too much money on the table,
Yeah.
then everybody invests in those technology, and that technology fails, so the whole structure falls
Exactly.
falls apart. Hopefully, Joachim will finish us with a very good, positive story.
I think I would like first to touch a point that Stefan mentioned that I think is key to all this. It's people, right? And we need to involve people from the start. And the operators are key for this to happen. So my most enriching professional experience was regarding this. It was a process of digitalization from the ground up, working with the operators so that we were able to provide them the information they required. But in the end, or in the beginning, it was really hard to convince those people that it would be useful for them because it was a process of change. Everything was difficult. They didn't want to use the app. They didn't want to use anything because it would change everything that they were used to do on a daily basis. So after 3 or 4 months going into it and start delivering and starting to see the benefits of having a GIS system, of having hydraulic modeling, providing you answers to what you're managing, knowing before going to the field what you should expect. It was tremendous in the way that you can make these things happen. And I think with everything that's gone by, with all the new technologies that we have, we still need to look at it in this holistic way, involving people and not stopping in the infrastructure, because we have our people, the people that manage the infrastructure, but we also have the users of the water in the end. So everything combined needs to come into a place. Another point that I think it would be important to mention in the end is the flexibility that we need to have when we go into these projects. Even for the regulator, the policies that need to set up, from the beginning we need to be alert that they will change. The future will bring us different challenges, a different way of seeing things, and so it will be stepwise, but we need to be open to this change.
That is very insightful. That's an amazing closing remarks to our panel over here. I would like you just for a round of applause for our panelists over here. Thank you for listening. Thank you for attending. Thank you, guys.
Thank you.
Thank you.
Thank you very much for our esteemed panelists and Engineer Abdullah for such an engaging discussion. It's clear that digital water is a cornerstone of a smart city development and urban resilience. Kindly accept this token of appreciation presented to you by the Saudi Water Authority to thank you for your invaluable contribution and participation for the conference. Thank you very much. Let's give them a big round of applause, everyone. Okay, so before we introduce our next session, ladies and gentlemen, let me remind you about the Water Horizons report, which was published by the Saudi Water Authority in partnership with Oliver Wyman for the goal of advancing the water sector. It takes a comprehensive look at the future of infrastructure, the digital transformation, the circularity, and also how is all this is being shaping the water management worldwide. And you can just scan the QR code to download the report and take a look at it. It's such a rich contribution. Our next session, ladies and gentlemen, is a fireside chat that is going to explore how technologies like AI, automation, and also the IoT are reshaping the human capital of the water sector. Through the lens of the global best practices, we're going to learn how digital transformation is driving progress in this critical industry. Moderating this session is Alex Money, the CEO and founder of Watermark. Joining him is our esteemed speaker, Muhammad Ali, the Senior Vice President and the Head of Consulting at IBM. Please welcome them to the stage.
Okay, well, good afternoon, everybody. It's a real pleasure to be here. My first time in Jeddah, wonderful city. So my name is Alex Money, and it is my privilege to be moderating this conversation with Mohammed. Mohammed Ali is the Senior Vice President, as you've heard, of IBM Consulting. And we're going to talk a little bit about his perspectives on digital transformation in the water sector. So Mohammed, it's great that we had an opportunity to speak a little bit beforehand about this session. Let's start with some detail and maybe just zoom out a little bit after that. So one of the things we've been discussing is some of the sort of pervasive challenges that are in the water sector. And we sort of identified three in particular. One is to do with asset efficiency and all these challenges that we've been speaking about in connection to non-revenue water and leakage and all of that.
Right.
The second is really around valuing water and recognizing the difference in that value between different types of users. And the third, of course, is just the financial sustainability of the sector and how that can be improved and made more sustainable. So I wondered whether just maybe to set this conversation up, you might have some perspectives on one or more of those challenges and really what the role of digital transformation might be within that.
Sure. Well, Alex, thank you for doing this with me. It's a pleasure to be here in Jeddah, and my thanks to His Excellency for inviting us to this panel. As I walked through the exhibit, I was struck by the slogan of the event, that water is not just a resource, it's a responsibility. And that is really kind of a fundamental statement. I go to many conferences, and this is different. It's a real responsibility here. So in some ways, for us to fulfill that responsibility, the three items that Alex just talked about are really critical. And I'm going to talk about two of those things today. The first is actually the last one he talked about, which is how do you make the business of providing water more efficient? The core functions of the various businesses. And for us at IBM, we 3 years ago decided to apply AI aggressively to ourselves. And we were able to remove $3.5 billion worth of cost. That's $3.5 billion as we apply the human plus digital approach to our own business. And almost every other company had the functions that we have. As a result, we should be able to get financial efficiencies on almost any business, including the ones in the water sector. This can then be used to reinvest in resources that are required, whether it's building desalination plants or other resources to fulfill their responsibilities. So that's one topic we'll talk about. The other topic is asset efficiency, which was actually at the top of your list, right? And I think you're all the experts here. You know that, in many cases, 30 to 40% of the water is lost. And, that's the prior speaker talked about an industry where, so much of your core asset is lost. So how do you deal with that? We've at IBM we have been working in the water industry for decades. We've done a lot of projects globally, including Australia, where we've done quite a few. And I'll briefly touch on a couple here. And then I want to talk about a new approach as we deploy AI more broadly. So at Water Corporation in Australia, one of the things that we did was we applied AI to predict pump failures. And it worked extraordinarily well. We were able to predict it with 90% accuracy. At Western Water, also in Australia, we used AI to do visual inspection of pipelines. And we were able to reduce blockage by 67%. And right here in the Kingdom, we actually have a really, really exciting project on corrosion. Actually, this one is in the oil and gas industry. And I believe that this is very applicable also to the water industry. But these are sort of point solutions. And I sort of want to wrap this asset efficiency part of the discussion up by just highlighting something that's happening right here in the Kingdom at Saudi Water Authority, where we are working with the Saudi Water Authority on a new platform called the H2O platform. And the H2O platform isn't just looking at asset efficiency on those individual bases, as I just mentioned, but across the board, right? From production to distribution to consumption to recycling. And once you could look at this across the board and you have a common data set and you can apply AI on top of that, I expect we're going to see a lot more efficiency than the point solutions that we've worked on before.
Well, Mohammed, thank you for that. The more I hear about how the Saudi Water Authority operates, the more it just seems to have the urgency like of a startup. It just seems to be
very much so.
Keen to figure stuff out. It is really interesting. That's super helpful, and thank you for taking a bit of time to get into the granularity of some of these things. If you wouldn't mind, could we maybe just zoom out a little bit? So you obviously head up IBM Consulting, which is part of IBM, the group. I wondered if you might just sort of situate the evolution of IBM Consulting within the organization, and maybe just segue from that into what some of the objectives are that you've set yourselves for the organization. You've described a few specifically in the region, but more broadly, what's the strategy and what's the plan?
Sure. Yeah. I do want to comment on your point about the Saudi Water Authority feeling like a startup. I mean, I've been coming to Saudi Arabia for a number of years now, and I have to say, over the last few years, there's such an amazing energy, and I think His Excellency and the Saudi Water Authority are really at the pinnacle of this urgency, right? And it's wonderful to see. In terms of the question you asked about how we're applying AI to IBM, this is sort of a remarkable story. About 3 years ago, when GenAI was launched, November of 2022, we at IBM looked at this and we said, look, we've been in the AI business for a long time. Somebody else brought this new app to market and this new technology popularized. And so what we need to do is we need to become the best user of this new technology internally. Otherwise, maybe we shouldn't be in the AI business. So we aggressively leaned in. We took our company, we're 270,000 employees, and we decomposed it into 490 workflows. And then we of those 490, almost every company, including the ones in the water sector, probably had 350 of those workflows. And we picked 70 that we considered high value. And we aggressively applied AI and automation to those 70. And what we did in the beginning is we built 220 what we call digital workers today. These are sort of AI agents. Back then, they were assistant class agents. And so about 4 of these AI digital workers per workflow. And these workflows are like procurement, finance, even our tax preparation, HR, customer service, right? And that, our first target was to take out $2 billion. And by the end of 2024, we had taken out $3.5 billion. And that's continuing, right? I mean, we've committed now to get to $4.5 billion. So this is actually quite remarkable. I mean, I've worked on cost takeout projects before. I've never seen something quite like this. And so now we've applied this to our clients. We have about 100 clients where we're applying this human plus digital labor approach, and that's working. So then you say, okay, well, what is IBM? IBM's really two large businesses. One is a product business that sells software and hardware. You're familiar with that. And then the other is a services business that we call IBM Consulting, where we do these projects like we're doing with Saudi Water Authority. We're helping companies like Riyadh Air build a whole airline from scratch, all the software, et cetera. That's my part of the business. It's 150,000 employees. So, you know, what we've done within IBM Consulting is we've recognized that going forward, we're not just going to be a human-based business. We're going to be a human plus digital labor business. And it's not just my business, but every business out there, including yours. So now, IBM Consulting is different. It's 150,000 employees, human employees, plus 3,000 digital workers. And you know, I was showing one of our colleagues here at Saudi Water Authority my dashboard, where I can actually see over 100 projects now being delivered with human plus digital labor. And so what we're doing at IBM and what we're doing in IBM Consulting, I think is applicable to almost every business in this room, every government sector, to be able to run more efficiently and then redeploy those cost savings into the responsibility that we have here, which is to bring water to the world.
Yeah, well, you gave me the chance to look at that dashboard as well, and I was, I mean, the dashboard's pretty cool, but it's when you think about the numbers behind the productivity benefits that have been generated that it kind of brings things into perspective. I'm going to take a chance, Mohammed. I'm going to ask you a question we hadn't rehearsed, and feel free to just give it a hard pass. But it's when you describe through the value chain the sort of productivity unlock opportunities that you, and I guess you're able to sort of help clients quantify the kind of benefit to cost in terms of investments to unlock those things. If you've had enough of an opportunity to look at stuff around water, are you already generating the sort of insights that suggest where, you know, potentially the productivity benefits might be the greatest from different investments in terms of unlocks, or is it difficult to generalize?
No, it's not. So, you know, we've done now over 100 of these projects across all sectors, and it turns out that some of these functions are very common. Procurement. We can now look at a procurement organization, and with the tools and the data that we have from doing other procurement projects, be able to tell you how much you should save in terms of, you know, what you're spending in your procurement organization, et cetera. We could do the same thing for financial planning. We could do the same thing for tax in certain countries, right? Customer service. Customer service is an excellent application. We've done lots of these now. And so I think those are, some of those are very deterministic. There are other projects that we work on that are less so. For example, and you know, this is sort of a fun one, not at all related to the water industry, but L'Oreal, the cosmetics company. So they've asked us to build a model to be able to reduce their R&D by, say, half. And what does that mean? They make 11,000 products per year. And so these products are basically a chemical composition of a bunch of raw materials. You put it into this petri dish, and out at the other end, you get lipstick, right? And lipstick has a set of characteristics. It has color, taste, texture, et cetera. So this is a big math problem of how do you predict, if you put in these ingredients, that you will get these chemical characteristics, chemistry characteristics at the end. Now, this is not a project we've done before, so we don't know what the outcome is going to be. Right? Now, having said that, by the end of the year, we expect to have results. And if we're able to effectively do with AI what you do in a lab today, think about it. The time to produce these products could be 1/2. And if that's the case, L'Oreal will beat every single competitor in order to get products to market. Now, that's not a water example, and we didn't prep this, but it's a fun one. But that's a different kind of project than a procurement project where we've done dozens of these and can predict that.
But you know something, and genuinely we haven't rehearsed this, but there'll be people in the audience who are thinking like what I'm thinking, which is color, taste, quality, chemical inputs. That is a water thing.
It is a water thing.
And there's a whole, this is what, I get very excited about what you're doing, and it's mainly because of the opportunities. Because it's probably, it isn't too much of a leap, is it, to think that the insights you're leveraging across these different industries are effectively cutting the kind of the R&D research time and can be readily deployed potentially into water utilities and just, you know, companies that are trying quite hard to move to financial sustainability could probably, with this digital transformation, kind of unlock the insight that could accelerate their own kind of journey towards financial sustainability. Is that fair, do you think?
I think it's definitely fair. You know, I actually believe that almost every company will, 5 years from now, have to operate between 10 and 20% less cost for the same revenue to be the leader in their field.
Right.
Because if they don't do it, one of their competitors
Right.
will. So, you know, we're working with a large energy company right now, and that energy company has decided that it's going to cut its cost by 10%. This is an energy company that does truck rolls, that you know, send trucks out to fix the utility pole and so forth. If those kinds of companies can do that, what'll happen is that their competitors who don't do that are going to be in trouble, right? So I think across many of these common functions, like procurement, customer service, and so forth, you will see dramatic cost reduction. Now that gives companies an opportunity to invest in R&D, to invest in sales and marketing, to invest in desalination plants, et cetera.
Yeah, so this is all about improving the marginal return on investment. So we've got about 5 minutes left. I'm going to ask you if we can use that time to think about one other thing, which is really what are the catalysts? So you know, you're sort of landscaping the opportunity here, and we've sort of got to get from where we are and to where we need to get to. And in the water sector in particular, the dynamism that we're seeing in the kingdom isn't universally kind of you know, applicable.
Right.
So I'd be really interested in your thoughts about what some of the catalytic drivers are. And I know we've talked very briefly about leadership and workflows and buy-in, but I wondered if you could just amplify a little bit.
Yeah, so I think maybe many of you have seen this MIT study that says 95% of generative AI projects fail. Has anybody seen that? Raise your hand if you have. Okay, look at that, lots of people. So I believe that. And part of the reason I believe that is because I actually hear that from companies that I talk to. There was one CFO of a very large telco, and I was having dinner with him, and he said to me, I've done 1,900 POCs and not a single penny to my bottom line. This is a CFO. He needs to see money to his bottom line, right? And so I think this is true. I also think that IBM, we have been part of the 5% that have succeeded. So you say, well, how do you do that? And the conclusion that I've come to is it's actually not about the AI and the technology, because we were able to get it to work. A lot of people are able to get it to work in pieces. And so what was different about our implementation and some of the people that are successful, I think are three things. One is that there's sponsorship from the very top, from our CEO. And I actually see that sponsorship from His Excellency here at SWA. Sponsorship from the top. Second is willingness to redefine the processes, right? We took our HR processes, we're a 270,000 person company, and we reduced the budget by 40%. 40%, that is a big number, right? And in order to do that, we had to redefine our processes. And that means that people are not going to be happy when you redefine your processes and your workflows. So that's the second thing. And then the third is that as you go through all this complicated process changes, how do you bring people along? And for us, we actually did these hackathons where we had 150,000 employees, including myself, build our own digital workers to help ourselves. And we became invested in it, right? People in the tax department wanted to build these digital workers to help them prepare their tax forms, and they were proud, right? They became like vanguards of change. But those three things have got to work together. And when we engage on projects now, especially these AI transformation projects, we really look for the sponsorship at the top. And you actually see that here at Saudi Water Authority, because we're no longer looking at these piecemeal projects, right? The H2O platform that we've announced is sort of an end-to-end. It's like, how do we apply, how do we get visibility, first of all, across the entire value chain, water value chain, from production to distribution, to consumption, to recycling. How does His Excellency get visibility into all of that? Then how do we put AI models on top of all of that? And then how do we adjust the workflows to get the efficiencies? And that first item, that sponsorship from the top, is where it starts. So I would say those are some of the characteristics.
Mohammed, I mean, I could keep talking to you about this for a much longer, maybe longer than the audience would like. But I'm very conscious we're into our last minute. So I don't know if there's any kind of parting thoughts you'd like to leave the room in terms of how they or we should generally be thinking about what the next 10, 15 years might look like. If that's too far, maybe that's too far to think. But in terms of what this digital transformation might end up, what is the prize here?
Yeah, I think the prize is big. It's like enormous. I can't really think about 10 years anymore. You know, a long time ago, I used to think in 3-year cycles. We used to do 3-year plans. Now, I mean, the digital workers that we built 3 years ago, every 6 months we have to rebuild them because the technology changes. Now we have 3,000 digital workers and we're constantly rebuilding them because, you know, we went from assistants to agents to agentic apps. I mean, the technology just keeps coming. Having said that, I think that, you know, companies and organizations and governments really need to seize on the opportunity. And that's one of the really refreshing things about being here in Saudi Arabia. I think Saudi Arabia has really sort of embraced technology, is deploying technology heavily. You know, the rate and pace, and I don't have to say this to you, I think everybody who lives here in the kingdom have seen this incredible rate and pace that have accelerated. And so I think to the extent that this technology inflection is here, that you can seize on it to leap ahead of your competitors, you know, whether it's inside the country, kingdom, outside the kingdom, this is an opportunity to leap ahead. And so I would just urge everyone to seize upon it. Now, granted, you know, the last panel talked about a bunch of risks. Risks have to be mitigated, and that, you know, that's part of why we're IBM. Like, we try to seize technology, use technology, but also use it responsibly.
Fascinating conversation. Thank you so much. Can you please show your appreciation in the normal way? Thank you. Okay, I think that's our time's up. Thank you all very much for being part of the session. Thank you.
Thank you. That was great.
That was great.
Thank you very much, Alex and Mohammed, for this thought-provoking discussion. The Saudi Water Authority would like to present to you a token of appreciation. Thank you very much. Thank you. Our upcoming session, ladies and gentlemen, focuses on the intersection of water and the digital infrastructure. This fireside chat will highlight how the next generation cooling technologies are helping data centers reduce water dependency while at the same time improving energy performance, particularly in dry regions. And we're delighted to have two distinguished speakers with us today. Together, let's welcome Olivier Berger, the Corporate Account Lead at Nalco Water, and Mohammed Azir, the General Manager of Infrastructure Quality at MCIT. Welcome to the stage.
Good afternoon. Can you hear us well? Can you hear us well? Yes? Thank you. Good afternoon. I am Olivier Berger, representing here Ecolab. We are proud of our long-standing support of helping the Saudi Vision 2030, and our subsidiary Nalco Water has been supporting the industrial growth of Saudi over the last 40 years, helping various industries, whether it be mining or downstream or even hospitality, such as this property, use water in the most efficient and sustainable way. Thank you.
Yeah, my name is Mohammed Azir. I am the General Manager of Infrastructure Quality at MCIT, the Ministry of Communication and Information Technology of Saudi Arabia.
Thank you. Mohammed, my first question to you in this fire chat is to hear from you what next generation cooling technology, be it liquid cooling or hybrid system or closed loop cooling, do you see generate the best results in a arid climate like the one we have in Saudi?
So first of all, I would like to thank the Water Authority for inviting me today. We were working a lot with the Water Authority during the last 1 year or 2 years on how can we have a resilient water solution for AI. I saw that the previous speakers were talking about how can we use an AI in water. Our session today will be taking this from the other angle. How can we use water to go and power AI? So this is in setting the stage. As all of you know that we are having, as a kingdom here, we are having big ambitions to be an AI hub for the region and for the globe. So starting from there, okay, and knowing that our strength is in power, how can we work and be an AI hub, knowing that we are working in a water scarce region? So back to you, Oliver. I would say it from two perspectives here. The first perspective is how can we go and minimize the dependence on the outside temperature of power. And I believe most of the audience, they are aware about how is cooling technology working. It's either that in data center or either on residential or commercial building. So the second point that we'll be talking about as well, which is mainly about talking about how can we minimize the water usage. His Excellency Engineer Abdullah Abdelkarim, yesterday we were talking about more than 60% of the global GDP, it depends on water. And I believe AI and technology is one of those industries that is using cooling, and by cooling that, we inherently talking about water dependence. So back to the first one, which is minimizing the dependence on the outside temperature. So previously, when I started my career, I worked in those data centers. At that time, it was a very small data centers, talking about a 1 mega or even below 1 megawatt. In those days, some of you that used to go and enter those data centers, we were wearing jackets at that time. Today, in those new architecture data centers, you will go and you don't need to go and wear jacket. And where this coming from? Now technology is evolving now. Today we are talking about a technology like direct-to-chip. How can we use water instead of using air cooling inside those data centers? How can we use water so we can go and cool the chips in the servers directly? And this is direct-to-chip is one solution. The other solution we are talking about is immersion cooling. But now the technology is evolving more toward the direct-to-chip. So this is the first point. Talking about the second point there, which is about how can we minimize the water. So there are many water cooling technologies there, or cooling technologies at large. So talking about closed loop instead of having open loop systems. Closed loop systems, it will go and have, maybe some of you are not aware. For example, in Riyadh, we know that Riyadh is hot. We are living in a hot, dry area there in Riyadh. But imagine that 70% of the time that we can go and depend on free cooling. So we don't need either that power, or even that we need water. So we need to go and evolve from a traditional systems of cooling toward a new designs, a new era of cooling. So those new smart systems, they need to go and first prioritize the free cooling. So once they're free cooling, it will go outside the 50 and as going back to the inside data center room temperature. Now we can raise it up to 50. So Riyadh, most of the time, it's below 50. So if we can reach this 50, we can go and depend on free cooling. If it will go above 50, we can go and kick in at that time. We can go and use power. And we can use only water on peak shaping, which is a very rare case. So by that two technologies that we just talked about, direct-to-chip and closed loop, so we can go and minimize the dependency on water.
Thank you, Mohammed. As digital infrastructure is rapidly growing in Saudi, what should operators, in your view, prioritize to build water resilient and sustainable data center for the next decade?
So I would say that, as we mentioned in the first question there, that we need to go and move from traditional cooling to where we can have a resource-efficient architecture. And when I talk about resource-efficient architecture, I'm not talking about water only. We are mainly talking about water, and we are talking about energy as well. So I can summarize this, Oliver, in three main principles there. So the first principle will be talking about how can we have decoupling, as we mentioned in the first, how can we go and decouple that data centers from water availability? This is a very important point. We cannot have an open loop system. We cannot build those data centers, especially the ones that the kingdom is targeting. We are talking about, previously we were talking about, or I would say last 2 years we were talking about a 50 megawatt data center. Today we are talking about a gigawatt data centers. So we cannot have open loop systems that it will go and depend on the water and high WUE, which is the water usage efficiency. This is the first point, or the first principle. Talking about second principle, how can we, I would say, how can we go and balance between the power usage and water usage? So those two, which is the BUE, which is the power usage efficiency, and the water usage efficiency, how can we optimize and make them work together? And maybe one of the speakers just I heard about, and everyone is aware, even that the kingdom today, once will come and want to go and extract oil or even generate electricity there, it's, again, we'll go and use water.
Yes.
So how can we go do this optimization between power and water, okay, and make that, out of those two, the most efficient combination, which is the second principle. So the third principle that I will be talking about, which is we need to go and look at it from a more holistic point of view. How can we look at it from an ecosystem point of view? So talking about, this is starting from choosing the location of data center today. So once operators will come, or data center developers will come and go and choose data center, they need to go and choose the land where there is a power availability, and not only in any kind of water, because we cannot go and depend on the portable water. So we need to go and we need to align, and this is what we are doing today with the water authority, and how can we use the right places of where we can use the TSE water. How can we go and recycle the water on those sites? So if you will go to a place that there is no, you cannot go and recycle the water, that will be a problem for those centers, because they cannot depend on the pure water or on the portable water. And also, how can those data centers go and recycle those waters? So not use it only once and flash it, they need to go and use it multiple times. So this is from a more holistic point of view, rather than thinking about it only from a data center point of view, or one data center.
Thank you, Mohammed.
So back to you, Oliver. I know that Ecolab, as you mentioned, is one of the pioneers on water efficiency. So I would like to go and ask you two questions here. I will start with the first one. How would you see the future of data center cooling evolving, especially in regions facing extreme water shortage like the GCC?
Thank you, Mohammed. So we see that cooling in the GCC entering a completely new phase, with AI racks pushing 80 to 200 kilowatt and designs heading towards 400 kilowatt. The scale is very unprecedented. And a single 400 kilowatt rack uses as much energy as 300 households in this region. And in this region where temperature exceeds 45, 50, sometimes more, we know that air cooling alone is not able to keep up. So operators now need cooling that will deliver for high density, high reliability, and yet use systems that will minimize water usage. All this at the same time. So, as you said, the future is being shaped by direct-to-chip cooling, and alternate water strategies that will enable, in a way, near zero potable water consumptions. And in water-stressed regions like Saudis or UAEs and so on, we know that every liter of water matters. And that's why data centers are now shifting towards using TSE, treated sewage, effluent or gray water or even seawater. And this is enabled by advanced filtration and corrosion control and real-time monitoring. And this will allow data center to operate without drawing from this scarce resource that you mentioned. But the biggest evolution that we see, however, is in the intelligence that we use in those systems. Because with liquid to chips, we are moving from reactive to predictive. We are moving from assumptions to, let's say, AI-driven optimizations. We have real-time coolant monitoring. We have detection tracking. We have, corrosion and fouling controls in those systems. And we even have the predictive analysis, which means that all these parameters will turn managing data center and the cooling into a precise data-driven science, I would say. We've conducted a pilot with digital reality, and this has proven that we were able, with those systems, to reduce water usage by 15%, extend the life of the asset through better predictive measures and maintenance, and we saved 160 million gallons of potable water.
Amazing.
All this without increasing the energy consumption.
Amazing.
So in a way, direct-to-chip cooling and AI allows data center to find the right balance between energy and water. And finally, I would say that integrated models like cooling as a service are emerging as game changer because they are unifying CDUs, monitoring, chemistries, analytical service into one integrated and optimized ecosystem. This again will reduce the water usage, the energy consumptions, and will make the system stronger and more reliable.
Okay, thank you, Oliver. So moving to my second question here, how important is water and cooling quality management in liquid-to-chip cooling performance? And what technical steps should data centers take to improve it?
Yes, so water quality and coolant quality have quietly become some of the biggest hidden risk for the performance of AI-driven data center. We know that liquid cooling can deliver remarkable efficiency, but for this to happen, the chemistry in the loop needs to remain stable. We've seen the consequence of this upfront when one of the global hyperscaler we work with lost 1.2 million in GPU in the space of 6 minutes because their coolant went out of specs. We also did another experiment whereby we evaluate 165 direct-to-chip loops in various regions around the world, and we were shocked to see that almost 80% of this sample had at least one key glycol parameter that was off specs. Could have been a lower pH or incorrect glycol-water ratio, and so on. So these are not small technical issues. They can quickly escalate into big operational risk and translate into lower heat exchange efficiency, higher energy consumptions, corrosion, microbial fouling, and of course the GPU running out of safety limits. So the second part of your question is what could operators do to improve it? So number one, get the right glycol blend from day one. The wrong blend at the commissioning phase will have long-term instability and consequence. So it is very important to analyze the system, the metals, and so on, and get the right blend of glycol and water. in the loop. The second is to move from a manual sampling of the glycol into real-time visibility through dashboards. Real-time monitoring can detect whenever the chemistry goes off and can detect much earlier and before it causes outage or damage to the hardware. And the third part is to ensure that the glycol parameter stay healthy. By that I mean that when the coolant stays within within its range, within its specs, this is the moment when operator can truly benefit and leverage the power of the cooling technologies. And we've seen that at their optimal, using this system will reduce energy use by 18 to 27%, and yet provide a stable AI data center.
Yeah, very, very informative answer, Oliver. So by that, I would like to thank you, Oliver, and thank our audience. Thanks a lot, guys.
Thank you.
Yes, thanks. I believe in this way.
Sorry. Then let me put this.
Thank you very much, Olivier, Mohammed, for a very rich conversation. Kindly accept this token of appreciation from the SWA. Thank you very much. Ladies and gentlemen, as we move to the final theme of day 2, we turn our focus to a critical and transformative topic, which is the circular water economy. From groundbreaking projects in water reuse to the innovative approaches in resource recovery, today's sessions will go and explore and showcase how circularity is shaping the future of water sustainability. Our first session in this theme is a keynote presentation that highlights the world's largest indirect potable reuse facility. We're talking about the Orange County Water District groundwater replenishment system. Since 2008, this facility has produced over 400 billion gallons of water and serves as a global model for water reuse, winning more than 80 national and international awards. We're honored to have Dennis Bilodeau, the president of the Orange County Water District, to share insights into this remarkable project. Please welcome Dennis to the stage.
Well, hello. I am Dennis Bilodeau, the president of the Orange County Water District, and it's an honor to join you here at IDWS and be a part of this important global conversation about water sustainability. Today I'm going to share how Orange County developed the groundwater replenishment system, now the world's largest potable reuse project, and how it's become a global standard for safe, reliable, locally controlled water. In short, how we took what used to be considered a wastewater and turned it into one of the world's most dependable drinking water supplies. In California, water is complex. Nearly 40 million people live in our state. Most of our rainfall is in the north. So the Orange County Water District was formed in 1933, and so we've been managing the basin for more than 90 years. Our basin is an important asset as it supplies up to 85% of the drinking water for 19 cities and retail water districts in the North and Central Orange County, which is a population of over 2.5 million people. We have a professional staff of engineers, scientists, and operators, guided by a 10-member elected board, of which I'm the president. Our job is straightforward but critical. It's to protect water quality, manage the basin sustainably, and make sure the region has a safe, reliable, and locally controlled water supply for generations to come. This illustration shows how our system works to serve our 2.5 million residents. You can see imported water, local rainwater, river water, and advanced purified water from the groundwater replenishment system, all coming together to refill the Orange County groundwater basin. The point is, it's an integrated system. Natural supplies alone are not enough. Recycled water is now a core part of how we maintain this basin full and our communities resilient. The groundwater replenishment system didn't happen overnight. It grew out of decades of experience. We started with a project called Water Factory 21. We started in 2008 when we turned the plant on at 70 million gallons a day. We then expanded it to 100 million gallons a day, and today we operate at 130 million gallons a day. That's enough to meet the needs for about 1 million people. It recycles essentially 100% of the Orange County Sanitation District's reclaimable wastewater, and we've invested more than $900 million in this infrastructure. It's a big number, but it's cheaper and more sustainable than the alternatives. This slide shows our water cycle, which of course includes wastewater, in a very visual way. On one end, you have homes and businesses using water. The wastewater, and which goes to the sanitation district. From there, instead of sending it out to the ocean, we bring it into the groundwater replenishment system. After advanced treatment, that purified water is sent to our recharge basins and injection wells where it becomes part of the groundwater basin again. Then our 19 retail agencies pump it out and deliver it back as drinking water. It's a closed, highly reliable loop that mimics nature, but with more control and reliability. Contaminants. The final step is a combination of ultraviolet light and advanced water oxidation, which destroys any remaining trace organic compounds. When we're done, the water is extremely pure, cleaner than most bottled water, and we've been very open about it with the public. We wanted full transparency because we're talking about serving recycled wastewater or sewage to the public. That openness has been a big part of building public trust. Once the water is purified, we put it into the groundwater basin. This map shows our recharge system along the Santa Ana River. We operate more than 1,000 acres of recharge basins. But it's incredibly powerful. Our basin is connected hydraulically to the Pacific Ocean, and that's both a blessing and a challenge. In the 1950s, as groundwater pumping increased, seawater began creeping inland in degraded wells near the coast. To stop that, we built a series of injection wells where we inject GWS water and some other sources into wells along the coast to form a hydraulic water wall or hydraulic barrier that keeps seawater out. It's a good example of how recycled water protects not only supply, but also water quality. Our seawater barriers and helps us recharge our basin. When you add it all up, it's now less expensive to make our own water locally than to buy imported water or to desalinate the ocean. And that's one that's consistent because we can control it. One of the key messages I want to leave with you is our partnership. The groundwater replenishment system exists because the Orange County Water District, my district, and the Orange County Sanitation District made a long-term commitment to work together. The Orange County Sanitation District provides us with a consistent supply of secondarily going to be essential everywhere. No one can do it alone. Of course, you can build the best technical project in the world, but if the public doesn't trust it, it will not succeed. We knew we had to get in front of the toilet. For us, the real measure of success is not the trophies, it's the fact that our communities trust the water, rely on it every day, and now see potable reuse as a normal, even an essential part of their water future. If you are ever in Southern California, I invite you to come see the groundwater replenishment system for yourself. We offer in-person and virtual tours, and we are always happy to host delegations from around the world. When people tour the facility and meet our staff and taste the water, it becomes and we are still learning and improving. I hope our experience can be a blueprint for any community facing water scarcity or seeking more locally controlled sources. The future of water is reclaiming and recycling every drop we can. And by working together, we can make that transition in a way that is safe, resilient, and publicly trusted. Thank you very much for your time today.
Thank you, Dennis. Kindly be in the center of the stage. Thank you. That was a very rich presentation. The Orange County Groundwater Replenishment System is truly a beacon of innovation and sustainability in water reuse. Mr. Dennis, kindly accept this token of appreciation presented to you by the SWA. as an appreciation for your rich contribution to the conference. Thank you very much. Up next, ladies and gentlemen, we're going to explore the challenges and the opportunities in making circular water adoption mainstream through a very rich panel discussion. The session is a panel that's going to delve into the barriers to circular water adoption and what it will take to make, reuse, recycle, and also resource recovery a global standard. We would like to note that for this panel, we have an Arabic speaker. So for all the non-Arabic speakers in the room, there are some translator headsets available for you. Moderating this session is Niall Reinald, the strategic advisor to the Saudi Water Authority. Please join me in welcoming Niall to the stage. Of course, along with Niall, we have an esteemed panelists, very distinguished panelists. Kindly join us to the stage.
Thank you.
Thank you. Thank you.
Ladies and gentlemen, distinguished guests. I'm very often called Niall. I have worked in Egypt sometimes in my life, but actually my name is Neil. I'd like to start with, I think we all noticed today that it rained very heavily in Jeddah. So this for me is the natural world showing circularity in its purest form. Our challenge today is to match this. I'm delighted to welcome you to the session on circular water economy, addressing the gaps in circular water adaptation. This is a huge topic. It extends across supply chains, manufacturing, resource recovery, reuse, and we heard now from California, recharge. Around the world, we have made great progress in improving efficiency and reducing waste. Yet circularity in water remains patchy. Many of us still operate in linear systems. We extract, we treat, we use, and we dispose. Today's discussion is about closing that gap, or perhaps going further. Because as we look to the future, we might ask, it is not enough to be circular. We must become regenerative. At its core, circularity is about eliminating waste and keeping materials in use, designing out efficiency. Regeneration asks us to go beyond efficiency and begin restoring, healing and replenishing to give more than we take. For example, wetlands, restoring biodiversity, brine valorization, that displaces mining, and water-positive operations. So the conversation is not just about closing loops, it's about opening minds. How can we make reuse, recycling, and recovery truly mainstream, and maybe redefine what progress looks like? We are joined today by 4 highly experienced leaders in the water sector, spanning technology, innovation, industrial and municipal treatment, PPP infrastructure, and large-scale delivery across some of the fastest-growing regions globally. So let me start with you, Sharif Dasuki, CEO of GP Holding, GA Aqua Tech. Sharif is an entrepreneur and investor passionate about the sustainable and clean technologies, particularly nanotechnology for wastewater treatment and waste to energy. GA Aqua Tech pioneers G-Nano, a breakthrough nanotechnology transforming wastewater management into high-value circular opportunity. Welcome, Sharif. Walter Kasia, Vice President, EMEA for BW Water. Walter brings over 25 years of leadership in water, waste, and construction. His company, BW Water, has become a global provider of full-service water and wastewater solutions, integrating advanced membrane systems and energy efficiency desalination technologies across 8 international hubs. We also have Joshua Un, who joins us from Singapore. Joshua leads a company with more than 100 industrial and municipal installations across Southeast Asia. His work focuses on integrating fit-for-purpose technologies with sustainable design, making circular principles practical and economical and viable at local scales. And finally, but not least, we have Moat Shabal, President, Marine Services of Desalination at Bari. Mohat brings over 35 years of international experience delivering water, wastewater, and desalination infrastructure across the Middle East, Asia Pacific, and Africa. He has led major PPP and BOT concessions, providing close to 1 million cubic meters of wastewater treatment across multiple greenfield sites. His background spans utilities, EPC firms, technology providers, and government agencies, with expertise covering desalination, industrial reuse, and the full water cycle in delivery. So let me start probably with a general question, I think, which you may all wish to answer. When we talk about circular water adaptation, what is really holding us back? Is it technology, cost, regulation, business models, or culture, or even something else? Maybe start with you, Sharif.
First, thank you to allowing me to add Arabic flavor to this panel. I will continue by Arabic. الحقيقة احنا عملنا انفست في الوقت والجهد والمال عشان نبدع إجابة للسؤال ده. احنا بنؤمن ان هي التكنولوجي، فلذلك استثمرنا عشان نخلق اجيال جديده من التكنولوجيا عندها قدره على علاج المشاكل اللي في التكنولوجيات القائمه. وبنؤمن ان هي الكوست، فكان لازم تكون التكنولوجيات دي بكوست اقتصادي. وبنؤمن ان هي كالتشر، فكمان كانت لازم تكون التكنولوجيات عندها قدره على تغيير الثقافه وعلى خلق وعي جديد بالحلول. وكمان الريجوليتور ايده مقيده بالتكنولوجيات القائمه، فكان لازم التكنولوجيات دي يكون عندها قدرة إن هي تطلق إيد الريجوليتور والمنظم للقطاع إن يخلق حلول، عنده حرية في خلق الحلول.
Thank you, Sharif. I know that's not easy. It's pretty.
I can translate if you want.
Pretty hard to pretty hard to follow on, even to remember the question. But I think
I remember the question.
What's the biggest mismatches? Maybe
in my opinion, is the financial one and the motivation somehow. Because when you want to move a step forward, first of all, you need to have a motivation. And today, I think that due to the difficulties in closing the loop from a financial point of view, there is a bit of lack of motivation. So probably regulation, as you were explaining, should step in and try to set some targets for water use in order to improve motivation and so push companies to move in this
just
direction.
to lead on from there, though, do we need some new incentives?
Incentives, or maybe a mechanism like the one that we have for the carbon, so sort of carbon credits, water credits, if for the companies which are doing well, some penalties for companies that they cannot or that they are not there in the water use, in order to move a first step. Then I think that on a longer term, probably the system, the market can find a way to finance by itself, but at this stage probably there is a bit of help which is required.
Thank you. Joshua.
Yeah, thank you. So I mean, I meet factory owners all the time. My customers are the factory owners, industrial estate owners. And a lot of them, they come with nice aspirations, right? They want to recycle. They don't want to waste any of the water. If you treat the water to an extent that can recycle back. So we will do calculations for them and design for them. But ultimately, when it comes to economics, the price of water in Southeast Asia currently is still relatively cheap. And so when they look at the dollar and cents, sometimes this is a huge barrier, right? So maybe the conversation or the way we think is how do we make this economically more viable, not just morally sound, or motivated morally only. It has to be some levers to make, so incentives or different pricing systems, things like that.
So not just financial, of course.
Yep.
Mohit.
If you allow me, Neil, I'd like to go a step back. It's important that all of us first are on the same wavelength or have the same definition of our move from linearity to circularity. There is no one-stop solution to circularity. It's a combination of multiple initiatives, right from when there is a demand for the resource, right at that stage, looking at, firstly clearly establishing the demand. What is the realistic need? Is it, are we overestimating or underestimating the consumption? So some fact-based, evidence-based prediction, projection right at the start of any water scheme. Then moving on to the implementation phase. So can we implement cleaner? Can we implement and then start to produce in a cleaner manner? And once we do that, then are we judiciously consuming? Or because we have plenty, we are lax or relaxed. So that's where conservation, avoiding waste, and also minimizing waste. Because we all recognize that if we have to make every drop count, and we know every drop has a substantial footprint, then the entire life cycle of this drop has to be deliberated, we need to deep dive into it. And finally comes what we cannot avoid producing in the form of waste, then we recycle it, reuse it before that, and what we can't reuse, then we recycle, and then finally put to bed the residuals. So it's not circularity is a circle, and we can't just choose to be conveniently plugged into one part of the circle. The stewardship of circularity needs to belong to each and every one. Everyone has to champion that ownership or the belonging of the resource, in my humble opinion.
No, I think the point you've made there also is that we are talking about circularity, but yet it's an ecosystem of many facets, I think, and a highly complex issue to deal with. If I may move a bit deeper now onto some topics, and I'll start with you again, Sharif, if you don't mind. G-Nano has made the news a lot recently, considered maybe a frontier technology. How are you changing the economics of reuse and resource recovery? And yesterday we had a good chat also, and you took us around your booth, and I was most interested, to be honest, in Sludge Plus, where you could see products coming out the other end that are reusable. So please tell us a bit more.
خلينا ابدا الاول. احنا لما كنا بنتكلم مع الناس عن الفيجن بتاعتنا وازاي احنا عايزين نعمل اجيال جديده من التكنولوجي وازاي عندها القدره اللي تبدو خارقه دي، فكنا بنشوف الشك في عيون الناس. جينانو واحده من التكنولوجيات اللي طلعت من عندنا بتاكد اللي احنا كنا بنوعد بيه. احنا كنا بنوعد بجيل جديد من التكنولوجي عنده صفتين. الصفه الاولى انه عنده قدره على علاج المشاكل اللي في التكنولوجيات الموجودة في السوق، وعنده قدرة على علاج التكنولوجيات اللي موجودة في السوق ما بتقدرش تعالجها. النهارده جي نانو تكنولوجي في الجيل الجديد من تكنولوجيا إعادة استخدام مية الصرف ودمجها في الاقتصاد الدائري عالجت واحدة من أكبر التحديات اللي حصلت في موسم الحج، اللي هي السلوتر هاوس الناتج من الأضاحي، وحققت أسرع دخول لتكنولوجيا في قطاع المية في السوق. بعد 6 شهور بس من دخول السوق احنا فزنا بأفضل مشروع صناعي في العالم من GWI في لندن على مشروع مكة المكرمة. بعد 6 شهور تانيين سبسيدري بإيكو سيستم ببزنس موديل جديد بيكمل الإيكو سيستم بتاع جي نانو، راحت يونيكورن، أول يونيكورن في المينا ريجون في تاريخ صناعة المية، وتاني يونيكورن في العالم. إزاي هي بتحل المشاكل اللي بيقابلها السيكتور؟ احنا عندنا تحديات في قطاع الويست ووتر ان مبني على التكنولوجيا على البيولوجي سيستم في ال100 سنة اللي فاتت، هو سيستم عظيم لكن كل المشاكل جاية منه. البكتيريا كائن حي بتأثر بالحرارة، بتأثر بتغير الانلت، بتأثر بحاجات كتيرة قوي بتخلي المحطة تخرج من الخدمة. الجيل الجديد اللي احنا عملناه ان احنا خلقنا جيل جديد من الحلول، مش بس تكنولوجيا بتشتغل بلاج اند بلاي، فيزيكال وكيميكال بروسيس. نجحنا في ان ندخل النانو تكنولوجي بقدراتها الخارقة لقطاع الويست ووتر بطريقة اقتصادية، فبقينا بنخفض في المساحة 95%، بنخفض في الطاقة 80%، بقينا عندنا قدرة ان احنا نشتغل بجارانتي كواليتي 24 على 365 يوم، بقينا عندنا قدرة ان احنا نضمن ان ما يكونش فيه اوردر، فنبقى راكبين في سمحان هوتيل اسفل في الدرعية جيت اسفل الريسبشن، والهوتيل بيعيد استخدام الجري والبلاك والكيتشن واللاندري على وان ستريم. اخر حاجة سلادج بلس كملت معانا الدايرة، ده انوفيشن فاز امبارح في الشركات اللي كرمت امس، اللي فازت دي اعاده استخدام السلادج وتحويله الماتيريال جوه السايد اللي بينتج السلادج. فالنهارده بقى عندنا قدره ان نوعد باعاده استخدام 100% سواء الووتر او السوليد كونتنت اللي جوه الووتر.
Thank you. You talked a lot about technology then. Would you consider that sludge plus to be part of your business model?
Yes. الآن احنا واحدة من التحديات اللي بتقابل دخول أي تكنولوجيا في السوق هي إن صاحب المشروع بيخاف ياخد الريسك في الانفست، فاحنا كريتنا نيو بزنس موديل ان نخلي فيه ان نشتغل بالسيرفيس، نقدم سيرفيس إعادة استخدام المية وفي نفس الوقت إعادة استخدام السلادج اللي طالع، فبقى في عندنا ديفرنت ستريم للإنكم اللي بيجي، بقى عندنا المية اللي بننتجها قبل إعادة الاستخدام والبيع، وكمان السلادج اللي بيخرج من المحطة عنده إمكانية لتحقيق دخل، فأصبح الإيكو سيستم هو اللي بياخدنا للتطبيق، مش إحنا اللي بندفع بإنسنتيف أو غيره للتنفيذ.
Thank you. Thank you. If I may move on to you, Walter, now, in terms of piloting projects, let's say for circularity, how do we actually move them into mainstream?
Yeah, what I see with our clients is that in order to move for a full-scale plant, you need to have, in my opinion, motivation from the owner of the factory, of the plant. You need to have technical means and financial means, and you need then to have a project which is financially viable. Today, the motivation, at least for industrial clients, is there in terms of environmental and social goals that most of the big enterprise they need to achieve, but probably is not so much. We need maybe a bit of extra push, and as I was saying earlier, perhaps the direction of some additional regulation could help in this way. Then, from a technical point of view, today I think that the technologies are there. We are able to address most of the concern, of the technical concerns of our clients. Before we talk about maybe moving a step ahead in terms of regeneration, reuse also of the sludge. This is probably something new, and probably there is still something to be done from a technical point of view, but for sure for the reuse of the water, the technologies are mature. And from a financial point of view, again, there could be some needs of help in terms of access of financing means with special rates could help again a lot of small companies to take this route. And this will end up in having something from a financial point of view viable and so more interesting for our clients.
Yeah, and if I think about Saudi Arabia at the moment, I think a lot of the sludge goes to landfill.
Yeah.
Yeah. This to me is probably one of the biggest opportunities we have here, particularly in recycling of sludge. I guess it's early days, but I think that's an area of focus for the kingdom going forward in future.
Yeah, I fully agree with you, and I think that this is something on which we need really to work. This is, before I mentioned about what should be done by the others, and this is something that we should do, because we should work a lot, because in this way we are really wasting, not only, we're really wasting an opportunity, because it's also an opportunity of additional revenues. Today is an additional cost. We can change it, making it additional revenues. And therefore, again, we go back to having to close somehow, not only the loop of the water, but we close also really the complete loop of our treatment.
And in our opening remarks, we also talked about regulation. So important there is that we need technology pull as well, and we need the right regulations to actually create the solution for the sludge.
Yeah. Yeah, for sure, because today, of course, we need to work a bit on our side. We need also to have sometimes, especially if I look at Europe, we have many regulations that also limit the reuse of the sludge, because there is always a lot of doubts about the quality of the sludge, presence maybe of potential hazardous components in it, and therefore there is also an help from the regulator to understand that the new technologies can produce safe sludge, which can be used in agriculture, or can be maybe used, as we have seen yesterday with your technology, in some other materials. But again, also these materials, probably if you want to use them, I guess in Europe, you need to have some certifications to prove that they are safe, that they can be really used.
So Joshua, if I may move to you, and I had a good conversation yesterday also with a colleague about Singapore, about you needed a real problem to come up with good solutions. And Singapore very often is considered to be one of the great case histories that we can all refer to, particularly with how you've reused water, commingled water, created new water. Tell us a bit more about that Singapore story, because there's maybe people in the audience that haven't heard about that before.
Okay. Maybe just a little bit of sharing about how Singapore is, because Singapore is still, at this moment, one of the most water-scarce country in the world, probably ranked bottom 5. But we need to strategize, and there's no one way to solve this problem. All right, so we call this the national taps, and in Singapore we have 4 national taps. The first, we try to create reservoir to collect as much rainwater as possible, but that's not enough. Right? So number 2, we buy water, right? Import water from our neighbors, Malaysia. Then number 3, we desalinate, right? I think this is the same strategy as many countries around this region, right? Desal of water for drinking water. But number 4, this is how we reuse, all right? And in Singapore, we don't call this wastewater, all right? We have a habit to call it used water, because the water was used and can be reused. It's not waste. Yeah, so we change the entire way we think about it by simple terminology. This used water is being treated to different levels, right? And I think one of the easiest way for us to overcome the different challenges, like we talk about economics, we talk about incentives, but a lot of times it is because we aspire to clean it 100% to the cleanest everything. But in Singapore, sometimes we only clean limited. Some of them we discharge out, we clean it to a discharge level. Some of them we clean it to a pure industrial level. Some of it we mix it back into the reservoir. Yeah, so with this strategy, hopefully, we can promote some sort of circularity within our national tap strategy. Yeah.
Thank you. Mohit, earlier again, we also spoke about finance and the incentives. From your experience, and I think you have great experience in private sector partnerships, PPPs, BOTs. Is there a procurement model or financing barriers preventing circularity? Do you see that anywhere across your career?
Sure. Yes, definitely. The tendency has been by procurers to procure piecemeal in a fragmented manner, and also driven by cost or the least cost, which doesn't really acknowledge merits of any circularity initiatives. So in my humble opinion, procurement needs to be again circular, so that water, wastewater, and energy has a strong nexus with water. All of these need to be procured together. And not necessarily cost-driven, but more a life cycle assessment, circularity-driven pricing. The second challenge is financiers. They will finance the least cost, submission or model, and consider that as a bankable project. Again, giving no acknowledgement or no credit for circularity initiatives. So we are starting to see more and more green financing, which is acknowledging this. And I think for our sector, green financing really needs a big injection going forth. Yeah, so that's my...
Just أنا حابب أضيف حاجة يمكن تكون مفاجأة لحضراتكم يعني. هقولها تاني. I want to share something maybe هتبقى مفاجأة ليكم. هنا أنا جاي من ألمانيا والكالتشر في ألمانيا أصبح فيه بيروقراطية، أو في أوروبا بوجه عام بقى فيه بيروقراطية لتقبل أي شيء جديد. هنا المفاجأة اللي موجودة هنا إن الريجوليتور أو صانع القرار هنا بقى مدرك إن الحلول اللي ما نجحتش خلال ال100 سنة اللي فاتت إن هي تغير طبيعة القطاع، لا يمكن نتوقع منها نتائج أفضل في الفترة الجاية. Okay.
Translate.
You should accept my English, okay?
Good, thank you.
No. What we faced last 100 years because of the limitation in technology, we can't expect better what we achieve until now. The reuse percent in water sector, it is just 11% global. The landfill, the area is huge everywhere. Even in Saudi Arabia, here, the mindset is changed totally in leaders in this country. They accept to support and to go with new innovation can solve those problems, because they believe there is no way to continue by the old ways last time.
Agree.
It's clear?
Yeah, very
so
clear.
Here, if you have something new and you have really value, not just talk, if you never apply anywhere, you can apply immediately. But you should approve, and you should approve your value. You should have this value in your hand. This is a new thing in Saudi Arabia. And I think they will change the water sector globally from this vision. They use innovation to drive the sector.
On that point then, let me be a bit more provocative then. Should we be focused on closing the gap? That's the circularity gap. Or should we raise the ambition entirely? Okay? This can be answered by any of you, but can we return more water than we use? Can we restore the natural ecosystems? Has circularity reached its sell-by date? Is it the wrong term to use today? Should we be purely talking about regeneration, making net positive and ecological contributions? I know, Mohit, you touched on that. I don't know if you want to continue on that point.
Sure.
But please do.
To me, net positive is an aspiration. Regeneration is an aspiration. To me, empty coffers don't make donations. So in my opinion, we are far from being circular first. Yeah. To me, circular is neutral. before we can start to regenerate or give or be positive, we need to raise our standard to come to a place where we've closed the circularity
So
gap.
it's a bit like baby steps, like recycle, circular, regeneration.
True.
Where do you think we are today?
We're sort of, I would say, still a considerable distance away from circularity. I think everyone will agree. Don't you think so?
Yeah.
There is aspiration, there is a lot of good words, good intentions, but there's a saying, the road to hell is paved with good intentions. So, there's a big disconnect between intentions and action. And each one, whether it's regulators or utilities or each one of us is a joint custodian, a steward of this resource, and we are all equally responsible for the state it is in. And the solution also has to come in a combined fashion. It cannot be piecemeal again.
Yeah. Joshua.
So I agree. We are probably not there yet, and I think circularity is a very good first step, right? But I just want to draw an example from where I come from, right, from Singapore. It's not that we have fully adopted regeneration, but it is in baby steps. So I share about our new water earlier on. We treat the used water such that we label it new water, and this is for us to drink, right? And the new water is also used for industrial cleaning and all these things. But nowadays, for our first national tap that I mentioned earlier, there are dry spells during the year where the reservoir is getting less and less water. We top up, right, using the new water, top it up to the reservoir, continue to, regenerate the reservoirs. There are two effects I personally see. Number one, the reservoir is maintained. Number two, the low minerals new water that was, went through RO and all, and now topping up to the reservoir, and then later on when we want to use it, we treat it again to become potable water. It induces back the minerals and into, like what yesterday we were drinking water, right? The very first thing Neil was looking at is this, is there minerals in it? Yeah, so this reintroducing minerals in it, I think it helps, right, to regenerate.
One thing that's interested me particularly is following the Stockholm Institute, actually, and they talk about planetary boundaries and exceeding planetary boundaries, where we probably put far too many nutrients already into the world today, particularly around phosphorus. Isn't that an opportunity for us, though, because we have the technologies now to clean up our rivers, let's say, where, let's say, the phosphorus exists. And that, for me, could be regeneration.
Yeah.
So I do believe very often, and just challenging you a bit as well, Mohit, I do believe we have a lot of the technology today, but we're not applying the technology correctly.
Yeah, for me, I tend to agree with you. And I think that it's true that we are not at the level of being circular even only for the water, but probably trying to look at the problem under different angles could help to solve globally. So I see it more for a global solution rather than a step-by-step. So I'm not really completely in line with Mohit on this. I think that if we wait to solve the problem of the reuse and then we look at the regeneration, it probably will never be there.
But we have to have the aspiration.
Yeah, maybe the aspiration are sure very high, probably, but we need to look globally. So it means that looking at the way to regenerate the water, the way to be more efficient in the way in which we treat the water from an energy point of view, from water consumption, and everything will help to solve globally the problem.
I guess my point was, yes, it's aspirational, we have to think global, but we still have to act local, which is nothing more local than my own backyard. So what is the sphere of my individual influence, whether it's in decision making or even in my own lifestyle? Consuming water, what's my relationship?
The washing powder you use at home.
What's my relationship with the resource?
Yeah.
So am I just a user or am I an owner?
Yeah.
So this is what I meant by, yes, of course we have to think future, think global, but each one needs to take responsibility at a local level.
Yeah, you're right, but there is also a lot of cultural somehow change of our mind. For me, that I lived in Europe and in Singapore I need to acknowledge that there is a different approach with water. It's considered really a resource, and it's something that you feel even in your normal life. And I mean, it's something which is important. It's the starting point, really.
It's a great example of circularity already achieved and going towards regeneration. But it's one example.
Yeah. Sharif, you respond to that.
And I will go back a little because we start everything from our purpose. Our purpose to protect people and environmental. And I like the regeneration, everything. So we every time we select to change the game, to create something new, can solve the problem and can create value. So if in the end of the day we believe that as a deen, yani, we target in the end of the game Jannah. So we should approve each step according to this quality. So I select every time to change the game. The sector is totally like empty. If anyone have something can disrupt and can create new generation technology, he can very fast. It's like blue ocean market. That's we should think by. So I am not with step by step. I am not. I direct go with how can I
leapfrog.
And we success. Yeah, we did that. We create new business model. In 6 months we came unicorn. So if you think by mind, money mind, we are the winner. If you think as a technology, we are the winner. If you work by this mentality.
Okay, we're coming close to our time, so I think we'll have a wrap-up question, and just to take your viewpoints, that if you could make one change to accelerate, let's say, and I'll have to rephrase this now because I'm not too sure if we're talking about recycling, circularity, or regeneration, but if you were going to accelerate any one of those three, what would it be? And who needs to do what?
Me? Okay. I'll start, yeah. I think ownership down to the grassroots, where each and every person coming in contact with the resource, wherever in the cycle, feels they are a steward or a custodian of the asset.
So are we talking about education? We're talking about a community level.
Education, awareness, but also having a seat at the decision-making table. You know, the decision-making cannot be isolated. It needs to be devolved down to the grassroots.
And we probably do need aspirational champions too. But
of course.
Joshua.
So I think the keyword is really baby steps, and I work with so many SMBs, factories and all. Aspirational is good. Let's do baby steps first. Let's clean partial of the wastewater and recycle it for partial use, partial reuse. Tiered quality, I would say, for tiered use, right? There's no need to clean the entire wastewater 100% to the cleanest for everything. So I think once companies start coming on board with baby steps and tiered cleaning, then they realize the benefits of it, and then they say, all right, for the next 5 years, 10 years, let's do a bit more, a bit more, a bit more. But let's start somewhere.
Walter?
Yeah, I tend to agree with Joshua. I think that we need to set some steps in front of us, some clear targets, and have a clear commitment to reach a certain level of reuse in a certain number of years in order to have to be all focused towards a common goal. Otherwise, we will have some different kind of aspirations and for sure not a global approach which is required for something which is at the end a global problem. Because today I don't think that we can say there is a region which is better condition than others. We are all very interconnected on this problem.
Sharif, the final words are with you.
I fighting, not I, if I fighting to do that, to work by centralize and decentralize. Centralize as a regulator, as a sector together, food and water and industrial and energy, they must work
Connect,
together.
Yeah.
In same time, I will go with the decentralize as a solution, as a project. If we think as a one mind and start do action as a decentralized who produce problem he must solve inside his place, so we will, what we create from energy sector will not affect to water sector. What we create in water sector not affect in energy sector. That's what I...
Thank you. I think from my side, I mean, it's been a pleasure, obviously, to talk to the four of you today, but for me, it's just trying to summarize what you all said. It's it's not just about closing loops.
Yeah.
It's about also opening up the possibility. And I think, so we need the aspiration. At the same time, we need to be grounded, let's say, in what we're achieving today. So thank you very much. It's been a pleasure.
Thank you.
And thank you.
Thank you for this opportunity.
Thank you to our esteemed panelists and to Neil for this amazing moderating for this rich session. Kindly accept this token of appreciation presented to you by the Saudi Water Authority to thank you for your rich participation. Thank you very much. And now, ladies and gentlemen, let's move on to a fascinating case study on utilizing desalination brine for CO2 removal. This session explores an innovative approach to addressing two critical environmental challenges. The first one is fresh water scarcity, and also the climate change is the second one. And this case study will highlight how desalination brine can be leveraged as a resource for the carbon dioxide CO2 removal. Please join me in welcoming our speaker, Ben Tarbell, the co-founder and the CEO of EBB Carbon, to share his insights. Welcome, Ben, to the stage.
Excellent, thank you. Well, I'd like to first start by thanking the Saudi Water Authority for their hospitality, for gathering us all here. I'm going to share a little bit about EB Carbon, how we do what we do, and then talk a little bit about the work we're doing in Saudi Arabia. So EB addresses two critical challenges, world problems. One focused on climate change, and the other on freshwater scarcity. And these are two very intriguing problems. In the GCC region alone, we're seeing dramatic growth in water consumption due to economic growth and population growth. And if we're going to hit the goals of the Paris Agreement, we need to remove 10 billion tons of CO2 from the atmosphere every year. This is a challenge, but EB can turn this from a cost into an economic opportunity. And so we help our partners profit by by solving these problems. I'm from California, and there's a lot of buzz in California around some of the recent Saudi investments in artificial intelligence. And AI requires infrastructure that uses energy and uses water for cooling, and this creates climate emissions and water use. And so it's no surprise that some of our biggest customers are companies like Microsoft and Google that are some of the biggest hyperscalers in the AI space. Desalination is essential to economic growth and water security in the region. And we can create additional commodities that can be created as exports, and we can create dramatic impact on climate change and environmental benefits. And all of this at a tremendous scale. Just existing desalination plants alone can deliver 1 billion tons of carbon removal per year. And we can create tens of billions of dollars of additional economic value. Desalination plants are already moving massive amounts of salt water, and so we don't have to build a lot of new infrastructure. Streams into multiple values. The low salinity waste stream, we recycle that back to the desal plant, and we can help reduce the energy intensity and produce more water with that desal plant. The acid and base, we can sell it as valuable commodities into the chemical markets. And then if we return some of the base to the ocean, we accelerate a natural process in the ocean that converts CO2 to another more stable, safe form of carbon in the ocean that ultimately we can quantify and remove CO2 from the air. We sell that to companies like Microsoft. All of this delivers additional environmental benefits. So we're removing CO2 from the air. We're also amending the ocean in a way that reduces ocean acidification. The carbon removal market is tens of billions of dollars today and growing quickly. And these industrial co-products are well-established markets that also continue to grow. When we deliver the low salinity waste stream to the front of the desal plant, this has significant change. Add those two benefits up, we can dramatically improve the free cash flow of that desal plant. And so this is either more profit for our partners or maybe more importantly, lower cost of water. If you add the other revenue streams, the chemical co-product, in our space. Customers like Microsoft and Stripe and Google scientific partners like the Department of Energy and NOAA in the US, and then third-party verifiers like Isometric. And so all of this is demonstrating safety and efficacy. We've been around for more than 5 years, almost 5 years, and companies like Tesla, SolarCity, SunPower. We're a team that's built companies. And so let me focus a bit more on what we're doing in Saudi Arabia. So the work we do advances many of the strategic objectives of the region. Saudi Arabia has some very specific advantages, some opportunities here to excel advancing and scaling EBS technology. Saudi Arabia has the largest and fastest growing fleet of desalination plants. And so there's strategic mutual interest there in terms of our feedstock and our ability to improve that industry. There's also industries that consume the chemical co-products, the acids and the bases, like the aluminum industry. And then here we also have access to some of the cheapest clean solar power in the world. And so all of that aligns quite heavily to a pathway to scale and success. And then strategically, we align quite well with the Vision 2030 and other broader climate initiatives that have been advanced in Saudi Arabia. And so, all of this contributes to the potential for economic growth. We can enable Saudi Arabia to deliver carbon reduction as well as create new growth and export economies. While doing it, we can establish help grow and advance the economy. And so the Saudi Water Authority has taken this into action. We are But Saudi Water Authority alone has the potential for up to 85 megatons of carbon dioxide removal with their fleet alone. So massive scale, and we're excited to be taking action with them. And so, next year we're going to be building a pilot plant at the Jubail site, and then as we advance the strategic initiatives within the kingdom. And all of this is advancing these climate goals and other goals around water security while creating potential for economic development. So we're excited to be here and appreciate your interest. Thank you. Thank you.
Finish?
Podium mic, yes.
Thank you. Thank you.
So, ladies and gentlemen, let's hear it for Ben. Thank you very much for this very enlightening keynote. Our final session of the day, ladies and gentlemen, is coming next. It focuses on how circular design thinking is enabling the reuse of waste water and also creating the ecosystem for resource recovery at scale. This presentation will also explore how public and private sectors are actually driving these efforts together. We're delighted to have with us Glenn Diger, the professor at the University of Michigan, to share his expertise. So please join me in welcoming Glenn to the stage. Thank you. Welcome.
Can I give him a head? Hear me now?
Yes, we can.
Works better if it's turned on. Whoops. Yep, yep.
Let's have a big round of applause, please. To Glenn. Welcome.
So maybe you heard, even without the microphone, my wow. So what a day. What a wonderful presentation of information and so forth. A very enlightening day for all of us, I know. And as I was listening through, I think that there are three themes that maybe flow through everything that we've had today. First one is systems, that what we work with is a system, and certainly if you look at the circular economy, it is a system. The second theme was people. In many ways, both us as water professionals, but also the people we work with. A third, which I don't know was emphasized as much, but I'd like to bring into this discussion, is journey. Because we're on a journey, not to a fixed destination, but we have a direction and so forth. So I hope as I go forward and kind of modify a little bit what I say, that those three themes will come through this presentation. So fundamental changes to water management are needed to avoid stress. We all know that. They're needed in two areas. The first area, and I'll come to that in a minute, is in terms of water stress. One water stress is when you don't have enough water. The drought side. I'll come to the other, which is happening outside, which is when you have too much water. But stress and a system that's able to deal with stress deals with droughts and floods. I will tell you we have the answers for these things. This is really good news that we know how to address these. For the drought situation, it's what some refer to as the portfolio. It's how do we put together the combination of water sources that we have, the right combination for a given situation. And you read a lot faster than I talk. You see the combination here, and what has come to the fore in the last decades, most particularly, is both reclamation and reuse and desalination. These are becoming essential components of the portfolio in many locations. The second then is, what do we do when it rains too much, the flooding? Here the answer is the same conceptually, but with different components. The answer is the portfolio of components. Now, in the distant past, we actually thought about using natural features more. As we've moved, especially into urban areas, we tend to think about, and even in more natural areas, we think about the engineered systems, pipes and levees and dikes and so forth. But we're bringing back the natural systems. This is one. Planet. But it takes changing how we think and changing how we act and using the tools that are available to us. So that's actually the people side of this. It's us, but us working with others that don't understand that these possibilities are here. That there's no reason to accept poor water management and the circumstances for it any place on this planet. It's really working with people is what gets us there. We've had quite a bit of discussion about reuse, and this is a change in mind. We can figure out how to do it, right? Not only the technical side, but the financing side. And certainly the incorporation of natural systems, even in urban areas, is progressing quite well. All this is happening, just not enough yet. Scaling it up, which is a little bit about the journey, right? The second thing, so now circularity, water is absolutely part of that, but other resources. In fact, Neil mentioned the Stockholm Resilience Center. Water management is becoming more resource efficient. These wedges coming out are where we're trying to use 2 or 3 planet Earths. Every one of these relates to water. Every one of them. Including things like biodiversity and land system change, just because we're taking too much water out of the environment. We take too much water out of the environment. We need to take less, which means we need to use it more efficiently and use it multiple times. It's that simple. Now, there's another aspect of this also. The diagram that's coming up here, this is showing the relative costs of of quite a number of just basic materials. So natural gas, materials, agricultural raw materials. The line that's here is that if you go back to back in history from this vertical line, the cost of these things was constant for 100 years because we had plenty, we had excess. What going forward reflects scarcity. Scarcity creates this type of chaos. We've all seen it, we experience it. Not just decades, but a century or more. There are more that are being investigated, and we saw the presentation just before me in terms of extracting valuable materials out of brines. This is an area of very active investigation, and it's not just investigation, people are starting to do this. We really need to pay attention to the results that folks are getting and prepare ourselves to implement these as we go forward. And here's a way some folks are looking at this as a pyramid and moving up in terms of value and up in terms of contribution, but also less volume. BOD is chemical energy, right? And nutrients. This is the distribution. So the nutrients are in the urine. We really need to move to not only separating gray water, but also separating urine. This would dramatically change wastewater treatment and our ability to recover other resources. In the fecal matter, the toilet waste, and kitchen waste, there's a lot of energy here. And what you end up with then is the gray water, which is not very contaminated. This is something that we also need to be pursuing much more aggressively. And this comes down to people again, because we have the technology to do all this. It's getting people comfortable with this. They will and they do because it's happened. We're part of the problem. We say, oh, people will never accept this, even though there are places where they do. People, and sometimes it's us. It's our preconceptions in terms of what's possible. A recovered material is a resource only when used. This is also, Neil asked what, in terms of constraints. One is putting everything on the table in an unbiased fashion. Take away biases in terms of what specific components of the system are. Just put everything on the table. And then systems. Put it together in well-functioning systems. Some of the components will be very large scale. They'll be centralized. Others will be decentralized. Just take the right pieces for a given situation, put them together in a good system, and you have the answer. This is a little cartoon just to show all these things coming together. In many cases, you don't need all these. You ought to have a vision, though, of how you can get to this complete system. We're on a journey. In water, we're never done. We're on a journey. You need to know where you're going to get to a reasonable place in the journey. What do these systems do? They improve public health protection. Reuse, people say, we actually improve public health protection. Less water out of the environment, significantly reduce environmental discharges, reduce consumption of resources, and actually, as you have distributed components, this is a system which is easier to upgrade and expand as you go forward. Again, this is not an either or of centralized or distributed. It's the combination of those. That's the direction of our journey here, an increased system resilience and a better urban environment. So let me give you a vision. This is my vision today in terms of our direction. Not a specific destination, but our direction. So it's integrated rainwater, stormwater management. I've talked about this already. The important point here is integrating with spatial planning. People. We as water professionals need to interact with those that make these decisions about spatial planning. We need to be an integral part of that. Portfolio approach to water supply. I believe that in time, reuse will be the norm in terms of managing used water, if I can use the Singaporean term here, which I like. Resource efficiency. So I grew up on a farm, and we used to say a weed is just a plant out of place. But I believe this is an area that we as water professionals haven't will be sustained. And flexibility and adaptability. Whenever we do something, we ought to think about not just the one way that we intend to use it now, but the different ways that it can be used into the future. We can build much more flexibility into our systems if we just think about it. So some final thoughts. My opportunity to share just a couple things with you. So I've said this already, but water stress is not inevitable. We create water stress because circumstances that we have going forward. So, and our circumstances are going to continue to change. So water management can and must adjust to provide reliable and resilient services to humanity and the environment. We need to be thinking about this journey and the direction that we're going. The great variety of circumstances that water management systems must adapt to. So we have, on this planet, we have such a wide but they're examples. We need to make this the norm. We need to be part of making this the norm. I didn't say much about it directly about industrial management and reuse. I want to say that everything I've said, which has been more focused, if you will, on the municipal side, it applies to industrial management as well. So, and resource recovery is progressing, but connections
Please remain on the stage. Thank you very much, Glenn, for that inspiring presentation and for sharing your vision with us today. Kindly accept this token of appreciation presented to you by the Saudi Water Authority to thank you for your rich participation. Thank you very much. With that, ladies and gentlemen, we conclude our agenda for day 2 of the IDWS. I would like to thank you all, our attendees, speakers, panelists, sponsors, partners, and all the participants for their invaluable contributions today. From groundbreaking innovations to transformative strategies, it's really clear, ladies and gentlemen, that the future of water sustainability is bright and is full of potential. We look forward to seeing you tomorrow for another exciting day for this remarkable conference. Thank you very much.